Hello everyone and welcome to SimpliCode's YouTube channel. I hope you guys are doing well. Today, we'll be taking you through the Advanced Java full course. This Java Advanced full course will cover several advanced level topics in Java. In this video, you will see the in-depth usage of Java and learn about all the concepts which are most essential for becoming a Java developer. By the end of this tutorial, you guys will be able to understand and deploy several projects using Java. But before we begin, let me tell you guys that we have regular updates on programming videos. So if you are a programmer and want to learn something new, then consider getting subscribed to our YouTube channel and press that bell icon to never miss any updates from SimpliCode. Let's go through the agenda for this full course tutorial. We'll start this video with method calling in Java, followed by exceptions, try-catch, and hashcode in Java. We'll then move on and cover topics like Java comparators, enumeration in Java, and annotation in Java. After that, we'll discuss topics like synchronization in Java, autoboxing in Java, input and output streams in Java, JDBC in Java, generics in Java, and Java string handling. We'll cover more advanced topics like util package in Java, networking in Java, images in Java, regular expression in Java, and Spring tutorial. We'll end this video by going through some projects using Spring Boot and Java. All the concepts we'll discuss in this tutorial are advanced level concepts. So if you are new to this channel, consider going through the last two Java courses for beginners and intermediate levels to better understand today's topics. You can find the links in the description below. Now we'll start with our first topic. Over to our training expert.
When it comes to defining the methods, I have been talking about methods throughout this particular series. And the syntax is pretty familiar, where you first specify the access modifier, then you specify the return type, then you specify the actual name of the method, and after that you specify all the arguments which this method is going to accept. And inside the curly braces, you do your calculation, and based on the return type, you return an appropriate value. We have seen many examples of it, and let me show you a quick example to just understand the method anatomy better, and then we will talk about how do we pass arguments to methods. So in this simple class student, I have some properties, I have constructor, and then I have methods. These all are also simply methods. You can see we have an access modifier, which will decide whether this particular method should be visible to the outside world or not. You can also either remove this particular access modifier or make the method private if you want, or you can also make the method protected if you want. So all of the possibilities are there, and what kind of access modifier will you keep depends upon your use case. So that is the access modifier. And then if your method is not supposed to return anything, then you would just say void. Void is the default keyword in Java, which is used for use cases when you do not want to return something. Void just means empty or nothing. So when you have nothing to return, you are going to put void. You cannot skip this. If you remove this, the method signature is not complete. So you have to provide this. There is no way around it. So you need to provide the method return type. After that, you provide the name of the method. This is a free text string, and you can name it whatever you want. Just follow the camel casing convention, where you start with a small alphabet, and for every new word in the method name, you start with the first letter as capital. After that, you put normal braces and you supply the arguments which this particular method is going to accept. For example, if this method was about calculating interest, then probably you might supply the interest rate as the argument and the principal as the argument. If this method was about calculating the price of the car, then you might supply all the different mileage details and the manufacturing details which would decide the price of the car. So it depends upon what you are doing, and that's how you will understand what kind of arguments your method is going to need. When you define the arguments, you need to define the data type of the argument, and again a name which you can give it as anything. This is again a free text string. And after that, it depends upon you what kind of logic you want to write inside the method. The basic need for writing a method is to not do the same thing again and again at every place. if you have a functionality, let's say if I take the same example, if you have to calculate interest and the interest calculation logic is required at, let's say, 15 different places in your application, then just create a single method for calculating the interest rate or the interest, and then just reuse that method again and again at different points in your application. Just call that method. That's how we use it. So that is the basic idea of creating a method to keep reusing the functionality over and over again across all the different methods in your application. Let's take another example of this particular method because it has a return statement. Again, I specify a public access modifier. I specify the return type, which is string in this case. Then I specify a name of the method, and I can also choose not to supply any argument if the method does not need any argument to do its computation or to run its logic. If you put a return type, any other return type, then void here, then you have to provide a return statement. The return statement will be the last execution step of your method. Remember that. The return statement will be the last execution step of your method execution. This has to be provided if you provide a return type other than void inside your method. In this particular case, this method expects a string return type, which means when I call getName, I should get a result back, which should be of type string. Then I need to write a return statement and return a variable which should be of string type. For example, if I just change this method to say, let's say if I say int I equal to 1, and if I say return I, this is going to give you an error. You see there's a compilation error, and if you hover over the balloon icon, it says cannot convert from int to string. It is trying to convert this particular return type and trying to match this into this particular return type, and it's not able to match int to string, so you get an error. So it has to exactly match the return type, the data type of the return value which you have put here. It has to match exactly with the return statement variable type. If it doesn't match, you're going to get a compilation error. That's the first thing. Now, there might be scenarios where you have multiple branches of execution in your method. For example, let's say if I just use this condition of I equal to 1 and I write if I equal to 1, then return, let's say, a test string, else return the name. I'll just cut this and put it here, and we'll change this to name. This is also possible. And this is possible because of the same statement which I told you earlier, that return statement has to be the last execution step of your method execution. In this particular method, there are two branches of execution. This is one branch and this is the other branch. At a particular time, either the if block or the else block is going to get executed. There would never be a case that both of the blocks get executed in the same execution cycle. It will always be either this block or this block. And that's why if you use these kind of statements, then you have to provide return type in each of the branches. You can also do something like this. Let's say if I say string return var equal to null, and then I say control C, control V, I assign test string to the return var, and then here also I assign name string to the return var, and at the end I say a single return, and I say return var. This is also fine because here I am just assigning different values in the if block and the else block, and then just returning the placeholder variable, which is also absolutely fine. So you can use either of the way. The better way is to return from within the branch itself. So this was a quick tour for you to see how methods work and what kind of anatomy method represent. Now let me just quickly revert everything which I did here and bring it back to return name. That's good. And now let's talk about the method calling patterns and how do we call the methods. So for that, I have prepared a class called method calling demo. It has a public static void main method. And here I have just declared a simple variable I and initialized the value of I as 1. Then I'm calling a method which is named as change value. And if you go to this particular method, it has a very simple implementation. It is accepting the argument which I created here. I'm passing this particular variable as an argument to this method, and then whatever argument I supply, I'm incrementing that argument by 1 and just return and not returning anything from here, just incrementing the value of I, and that's it. And after that I'm printing I. So what would be your guess here? What would be the value here? I'm going to pause here for a moment and to let you think about what is going to happen. Okay, I hope you would have done some calculations in your head to see what is going to happen and what is the value of I eventually at line 8. Let's run this program to understand that. Okay, so I had initialized I as 1, then I passed the value of I in this particular argument, and I said I equal to I plus 1. So it should be 1 plus 1 equal to 2, and the new value of I should be 2. But at line 8, I still get I as 1. Why is that happening? It's happening because of the concept of pass by value. Remember that concept that in Java, every argument which you pass to a method is passed by value and not by reference. In simple language, what does it mean is that when you pass this particular argument, a copy of this particular argument is a copy of this particular variable is passed to the method argument. It's not the exact same variable. We are not passing the same reference of I here. We are passing a copy of it, a unique local copy of it. That's why whatever you do with I inside this particular method is not going to change the state of I which is defined here, because it is passed by value, or in simple language, the object is copied over locally to the method. It's not the same reference which is being passed upon. That's why you see this value. If you want to get the return value, then the one way is to just change the return type and say return I, and then just store this return I value here, saying int result equal to whatever is returned from here, and we are returning the new I here. And then you can print the result and you will get 2. If I run this now, I get I as 2. So this is just to validate that this is everything in Java is passed by value. There is no concept of pass by reference when we talk about method calling in Java. Let's take a more complicated example. This was a simple variable. Let's go back to the student.java. So I have the student class here. Let's create some objects of it and try to follow the same pattern. So here I have created an object of the student class named John, age 25, address 23 East California. I'm doing some sysouts which are not really important here, but let me just uncomment this particular method. So here what I'm doing is I'm calling a method. I'm basically defining a method which says change name in the same object, and I'm supplying the student object. So the student object gets here, and then I'm overwriting the name in the student object. That's what I'm doing here. So now let's just call this particular method and see what happens. So I'm going to call this particular method here and pass the object John inside it. And then let's try to print the name of the object referenced by John. If I say get name. So I'm calling this particular method, passing the John object here, where I'm overwriting the name John with Jane, and then I'm printing the new name of the John object. Let's see what happens now. So if I run this particular program, yes, I can see that the name has been overwritten from John to Jane now. This happened because you passed the reference pointed to the object inside the method, and then you overwrote the name on the object which was pointed by this particular reference. So here you might think that this is passed by reference, but this is still passed by value, because this reference is not the same reference as this one. This is a different reference, but both references are pointing to the same object. That is the only commonality here. So you can mutate a particular object inside a method, and be very careful of that. Do not ever try to do that, because it is going to create a lot of unpredictable results for you, because it might be possible that you're calling a particular method from some other application which is doing a lot of changes in the same argument object which you supplied, and then you don't know what is the state of it. So it's a very dangerous pattern and very dangerous way to mutate the objects. Do not do this. Let's find another way to deal with this problem. If I don't want to mutate the same object, how do I solve that problem? So we can solve that problem simply by creating a new object and changing whatever we want to change. So I have one more method here which says change name in a different object. It is also accepting the student object, and then here it is creating a new student object. And here it is overwriting the name, but getting the age and the address as the same values from the argument. So we keep the age and the address same, but we create a new name, but we don't overwrite the same object. We create a new object, and then we can return this particular new object if we want to. I can do clear this, and I can say return new student, and then I can store the value of this particular method calling I can call this method here, supply the same argument as John. Let me comment this one. And then I can store the value of the result, student result obj, and I get the value here, and then I can say result obj.getName. And if I run this program now, remember I'm calling a different method now, which is going to create a new object and then change the value. I do get the same effect, but now my previous object John is not touched at all. It is safe and sound. I can reuse this John object anywhere in my method, in my application, and I can be assured that nothing is changing in terms of the state of the object. So always follow this particular pattern whenever you are calling methods and passing arguments to the method. And if those arguments happen to be your custom classes and even Java classes, in fact, then always try to create a new copy of the object inside the method if you intend to mutate or change the state of the object. Now this session is getting a bit longer, so I would just like to stop it here. And in the next session, we are going to talk about exceptions in Java. Let's first understand what are exceptions and why do we actually need this concept. The simple reason for having exceptions existence is that developers make mistake. We do create bugs and errors while we write code. It's natural. It always happens that whenever you write code, you might miss out some condition or the other, which creates a bug in the application, which creates a defect in the application, and then the testing team finds that defect and then we fix that defect. And that's how a normal software development lifecycle works. So to handle those kind of exceptions and errors, every programming language provides their own exception and error framework to support the developer in spotting those errors and fixing those errors and handling those errors instead. And Java also provides its own exception framework. So what you see on the screen right now is basically a snapshot of the exception framework of Java. And you see it has a long hierarchy of different classes here. This is also an inheritance hierarchy, just to give you context. And the whole exception framework hierarchy starts with a class called throwable. So throwable is the class which is the root or the parent class of handling all types of exceptions and errors. And that's where the next differentiation comes, exceptions and errors. Java treats these two things differently. And I will go in detail as to what is an exception and what is an error. But let's first understand the hierarchy further. Under the exception hierarchy, you see some exceptions like IO exceptions, which is an exception which comes when something goes wrong in the file writing or file reading or the file handling operations. Then you have SQL exception, which comes whenever you are talking to the database, writing SQL queries and something goes wrong. You also have class not found exception, which comes when a class is not found in the runtime or at the time when the class is being loaded in the JVM. And then you have also runtime exceptions, which are like arithmetic, number format, and there are lots more of this type of exceptions as well. On the right hand side, you have the error type, and then you have some errors like JVM error, memory error, and framework error. So now coming to the differentiation between exception and error. Exception is a type of problem which can be recovered in a program, from which the program can be recovered, which the developers should handle. So exception is a type where the developer focus is. The developer is responsible to make sure that none of these exceptions occur in the program. And if these exceptions occur in the program, then the developer has the responsibility to handle these exceptions properly. We will look at the examples of how the developer can handle these exceptions. On the right-hand side is the error type, where the developer does not have any control. You cannot do anything if the JVM has an error, or if the underlying memory of the computer or the JVM memory gets an error, or the whole framework or the Java itself, library itself has an error. You can't do anything about that. And those are the kind of problems which go into the category of error. That's why Java has created these two different categories. One is exceptions, which is the responsibility of the developer, and other is error, which are not the responsibility of the developer. And in fact, developer cannot do anything if this happens. So this was a quick tour to you to what kind of the exception framework is present in Java. Do read about this framework in detail in the Java docs as well. But just to extend this understanding further, we'll have a look at some examples of the exceptions and how these exceptions occur. So with that, I'm going to switch to the Eclipse IDE, and I have created a bunch of classes to show different types of exceptions. So let's go through the first class, which is named as simple exception demo. It has a main method. It has a variable of int type. The variable name is data. And what I'm doing here is I'm dividing 100 by 0. So if you see this carefully, you know that this is going to result in an infinite value. You cannot divide any number by 0. And Java also prohibits doing the same because it doesn't make sense to divide anything by 0. So if you run this particular line, if you execute this particular line, this is going to throw a runtime exception. These are the runtime exceptions, remember. So let's try to comment rest of the code and let's quickly try to run this. So I run this program and there you go. I get an exception which says exception in the thread main. Main is the main thread. Which the exception type is java.lang.arithmetic exception. And this is the exception type, divide by 0. And it will also give you the line number at which the exception happens. If you click on this, it will directly take you to the exact line at which the exception happened. And this is, if you see now, this helps the developer a lot. This information which is printed here is called exception stack trace. And you can look at the stack trace, go to the last line, and this would be the line from where the exception actually originated. If you click on that particular line, it will take you exactly at the place where the exception might have occurred. And then you can look at the line, fix the code, and rerun the program to see if the exception is gone. That's why I said that developer has to handle this exception. Now, as far as handling these exceptions is concerned, I'm going to cover that in the next session. But in this particular session, we are just going to focus on the types of exceptions and how they occur. This was an example of arithmetic exception where we are trying to divide something by 0. Let's take another example. Let me uncomment this particular line of code and comment back this one. So here I am creating a string A, but the string is null, and null means nothing. It's a void reference. It has nothing in it. And now if I try to do some operation on this particular string, so remember A is null, and whenever you are trying to operate something on a null object, Java is going to throw an exception because you can't operate on null because null means nothing, empty. It is a dummy thing. So you cannot do anything on this particular null reference. And if I run this program, I get an exception which says null pointer exception, java.lang.null pointer exception, and it will give you the exact reason. Cannot invoke string.char at int string dot, this is a string type, string.char at int because A is null. So it will give you the exact reason as to why this program failed. And then again, if you click on this particular line, it will take you the exact line where the problem is, and then you can fix the problem. Maybe you need to initialize the string properly to make sure that this error doesn't occur. So these are all the runtime exceptions which the developer has to take care of, which the developer has to fix to make sure that the program runs smoothly. If they don't handle it, the program is going to fail, and the program will actually force them to fix because the program will not run unless they fix those exceptions. Now, these are the examples of runtime exceptions. You can also create these kind of exceptions, which are called checked exceptions. Runtime exceptions are also called unchecked exceptions. You might hear this term as well. Some people use the term runtime exception instead of unchecked exception and use both of them interchangeably. So runtime exceptions are also called unchecked exceptions, and these exceptions are called checked exceptions. Why do we call them checked and unchecked? Is because these exceptions are something which you do not have to explicitly specify in your program. In this program, I did not have to explicitly specify this particular because I don't know if this line of code is going to result into a null pointer exception or not. But these exceptions are something which Java will force you to handle. Let's look at an example of this. So I have created one more class which is named as checked exception demo, and I'm doing some file operations, basically reading a file, writing to a file, etc. I'm using some classes of Java named as file reader and some methods like readLine and close. And if you see, the moment I'm trying to read a file, this line has a red marker. There's a compilation error. If you scroll over it, it says unhandled exception type file not found exception. So Java is forcing you to handle this particular exception because file not found is a checked exception. So if your expression, your line of code is throwing a checked exception, then Java will force you to do something about it. It will not compile the code until you either handle this exception or you rethrow this exception. Again, how do we handle this is something which we will cover in the next session. But you can always rethrow this exception, but you have to do something about it. You cannot just skip it. So what I can do if I don't want to handle this is I will pass on the responsibility of handling this exception to the callee program. So whoever is going to call this main method has the responsibility now to handle the file not found exception, because I've just thrown it. I've just passed it on. I've just passed my responsibility to the callee. And you can do similar thing here as well. If I go here, you see it says unhandled type exception, IO exception. And if you remember, IO exception is here. It is a checked exception. So I can do one more throws here, comma V. And now if I just resolve the import, whoever is calling the main method has the responsibility of handling the file not found or IO exception. You can also handle it like I said, or you can just add throws clause to the method signature, and then the caller has the responsibility to fix or handle the exception. So this is how the checked exceptions work. Remember, in the unchecked exception, in the runtime exception, we can see that these two lines do throw exceptions, but there is no forced way by Java to tell us that I have to fix it, because Java doesn't care about unchecked exceptions at the compile time. It will only encounter those runtime exceptions at the runtime. That's why they're called runtime exceptions. But checked exceptions are compile time exceptions, and you have to fix them, handle them, or throw them right at the time of compiling the code. So that was about checked exception. Now there's also a possibility that you can create your own exception if you want to. So for that, I've just created a very simple class here called myException. And the way you create your own custom exception is by just extending your class with exception class. You just write this extends exception, and you can write a default constructor or a parameterized constructor, whichever makes sense for you. And this is your exception class ready to use. And you can just invoke this exception explicitly. Remember, whenever you are creating your custom exception, it is by default a checked exception. So your program has to handle it. For example, if I go back to this particular class, and if I do this, let me just comment all of this code now and remove the throws clause as well. So if I go here and I'm saying throw new myException. MyException was my class. So I'm explicitly throwing an exception, which was my custom exception. And I again get the error. If I hover over it, it says unhandled exception type myException. So I have to handle this exception, or I can just throw this exception and let the caller handle it. So this also works. So this basically builds our understanding that broadly there are three different types of exceptions which we work with. There is a runtime exception, which is also called unchecked exception, which happens because of developers' mistakes in the program, like this one. Then there is a checked exception, which developer might not be responsible for creating the exception, but developer has to handle it. And there are some classes in Java which throw those checked exceptions, like file not found exception and IO exception. Whenever you are working with file handling operations, Java will force you to handle those checked exceptions or rethrow those checked exception using the throws clause. Similarly, the third type is when you create your custom exception type, and custom exception types are also checked exceptions by default. And whenever you are explicitly throwing your own custom exceptions, you again have to either handle the exception within your enclosing code, or you can just rethrow the exception and let the caller handle it. So this is a quick tour of different types of exception and including this exception hierarchy. In the next session, we are going to talk about the try-catch scenario, and we'll see how we can handle these exceptions. So in the previous session, we had a look at the scenarios where an exception can occur. How do we see that there's a runtime exception, or there's a checked exception, or there's an unchecked exception, or there is a custom exception. Now, we did not talk about how to handle those exceptions. And now we are going to focus on the handling part. So whenever you have to handle those exceptions, the way Java provides for that is using the try-catch block. So try-catch block is basically a bunch of syntax which you have to follow to handle different types of exceptions in your programming code. And the syntax of the try-catch block is pretty straightforward. You write try and you put curly braces, and then you write whatever code which might throw an exception. You don't know that, but it's always safer to enclose your code in a try-catch block so that you know that if an exception occurs in the try block, then you can handle it in the catch block. So it's always considered a better practice to and close your application code in a try catch block so that you can handle the exceptions. So you put this try block and write all the suspicious or non-suspicious code which may or may not throw an exception inside the try block. Once you have done the try block part, then comes the catch block part. So let me go to the catch block. So this is how the syntax look like. Once you have written the try block, then you write catch and you put braces and you write the exception type which this block of code might throw, or the exception type which you are interested in catching. You might not be interested in catching all the different exceptions, but only a few ones based on your business requirements. So whatever exception type you want to catch, you are going to catch it like this. And if an exception occurs in the try code, let's say you have specified an arithmetic exception here, and if any line of code in the try block throws an arithmetic exception, then this catch block is going to catch that exception. And then inside these curly braces, you can decide what to do with that exception, whether you want to log that exception or whether you want to rethrow that exception, whether you want to embed some error code or get an error code out of it, or convert that exception into a business or custom exception of your own choice. So it's up to you what you want to do with that. But catch block will be able to catch that arithmetic exception. Similarly, you can specify as many exception types to be caught as you want and keep adding more and more catch blocks. Remember that these catch blocks work in a sequential fashion. So if an exception occurs here, it will first go to this particular block to match the exception type. If it didn't match, then only it will move to the second type. If it did match the first type, it is not going to execute the second type. So that is how the try catch block work. You can see an example here that if the code here is throwing an index out of bound exception, then it is going to be caught here. And we are just printing the index out of bound exceptions message. If it is throwing an IO exception, then I can do this. So you can keep adding different checked and unchecked exceptions in the catch block. You can also catch more than one type of exception with one exception handler. So rather than writing these multiple catch blocks individually, you can combine these exceptions together if your logic of processing both of these exceptions is the same. Remember, if the logic of processing these two exceptions is the same, logic means whatever you write inside these curly braces. So if that code is going to be the same for both of these exceptions, then why bother writing two catch blocks? Just write one catch block like this. Use the pipe operator to separate different types of exceptions and write the common code which is going to be applied if your try block is going to throw an IO exception or an SQL exception. So that depends upon you. That's the second piece. The third piece of the try block is the finally block. So we talked about the try block, we talked about the catch block. Now there's a finally block as well. Remember, this is finally and not final. The finally block is used together with the try catch block when you want to perform some cleanup operations. Imagine you are opening up a file handler in the try block, you're doing something with it, and then you want to just close the file handler irrespective of the fact if there was an exception in the try block or not. Because even if there was an exception, the file handler resource is going to remain open and is going to consume memory in your application. You don't want to do that. Similarly, if you opened a database connection inside your try block, irrespective of the fact of what happens in the try block, you always would like to close the database connection. And you can write that closing code in the finally block. That's the purpose of the finally block, that you can write the code inside the finally block, which is supposed to be always executed irrespective of the fact whether an exception occurs or doesn't occur. So now we have built a good understanding of what is the try catch, what is the try block, catch block, and the finally block. Now, if you just put it all together, this is how it is going to look like. That you write the try block, you do something inside the try block, then you write the catch blocks. After that, you write the finally block. You can write the finally block without the catch block as well. Remember that. If you do not have any exception to catch, but you have some resources to close or free up after executing the try block, you can skip the catch block and just write try finally. That is also possible. With that understanding, let's switch to the IDE and let's look at some example. So I have a writer helper class, which is having a method called writeList. I have a try block here, and this try block is basically initializing an array list, adding an item to the array list, and then I'm accessing list.get1. Remember when I added this particular value, let me make it 10 to make it more understandable. When I added 10 to this particular list, this goes to the index 0 position. And here I'm trying to access index 1 position, which does not have anything. So in such case, it might throw an error because there's nothing at list.get1. So this is my method where I put the try block code. And then because I don't want to end up in a position where I get an index out of bound exception. Index out of bounds exception comes if you are trying to access an index which is illegal, which does not having any value. So I'm putting a catch block and catching the index out of bound exception and just printing the message of the exception. And then for simplicity, I'm showing a finally block as well. Though I do not have any resource to close here, but this is just to show you how this looks like in the code. This is just to show you that I'm printing a sys out here. This is what my method is. And if I go to the main class, the try catch demo class, I'm creating an object of the writer helper class and calling the write list method, which we just walked through. Let's run this program and see what happens. Okay, so first I get this statement saying entering try statement. So if I go here, I call this method, the execution goes inside the try block and I get this sysout, which says entering try statement. Then I try to access the second element in the list because the position is 1. This is going to index 0 and I'm trying to access index 1. There is nothing at index 1. So I get an error saying index out of bounds exception, index 1 out of bounds for length 1. Because the total length of the list currently is 1 because there's just one element and that one element is sitting at 0 and not 1. So I get the exception, which is the index out of bound exception, but the index out of bound exception is caught by my catch block and the system.error.println is something which gets executed and I get this particular line from this line number 17. And then irrespective of the fact whether an exception occurred or not, my finally block always gets executed. Let's fix this and see if the finally block gets executed even if there is no exception. So now I'm accessing get 0 and let's see what happens. Yep, I access the element 10, no exception, but the finally block still gets executed. So this is to assert our understanding that the finally block will always be executed irrespective of the fact whether there was an exception or there wasn't. Now you can also nest different try blocks if you want to. Let's look at an example where I have multiple try blocks. So you can write a try within a try within a try if you want, and you can go as deep as you want. But remember, the more indentations, the more hierarchy you create, the program is going to get more and more complex. So always remember to have that kind of trade-off. So I write multiple try blocks, I initialize an array, I print array 10. Obviously, array 10 does not exist because this array has just 4 elements. So this is bound to throw an index out of bound exception, and I'm catching that exception immediately in the catch block. This is the exception, printing a sysout and just rethrowing the exception. You can also rethrow the exception by just using the throw keyword. Remember, this throw is different from the throws keyword, which comes in the method signature. This is just to throw any exception from your code. So this is array index out of bound exception for this try block. Then I have another array index out of bound exception for this try block, which starts from here, block 2. And then I have another catch block for the block 1 try block. So you can see it is already getting a bit complicated where I have multiple hierarchies, but you can do that. So this is what is happening in this particular program. Now let's try to run this and see what happens and try to decipher the output. Okay, so at first I get this particular line which says array index out of bounds exception in block 3. What happens here is that this line gets executed. It throws an array index out of bounds exception. At line 13, that array index out of bounds exception is caught, which was generated from this line. And then we go inside the catch block. We execute this sysout. This is what you see here, the same sysout. And then we rethrow the exception. If we rethrow the exception goes to the enclosing try block. The enclosing try block is this one. There was an exception rethrown from this try block, and now it has gone to this try block. And now this try block, block 2, will try to see if it can catch this array index out of bound exception. Yes, we can catch it. So it can. So the block 2 again has a catch block which catches the array index out of bound, and it prints a sysout here which says exception in block 2, which we see here. And it again rethrows the exception. And if it rethrows the exception, so now the block 2 is rethrowing the exception. So this whole code is now rethrowing the exception. If this block 2 is rethrowing the exception, it goes to block 1, just going one hierarchy up. And then it sees if it can handle the exception in the catch block of this block 1. So yes, the block 1 try block also had a catch exception which said array index out of bound E4, and here it just had a sysout. So if I just bring back the output, yes, we do get this particular exception printed here, which says array index out of bounds exception in block 1. This is what you see here. And this is where the exception just stops going propagated, because I'm not rethrowing the exception from this particular catch block. So that's where the exception ends. The reason you see a hyperlink here is because the text which I have printed here exactly matches with the name of the exception. So Java is pretty smart in that case. If you use the exact same name exception, it will link it to the matching class name in Java, which is pretty cool. I also have a redundant catch block here, which does not have a try block. This is just to show you that you can write a catch block without a try block, but it doesn't make sense. It is of no use. So I can just remove this particular catch block and the program still will compile fine. So this was a quick demo to show you how you can use try, catch, and finally blocks. And when would you use the finally block? And if you want, you can use a nested hierarchy of try blocks, and you can rethrow the exception from within the catch block only to be caught in the outside or the outer or the enclosing block. So this is all I want to cover in this particular session. And in the next session, we are going to talk about one of my most favorite concepts in Java, which is about equals and hashcode. To understand why we need equals and hashcode and what equals and hashcode is all about, let's first understand the object class of Java. Remember, I'm calling it an object class and not just an object. Object is a class as well in Java, and it is the super class of any class you create in Java. So anything you do in Java, any class you create, it will automatically be inherited by the object class. Object class is the super class of any class created in Java. And if you look at this documentation, and if you come here, you will see that object class defines this equals method, which indicates whether some other object is equal to this one or not. And it also defines a hashcode method, which returns a hashcode value for the object. So let's understand both of them one by one. First of all, let's establish that these methods have their concrete implementations available inside the object class. But how do you do that, and how does it come into effect? Remember when we talked about hash set, and I said that hash set will maintain uniqueness automatically. How does it maintain uniqueness automatically? It is because of the equals method implementation, which it inherits from the object class. That's how it maintains uniqueness. And if you remember, I also told that you can maintain uniqueness in a hash set if it's a built-in data type like integer or string or float or double, etc. But what if you are trying to create a hash set of student objects? Then Java does not know how to perform equality on two student objects, because student is a custom object. Java doesn't know how to run equality. And that's where equals and hashcode comes into picture. So the contract is that whenever you are creating your own custom objects and you have a need to perform equality on those objects, you must override the equals method in your own class. You have to override that. If you do not override that, then two student objects will be compared based on the reference and not based on the actual object values. We will see all of that with the help of an example. Another thing which says that whenever you are overriding equals, you should also override hashcode method. Reason is because hashcode is also used in certain collections, and we will cover that in a while. But let's just focus on equals first. And let me switch back to the Eclipse IDE, where I have a student class. Again, it's a very familiar class which we have covered in other lectures as well. And I have three different properties here: roll number, name, and address. I have a constructor, and I have setters and getters. Now, if I go here and I create three different objects of the student class, you see I have created three different objects. This student object has a roll number 1, name John, and the address is the same one. Second object has a roll number 2 and the name John, and the address is the same as this one. And third one again has a different roll number, but the name and address is the same. It's a hypothetical situation. So let's do one thing. Let's make this roll number as 1 as well. So now these two student objects are exactly identical. So what happens if I compare John with John 2? By looking at naked eyes, these two objects look exactly the same. So John equals John 2 should return true. Let's run this program, but we get false. The reason we get false is because the default implementation of equals is being run on comparing the student objects, because Java still does not know how to equate these two objects. Why you are getting false? Because these two are different references. Java created a new memory location somewhere and put this object, created a reference John to it. Then Java created one more new object in this line and created a new reference John to. So these two different references are pointing to two different memory locations of the objects. Though their internal values are same, but their memory locations are different. That's why you get this particular value as false, because these are pointing to two different memory locations. And that brings me to the hashcode contract. You need to override the hashcode contract as well, along with the equals, to make sure that your equality runs perfectly. Let's go back to the student class and let's fix this problem, because we can see that these are identical objects. You don't want to store the same student twice in your database, right? So you need to fix this. So I go back to the student.java and I have commented this equals method, and let me uncomment this now. So what I do, that I override the equals method, and the equals method contract looks like this, where you supply an object which is a foreign object, and now you need to compare this foreign object with your current object of the student class, which is this. So at first you need to run this particular condition, which says, are these two objects, these two references, this reference and the obj reference, pointing to the same object? If they're pointing to the same object, then this will return true, and then we will say that the object is that equality holds true, because both are pointing to the same object. So obj equals this. If that doesn't hold true, if this doesn't hold true, then it moves on to line 50 and it runs a condition saying that is obj null, or obj.get class is not equal to this .get class. Get class is a method which will tell you the class type. Here we are checking, is the obj class object is of the type student or not. If it's of different type, let's say vehicle or something, then definitely they will not be equal, and we can directly return false. So that's why I'm checking that it should not be null, or the class types should be matching. If these two conditions are, if either of these conditions are holding true, then I return false and I say that objects are not equal. So I've covered this condition where both of the references are pointing to the same object. I covered this condition where the class types were not matching or the obj itself was null. Then we return false. If we've passed all of these sanity checks, then we do the actual comparison. Before doing the actual comparison, I need to do this explicit casting. So I cast the obj object into the student type. If you remember, this is how we did the casting for other data types as well. Once you have converted this obj into the student object, then you need to define your own business logic based on which you are going to define uniqueness. So how are you going to uniquely identify a student in your application will govern this logic. In this particular example, I'm saying that I am going to identify a unique student based on its roll number. So even if two students have exact same matching details, but if their roll numbers are different, then these are two different objects for me. But if two objects are having the same roll number, and even if they have a different name and address, I'm going to say that those two objects are duplicate. So roll number is the condition on which I'm defining uniqueness, equality, and duplicity. So I define this and say if the roll numbers are equal, then the object is equal. Objects are same basically, or duplicate. And if the roll numbers are different, then these two are different objects. Good so far. Coming back to the main class. So now I have the same roll number here. Let me change the name just for fun, and address as well. So I have a different name and a different address, but the roll number is exactly the same. Remember, we have defined the equality condition based on the roll number. And here we are comparing if John is equal to John 2 or not. So let's run this program. Now I get true. The reason I get true is because this equals method is used to run this equals comparison. So this establishes how we can use the equals contract to maintain uniqueness. Now I also said that whenever you are defining the equals method, you also have to override the hashcode method. And to understand why do we need hashcode as well, let's go back to how hash map works. Remember, in the hash map, or let's say even hash set, in the hash set, you have to maintain uniqueness. Now Java maintains uniqueness using both equals and hashcode. Hashcode is nothing but a memory bucket in Java's memory where your object is stored. It's basically a memory location. So every object has a hashcode, And that hash code is the actual memory footprint where the object is stored. And whenever you're dealing with hash set or hash maps, you will be required to override both of these methods. Let's understand how this works. So if you have a hash set and you are trying to insert an element, then first Java will use your equals method definition to check if an object similar to the object being inserted is already present in the hash set or not. If it finds an object, it will basically flag that this is a duplicate object and it will not insert it. Let's understand how an object is fetched from a hash set. Let me open a hash set example just to give you some sort of a visual representation of what I'm talking about. So if I go to my hash set example in the collections package somewhere, and let's open a hash set demo class. Yeah. So when we were doing these insertions, though this was a string object, so it was the Java already knew how to use the equals and hash code of it. But if it was a student object and you were doing multiple add, and then when you were actually fetching the element or you were doing the contains, then how does it work is basically first it is going to calculate the hash code of the object. Let's say you are saying hash set.get b or hash set.get John1. Then it is going to calculate the hash code of your John1 object. Hash code is a memory footprint, and hash code, and the way it is going to calculate the hash code is going to be based on the definition which you have provided. So the definition which you have provided, this hash code will be run to calculate the memory footprint, and then that particular Java will go to that particular memory footprint and see if there is an object present there or not. Now Java has a memory location, right? And there can be multiple objects stored at that particular memory location. This is possible in Java. So if there are multiple objects present in that particular memory location, which was calculated based on your hash code implementation, then Java is going to run the equals method to find the exact matching object. So just to try to visualize this, if I try to visualize this, let's say you have this memory locations, and let's say your hash code came up to memory location 2. And then at 2 memory location, you had multiple objects, obj1, obj2, obj3, etc. This is possible. Multiple objects can point to the same memory location. So if this happens, then Java is going to use the equals contract to compare your John1 object with obj1, with obj2, and with obj3. This is where the equals will come into use. So you see that both hash code and equals are being used here to point to the right memory location. And that's why I said that hash set and hash maps are where equals and hash code will come in full force, where you will be required to implement this. And it's a good practice to always override the equals and hash code in your application whenever you are creating classes. The reason is that you don't know when and where these classes will be stored into a hash set collection or a hash map collection. So it's always a good idea to have equals and hash code being implemented. And when you implement hash code, the thumb rule is that you should use the same parameters which have been used in the equals contract in the hash code contract as well. The reason for that is, what if you used here, let's say you used name here and you used roll number here, then two different properties are being used to find memory location and the uniqueness. And remember this logic which I just gave you. Here both hash code and equals are working together to find the right object. So if you make any mistakes in defining the equals and hash code, or if you made any mistake in defining the symmetry between equals and hash code, then you may get unpredictable results. How you define your hash code? Up to you. But make sure to use the same properties which you have used to define the equality. Always keep this consistent to avoid any unexpected results. You can also do this, just say return 1. And what will happen that when you use this particular student class in a hash set, all the objects are going to be stored at a single memory location. And then this particular situation will occur where you will have a single memory location and all of your objects will be present at that memory location. And when you are trying to fetch anything, the hash code will always point to the same memory location, and then equals will make sure to find out the right object you are trying to fetch from the hash set. So this is all about equals and hash code, which I wanted to cover in this particular lecture. Do read about this in detail. There are tons of articles available on this particular concept because this is a very important and popular concept, both from implementation perspective and from interview perspective. And that's all we are going to cover in this particular session. In the next session, we are going to talk about another very interesting concept, which is comparable in Java. So the basic idea is that you want to sort your collection, and to do that, Java provides you with a method called collections.sort. You just supply your list or your collection inside this sort method, and all the elements or objects inside your collection will be sorted based on the natural sorted ordering. This holds true for built-in data types, but what if your list is of type student objects? Then again, the same constraint applies that Java does not know how to sort student objects. It knows how to sort strings and ints and floats and doubles because those are built-in data types, but student is a custom type and Java doesn't know how to sort it. And to solve that problem, Java provides an interface called comparable. So comparable is the interface which you need to implement from your class whenever you have a need to sort your objects or of your class type. So this is the interface which your class needs to implement. This interface provides a single method which says compare to, and it provides the foreign object, and then you need to compare this foreign object with your current object. So let's go back to the Java class and understand how do we work with this comparable interface. So again, I have used the student class for the sake of continuity, and I have the same properties as roll number, name, and age. But this time I say implements comparable of type student. This is a generics type. We will be covering generics in a bit more detail in this whole series. But the basic idea is that you define that this comparable interface will only work for student types. You define the type in this particular construct, which we also call as generic type. So you do this, and the moment you do this, Java will force you to provide the implementation of the compare to method, which I have provided here. So the way this implementation works is you have a foreign object here, but this time this foreign object, since I have defined this as of type student, so the moment you do this, Java will ask you to override this method, and using Eclipse IDE, if you override this, then you will get this signature automatically. Let me show you this how this works. So if you do this, you will get an error here. And if you click on this balloon, it will say add unimplemented methods. If you double click on this, you will see a compare to implementation here. And this is exactly the skeleton which you see here. By default, it says return 0, but I'll just come back to that in a while. So this is how this method came up here. And once you have this signature available, then you need to provide your implementation on how do you want to sort the objects. Remember, you need to define your logic here. So again, I would like to sort my students based on the roll number, which is the natural sorting order for me for the student objects. So this is your custom sorting logic, which you can call as natural custom logic sorting order for your student objects. So I want to sort them based on roll number. But you see, I've done a strange thing here. I've done a minus here. So what I'm doing is that the current object's roll number minus the foreign object's roll number. So if this value comes as a positive number, then this object is going to take priority. This is going to be sitting before the student. If this result returns in a negative value, then this object will come first and this will come second. So the student object will come first and this object, the current object, will come second. And if this returns 0, then it means both of the objects deserve the same priority or the same order priority, and any one of them can come after the other. So the basic idea is that if this results in greater than 0, then the current object is going to take precedence. If this is going to return in a negative value, then the foreign object which you're supplying here is going to take precedence. And if this returns in 0, then any one of them can take precedence. So you need to define your compare to logic in the compare to override implementation. Once you have done that, let's understand this with the help of an example. I've created a comparable demo class which has a public static void main method, and I create an array list and I create 3 different student objects. First student object is named as John, second is Jane, and third is Tom. The first has a roll number of 3. So John has a roll number of 3, Jane has a roll number of 1, and Tom has a roll number of 2. So if my compare to logic runs perfectly, then Jane should be coming first after I sort this collection, after I add these 3 elements into my list. And once I sort this collection, then Jane should come first, Tom should come second, and John should come third, based on my natural ordering custom logic, which I have implemented in the compare to method. And that's what I'm doing here. After I've sorted the list, I'm just printing the list by using the for each construct of the streams API. I'm just printing the name to see which one comes first and which one comes second. So let's run this program. And this is how it looks like. So Jane comes first because she had a roll number 1. Tom came second because he had a roll number 2. And John came third because his roll number was 3. So no matter how many times you run this program, you're going to get the collection in the same sorted sequence. And this is happening because of the compare to implementation which you provided here. Now, if you comment this implementation, let's see what happens. And I remove this implements comparable as well from here. I just create a simple student class and now I try to run this sort. Now you see that you get an error here. And if you hover over this balloon, it says that the method sort in the type collection is not applicable to the argument array list of student. Java does not know how to sort this. So it will force you to provide a sorted implementation. And the moment you provide comparable implementation here, and if you go back to the main class, the error is gone. So this also will force you to provide your comparable implementation. Now you can use this sorting for any kind of collection sorting as well. And whenever you are doing this, always make sure to provide the compare to implementation. And remember that contract which I gave you about greater than 0, less than 0, and equal. And that's all I'm going to cover in this particular session. And in the next session, we are going to talk about one more way of sorting collections, which is using comparators in Java. In the previous session, we talked about comparable, where we said that whenever we want to implement a naturally occurring sorting order, where you just say collection.sort and you sit back and relax, if you have provided the compare to implementation, you would expect things to work. But what if you have a custom sorting requirement? Let's take a hypothetical scenario where you created an application and your application has a student object and you created a collection of student objects, and now you have different consumer applications. Let's say you have a payroll application, you have an attendance system, you have an examination system, you have another extracurricular activity system, and all of them want to get the student collection, but all of them have different sorting requirements. Payroll wants to have the sorting based on the roll number. Attendance want to have the sorting on some other mechanism. Extracurricular application want to have the sorting on some other mechanism. So how do you implement custom sorting or multiple sorting logics for your collection? And that's where comparators comes into picture. Comparator is again an interface, as you can see here in the signature. And this interface provides you the flexibility to define your own custom sorting logic multiple times. So you can create multiple comparator implementations, and each comparator implementation will focus on a particular sorting order. So that's the basic need of sorting. So remember, whenever you want to sort the object in an order other than natural ordering, or you want to sort some object that don't implement comparable. So whenever you have these kind of conditions, always think of comparator. Apart from that, always think of comparator when you have to provide multiple sorting implementations on the same collection. So let's see how can we do that with the help of an example. So here again, I have the same student class and I have the same properties. Currently, by default, I have provided a comparable student implementation, which is exactly the same as we covered in the last session. And if we use this particular implementation, we create an array list, we created multiple student objects, we added them to the list, and we called sort. So what happens if I just comment the new code, and if I just run this particular code, remember the sorting is happening on the roll number. So here, roll number 1, Jane will come first, roll number 2, Tom will come second, and roll number 3, John will come third. But then you had one more application which wanted to have the sorting based on the age of the student. So these are the age values of the students, and some application wants you to provide the sorting implementation for the age. Now, age is a custom sorting logic which you need to provide. And whenever you have that kind of situation, create a comparator. How do you create a comparator? Like this. Simply create a class, name your comparator anything, try to end it with the suffix comparator so that you know that this is a comparator implementation. And then you say implements comparator of the class type. This is what you need to do. And the moment you do this, it will force you to override this compare method. Remember, the comparable interface provided compare to method where you supplied just the foreign object. Its name was compare to with single object. In comparator, the name is just compare, and you have two objects here. student 1 and student 2. Let me just call them student 1 and student 2 for simplicity. O1 and O2 look a bit weird. So I've just refactored this one and I will refactor this one as well. So I have student 1 and student 2, and this is an age comparator. So I want to apply the sorting logic based on age. Simply put, whoever is younger should come first, and whoever is older should come later in the collection once I sort it. So let's see how this sorting logic is implemented. This is a single line code, so let me just put braces around it so that it's more easily readable. You can write it without braces as well if you have a single statement inside the if block or else block, but you can always write it like this. And let me just format this as well. Okay, so this is the compare implementation. The first logic which I've run which says that if the first student's age is less than the second student's age, then return -1. Similarly, if the first student's age is greater than the second student age, then return +1. And if both of the students' age are same, then return 0. So this is your custom logic, and this is where you need to define your logic. And remember, this will also govern whether the sorting is going to be ascending or descending. So for example, if you have provided that student 1's age is less than student 2's age, then return -1, then this is going to maintain the natural sorting or the ascending order sorting. Now, if you want to have a descending order sorting, just change these values, saying that if this is less, then return 1, and if it is greater, then return -1. And this is going to run the sorting in a descending order fashion now. So it depends upon what kind of sorting order you want, and based on that, you can define the values. But the default is always like this, that whenever the first object's value is less than the second object value, return -1. And if the first object's value is greater than the second object's value, then return +1, otherwise return 0. -1 means this one will get precedence over this one. So this is how you have provided your age comparator. Going back to the main class and uncommenting the other part of the code, here I have called the sort method where I want to sort the list, but since I want to supply a custom sorting operator or a custom sorting comparator here, I need to provide that comparator object here. So remember the age comparator which you created here, you just need to provide the comparator. You need to tell Java how to sort this particular list. If you do not tell Java how to sort this, Java is going to look for the comparable implementation in the student class, and it will sort the student objects based on the compare2 implementation provided inside the student class. But if you want to have more custom control over sorting, then you need to tell Java how to do that sorting. And if you see, this is an overloaded representation. This is a method overloading example as well, where the method signature is same, but just the number of arguments are different. So this is how you provide your custom sorting. You supply your comparator. Now you can create multiple comparators. You can create another comparator based on, let's say, name. You can have one more property here, create one more comparator. So you can have as many comparators as you want. Just keep creating them and keep supplying them individually one by one in the sort method. You can just duplicate this and add one more comparator. So this is how you are going to have more control. And if you have multiple consumer application, call multiple sort methods, supply their corresponding comparator, and you will get the sorted collection. So here I'm just printing the list based on the age comparator sorting. And these are the objects. So let's see how this works and understand the output from the beginning. So the natural sorting order is something which we have already covered, which was done based on the roll numbers. So Jane comes first, Tom comes second, and John comes third. And this is how you get this particular output. Now coming to the age comparator, you print this particular statement, which is coming here, and then you print these values. So let's see how the age comparator is working. The youngest here is John. So John comes first. Then we have Tom, who is 20 years old. So Tom comes here. And then we have Jane, who is 21 years old, and Jane comes in the last. So we can see that our age comparator has fired here, and it has sorted this in an ascending order. Now let's flip the values. I'm going to change the values here, and now it should work in a descending sorting order for the age comparator. So let's run this application again, and now you see Jane comes first, who is 21, then Tom comes, who is 20, and then John comes, who is 18. So now the age comparator is working in a descending order. Before we go into enums, let's understand why we need it. When you will be building the Java applications, you will face scenarios where you will have to define some variables which will remain constant forever. For example, months of the year. They are not going to change. They are always going to be 12 months in an year. Similarly, let's say name of flowers. They are not going to change. A lotus will be a lotus forever. Similarly, the name of the seasons will always remain same. The season of summer or winter will always be called summer or winter. They will not be changed. The meaning of those variables will never be overwritten or will never be changed. So you can think of them as constants, but they are not the constants which your programs may mutate or your programs may interpret differently. They will be interpreted by multiple applications, multiple components, multiple consumers in exactly the same way. Similarly, if you take the example of time zones, they are fixed. They work with the GMT with respect to the GMT time zone, and they will always remain like that. So whenever you have a situation where you have to define such constructs or such constants, always think of enum types or enumerated types. Enum is basically a language construct, and you can use this language construct to define type safe variables. When we say type safe variables, what we mean is that these variables are not integer or string, they are of enum types. That's the reason Java created a completely new data type, which is called the enum type. They are by default constant, so you cannot change them. That's their property. And the way you define enums is like this. You say public enum. So instead of the keyword class, you use the keyword enum, and then you define the name of the enum, the name of the enum type, and then you define the possible values, just simply separating them by a comma. So for example, days of the week is again a constant thing. There will always be 7 days of the week, irrespective of what you do on this planet. So that's why you can declare an enum for the day, and you can define those as the values. You also notice that the values are caps by default, and yes, that is how you define the enums. Let's have a look at a more interesting example of the enums in the IDE now. So if I switch to the IDE, I have created a class called color, not a class, but an enum type called color. And this enum type color is basically holding all the different color types, their values basically, like all the WebGear colors, for example. So I've defined 3 colors here, which are red, green, and blue. So you see, I've defined them as caps. They automatically become bold. You don't have to bold them. But you see an interesting thing, a difference here, that there is another value in the brackets here. This was not there when we looked at this example of day. There is no value inside each of the enum types, but I have defined the value of the enum types, and that is optional. There will be use cases where you want to define some enum constants, where the name of the enum type is a constant, which is a placeholder, but it will have an internal value, which may be more practical for your application. So this is what your consumers see, and this is what is used whenever you call red inside your application. It's just for simplicity. There might be use cases where you use some abbreviations and their full forms. For example, if you want to use here an abbreviation of, let's say, WHO, and inside this you can define the value as World Health Organization. So this is just a toy example I'm giving you, where you will have use cases where you want to define a constant, but you want to define an internal value of it, which is to be read by your application elsewhere. But everybody who wants to consume this enum can just use this particular keyword. And if they want to get the value, they can get the value as well. So this is the use case where you might need to define values of your enum types as well. But whenever you have to do that, if you want to fetch the value of an enum type, you have to write some extra code, which is written here. If you are not defining the value of your enum types, your enum can be as simple as this. You don't need to define anything else apart from just defining the constant of the enum types. I'm giving a more complex use case so that it covers both of the things of using just the constants and also using the values. So if you just want to read the constant, you can just say color.red or color.green or color.blue in different classes, and you will be able to refer to the enum types or use the enum types. But if you want to refer to the value of the enum type, then probably you need to call this method called getValue. So whenever you define a value, what you would do is you will define a private member variable inside the enum, which is defined here. You can name it anything if you want. You define a constructor where you set this particular value, and then you define a getter. So whenever some consumer application wants to refer to the value of your enum type, they can call this getValue method to get that. So this is the enum. Now let's see how we can use this enum. For using this enum, I have this main class where I have a public static void main method, and you can simply fetch the enum types by writing the code like this. Just write the enum type holder and then type the enum type. So let me show you how this is done. If you just put a dot here, you will get all the enum type options. So I've defined 3 enum types, red, green, and blue, and I get all the options. So whatever option I want to choose, I can just select here. And I can store this inside an enum variable. So if you want to just refer to the name of the enum, so this C1 is holding color.red or red. So if you want to refer to this, just this red, then you can call the dot name method on the C1 variable. So if you say C1 dot name, it is going to put or print the red in caps. And if you want to fetch the value inside the red, remember the value is red in small caps. So if you want to refer to the, or if you want to fetch the value of the red, then you call the getValue method, which we have defined here. So that's what we are doing here in this first two sysouts, where we are printing the red enum name and then printing the red enum value. Now you can also iterate over all the enum types. And for that, you need to call the dot values method on the enum. So you can just say color dot values, which is going to iterate over all the enum types. And you are just storing each of the enum type in this color placeholder. Then you can either call getValue to get the actual value of that enum type, or you can call the name to just print the name of the enum as well. Both of the options are available. So let's just put it back to getValue and let's run this code. So if I run this application, I get some output here, which looks like this. First sysout says red enum name is red in caps because we are calling the name method. Second says red enum value, which prints red in small because we are calling the getValue method. And then we are iterating over all the enums. So I had 3 enum variables here, red, green, and blue. And I'm going to iterate over all of them one by one here, printing their value and not the enum constants. So that's why you see the red, green, and blue here in small. But if you just want to print the enum constants themselves and not their values, then you change this to dot name, and then all the enum constants will be printed here. So this is how you can create enums and use enums for the constants which are never going to change in your application. And that's all I want to cover for this particular session. In the next session, we are going to talk about annotations in Java. Now, annotations is a bit advanced concept, so let's understand why we need it. There would be some cases in your application where you need to provide some metadata information to the Java compiler. Now, this sounds a bit complicated, but it's much simpler than that, because you might not want to code everything with a lot of lines of code. Rather, you want to give some smart instructions to the Java compiler so that they understand what to do. We have already seen some of the annotations, but the basic idea of annotations is to provide some shorthand metadata information about the program to the Java compiler. Generally, annotations will not have any direct effect on the operation of the code they annotate, but they provide additional logic to the code. That's the idea with annotation. Remember, they are shorthand metadata. The main use is providing information to the compiler, or providing some compile time or deployment time processing, or also providing some instructions for runtime processing. We have already seen some of the annotations. If you remember, when we were dealing with inheritance, we had this override over the methods, right? This override is an annotation. This annotation, if I show you what I'm talking about, if I take you back to one of the inheritance example or the method overriding examples, and if I open the mountain bike class here, mountain bike extends bicycle, you will see this override annotation. This is an annotation. An annotation always starts with @ in Java, and the annotation name is override. Now this override is just a shorthand to tell the compiler that, hey, I am overriding this method from the base class. That's what this annotation does. If you remove the annotation, in some cases, the Java compiler might not understand what to do, and the Java compiler has to do some extra processing to figure out that this method is actually being overridden. But if you put this @override here, then the Java compiler pre-hand will know that this is coming from the base class. So you save some of the compiler processing time as well by using the annotation. It's a shorthand providing instructions to the compiler. You see exactly what I'm talking about. So this is one of the annotations which we have used, but we will look at some of the other more generic annotations, and we will also see how we can build our own custom annotation in Java. You might have also seen some other annotations like, for example, you can put @suppress warning annotation, which is a very popular annotation to suppress any kind of yellow warnings in your code. Generally, we do not recommend doing that, but if you have a use case, then you can use @suppress annotation as well. There are some other annotations as well, like @author. If you want to put your name as the author of a particular piece of code, then you can add this metadata so that whenever somebody looks at even the documentation of your code, your name will be shown there as the author. So that's the idea with annotations. So let's see how you can build your own custom annotation. Whenever you have to do that, there are multiple ways to doing that. And the first type of annotation we are going to have a look at is called marker annotation. A marker annotation is just an empty annotation without having any metadata logic at all. You can see I have defined an annotation here. I will talk about what all this means, but inside the block, there is no code here. And this is how you define a marker annotation. Marker annotation is just to provide very high level instructions to the compiler. And the way you will write your custom annotation is you will put an access modifier keyword like public. Then you will write @interface. This is the keyword which you have to use whenever you're trying to create your custom annotation. Marker or no marker doesn't matter. Whenever you define your annotation, you have to use @interface. Once you do that, then you provide a name for your annotation, which can be anything, but still not complete. You need to also provide more instructions to the compiler or the runtime processor to tell them when to execute this annotation and what the annotation type is going to be applied upon. So at first you specify when this annotation is going to be active or executed or evaluated. So here you can say @retention, which is another annotation. So you say @retention, and then you say retention policy dot whatever you want to write as. You can write it as runtime or you can write it as source. If you write it as source, then it is going to be applied at compile time. And if you select it as runtime, then the annotation is going to be processed at runtime. So this is the first thing which you need to provide. The second thing which you need to provide is where this annotation is going to be applied, whether you want this annotation to be applied to a class or to a method or to a member variable or to any other type. And that's what you define in the @target annotation. You specify the target audience for this particular annotation. And here inside the element type, you will get multiple options. You can apply this annotation to a constructor, to a field, local variable, method, module, package, record component type, etc. So here I'm going to use type, which means it can be applied to a class or a generic element type, which generally means class type. And that's all. You can define your marker annotation like this. But generally these marker annotations does not have any logic, so you will not get much value out of it until you have very special cases. But if you have a case where you want to also run some business logic or provide some metadata logic to the compiler while defining the annotation, then you can define the annotation like this. So I've created one more annotation here, which is called my custom annotation. Again, the target audience for this is method. So this annotation can only be applied to methods. If you try to apply this annotation to a class, you will get an error. The retention policy is runtime. It means it is going to be processed at runtime. And I've declared a method here, which is called int value. So this is how you will declare your annotation. Now let's see how do you use this annotation. So I have a class called as my class here. And if you look at this structure of the my class, we create the class and then I create a method, which is named as say hello. And I am applying this annotation on this particular method. Remember, the target audience of this particular annotation was method, so it only be applied on method. If I try to put this on the class type here, then I get an error here. It says the annotation, my custom annotation is disallowed at this location because the type specified is of type method. So the compiler will not allow you to use this at an illegal place. So you write any method and you apply your annotation, but you provide a value to the method. The int value method is going to consume this value. And inside the method, you can write any other logic. So let's see how this pans out. I create a public static void main method and I create an object of my class. So my class h equal to new my class. And after that, I'm saying h dot get class dot get method. I'm basically calling the method by using reflection API. You can also call the method directly if you want, but this is how you need to call it if you want to use the annotation property value, if you want to fetch the value of the annotation. So this is just an example of me showing you how you fetch the annotation. So we created an object and then we say get class, which is going to return my class type, and then get method is going to return the method type which has the name say hello. So this is a way to fetch a method name or a method type from a class using Java's reflection API, which is an advanced API. You might not need to use it, but for the sake of demo, I'm using this. So we fetch the class and we fetch the method. It is going to search the class for a method named say hello. If it finds the method, it is going to return the method in this variable. And then you can call method val, which was this variable, dot get annotation. Give me any annotation which is applied on this particular method. And you supply the annotation class type as well. Once you do that, you get a my custom annotation reference type. And then if you call the value method on this, you will get this value as 10. So this is a way where you can apply an annotation and you can actually see the effect of the annotation. You might not always want to do this because, like I said, these are metadata instructions to the compiler. But if you have a need to actually see what your annotation is doing, you can use the get class.get method to first fetch the method, store it into a method type, and then call get annotation, supplying the exact annotation class type, and then you can call the exact method which is defined in your annotation. Here I've defined it as value, so I'm just calling the value method. So if I run this particular example, I get the value as 10. So I'm able to see or fetch the exact value which my annotation metadata is holding at the runtime. And this is the power of annotation. They're a very powerful concept and they're a very advanced concept. There would be very rare scenarios in your application where you need to create your custom annotations. Generally, you will be better off with your predefined annotations which are provided in Java, like @override, @author, suppress warning, etc. And that's all I'm going to cover in this particular session. And in the next session, we are going to talk about serialization in Java. When you will be building the enterprise grade applications in different organizations, you will often have a use case or a need to send an object from one application to other application which is deployed on some other machine. So if you have a network of computers or if you have a lot of different complex setup where you have a producer application and you have a consumer application. Producer application produces the object and then this object gets traveled over the network lines, over the network wires, and reaches at the consumer application. And how does the consumer application receive the object and how does the producer application sends the object? Because when the data travels over the network lines, it will be all bytes. So how do you convert a Java object into bytes, send it over network, and then the consumer application has to again convert that bytes back to an object representation and then store that or use that inside its application. So you need to do this whole conversion, right? So the process of converting an object to a byte so that it can be sent over a network is called serialization. And the process of converting back the byte from the network to a Java object is called deserialization. So generally, you may have a use case where you serialize an object, create a binary representation of it, send it over the network. And that's where the Java serialization concept kicks in. Whenever you have to do this in Java, you will be using the serializable interface. So you need to extend your objects from this serializable interface so that those objects themselves becomes serializable. You need to tell Java that this object is able to serialize itself and deserialize itself. And the way you will tell Java is by letting that object implementing the serializable interface. Let's have a look at an example of this serialization and deserialization to understand this concept better. So here again, I've used the same student class where it has the name, age, and address. So you can see I have created a student class, but the student class implements serializable. This is something which you have to add to your class. Second thing, the moment you do that, all the modern day IDEs like Eclipse or IntelliJ will ask you to add a serial version universal ID to this particular class. This is added so that Java can uniquely identify your object once it is serialized and deserialized. And it will also keep a versioning track of it, right? Because when you serialize the object, what happens if somebody hops over the network line and change the representation of your object? And the consumer application will get a completely different object copy now. So this is Java's way to make sure that the same version which the producer application is producing is received by the consumer application. So it's also sort of a security feature. It basically, whenever you do an update onto the object, it is going to increment this serial version UID by 1. So when you create the object first time and you serialize it for the very first time, the value is going to be set as default 1. And as you mutate the object again and again, before deserializing it, the count will just keep on increasing. So that's how you keep a track of the state of the object which is being serialized by adding this long serial version UID. You can also specify your own value if you want to. By default, Java initializes a value of 1, and this is a long type variable. So that is the only new thing which is happening the moment you do implement serializable. After that, I have the same fields here. I have the constructor and the setters and the getters. And I also have a toString method just to print the object nicely, where I print the name, the age, and the address. So let's look at a main class and where we use the student object, we serialize this object, and then we deserialize this object. So what is happening here is I create a class, I create the main method, and I create a student object. This is something which we have already seen. Then I want to store the state of this object. When you serialize this object has to be either sent to a network. But since I'm running this demo on the same machine, what I will do that I will serialize this object onto my local file system. It's the same thing, right? You can put it somewhere and then fetch it from there. So either you can send it over the network or you can put it on a file system. So I create the object and then I need to store this into a file. So far, I have not covered the file handling operations. So we will not go deeper into the file handling classes here, but I will just explain you the reasoning for it. And when we'll do the file handling session, there I will go in detail about the file handling classes. So I specify a file name where the serialized representation of my student object is going to be stored. And this is the location where I'm supposed to store this. Then I create two different classes, which is for writing to the file and then creating an object for it. So that's what I'm doing here. We can ignore this particular part where I'm just supplying the file name, and we can focus on this part, this line, where I'm saying write the object, the student object, to this particular file. That's what I'm doing here in this 3 lines of code, that I'm writing the student object to the file. So when Java has to write this object to the file, it is automatically going to serialize it. That's the only way Java can write an object to the file. So you serialize the object and then you print that message that the object has been serialized. Again, you can ignore this part as well. Like I said, we will not focus on this. But what we technically did is we just wrote the object to a file by serializing it. Then I try to deserialize it. So I load this same file into the Java JVM, and then I read the object. And the way I read the object is by using this object input stream class. I supply the file that read this particular file, and then I call the read object method, which is going to return an object, a general object. When you call the read object method does not know that it is a student type object. So you need to explicitly cast this to the student type so that you can store this as a student object. If you do not cast this, you will get an error because, like I said, read object does not know anything about the student class. So what does this mean is that when you serialize an object, the class type information is lost. You cannot store the class type information when you serialize an object, because the moment you call this write object method from the object output stream class, so you created this object output stream class, you supply the file output location, and you call the write object. The moment you call the write object, it's just any Java object for this Java program. The signature of the student class is lost. It does not know that it's a student class anymore once it is being serialized. Similarly, when you deserialize it, the serialization API has no idea about what student class is and what student object is. So you need to tell the read object method explicitly that, hey, you are reading an object of the student type. And that's how this line works. Once you explicitly provide the casting operation. Once you have casted it, we try to print the same deserialized object to see if all the state which we stored in the object is still persisted there or not when we deserialize it. So our major focus in this particular class is this object output stream classes and the write object method. These are the two most important statements which you need to take care of. The file output stream is basically a file location. What is an output stream? We will talk about that later, but whenever you need to serialize, you need to use this particular class called object output stream. So that's all I'm doing here. I'm serializing the object with these values, and then I will deserialize and I will again print the object to see if these values are still there or not. So let's run this application. So when I run this application, let's start from here. First, this sysout gets called, which says object has been serialized. So you see object has been serialized. And what I serialized was this student object, which had the value of name as John, age as 25, and the address as 23 East California. And that's what gets printed here. Then this whole block gets completed. This whole try block gets completed. It's a standard try catch block. You see, I have also added the IO exception. You need to do that because these file operations will force you to catch or throw the IO exception, which is a checked exception. That's why it will force you to do that. Then we move to the deserialization block, where we create an object of the object input stream class, and then we call the read object. We cast it to the student type, and then we print the object. So when I print this object, this line gets printed, object has been deserialized, and then I can see that the exact same state is still there. The name which I set in the object is still there after being deserialized. The age and the address is exactly intact. So this is how you can serialize an object, send it anywhere you want, and then the consumer application need to read the object and cast it back to the student type, and they will be able to see the exact same state which you saved in the object just before serializing it. What if you have a use case where you have a property in a student class or in your object, but you do not want that to be serialized? That's also a use case where you may have 50 different properties inside the student class, and one of the properties is something which you do not want to serialize because you do not want the consumer application to see that value. If you ever had that scenario, use the transient variable. So transient is again a keyword, and the moment you put this keyword in front of a member variable, that variable becomes transient. The use case of transient variable is that if you do not want this X to be serialized and deserialized, then you put the transient keyword in front of it. The normal member variables will automatically get serialized and deserialized when the object is serialized and deserialized. But if you have a use case where you do not want a particular member variable to be serialized or deserialized, put transient in front of it, and then have the getters and setters for this X variable. And let's use this and see if this actually gets serialized or not. So I created the student object, and let me call student.setX, and let's put a value to X. Let's say 10. So I have set the value of X is 10, and X is a transient variable, and then I am serializing the whole object here, and then I'm deserializing the object. And let's see if I'm able to fetch the value of X after deserializing the student object. So I'm calling the system.out.println, and the deserialized value of X is object.getX. Let's see if I'm able to see the value of X or not. So let's run this application again. So this is exactly the same as before. This is also exactly the same as before, but I see the value of X is 0. Remember, I set the value as 10 before serializing it, but I don't see the value 10 anymore when I deserialize the object because it was transient. If you remove transient from it, then you will be able to transfer or travel this value of 10 between serialization and deserialization. So if I just remove this here, don't change anything at all, and I just rerun the application. This time, when I deserialize the object, the value of x as 10 is still present there even after deserialization. So this is how you can use the transient variables if you want to not have that object serialized or deserialized when you're doing the serialization. And that's all I want to cover in this particular session. And in the next session, we are going to talk about multi-threading in Java. And the idea behind concurrency is very simple and plain. And that idea is that as a developer, when you write a program, you would expect the machine or the computer to run multiple tasks in parallel. For example, right now, I'm recording this video on a particular laptop, which is recording my voice, which is also recording the screen, which is also running the Eclipse IDE and also running a Chrome browser. It also have opened multiple background applications. So there are a lot of tasks running in parallel at the same time. And that's the idea about concurrency. Now, how do we work with concurrency in Java is with the help of processes and threads. So these are the two basic units of execution when we talk about concurrent programming in Java. And when we talk about processes, you can think of a process as basically an execution environment, or I should call it as a standalone execution environment. Think of a logical box which is completely cut out from everything and it has its own environment. For example, again, the recording software is running in its own execution environment. And when we talk about process generally has an everything or a private set of all the runtime resources it needs and the memory space it needs. Now, there's another concept or another construct which is very important is threads. So threads are also sometimes called lightweight processes. And basically, when we talk about threads, a thread also has an execution environment, but creating a new thread requires a lot less resources than creating a new process. And you can also think of threads as a mini version of a process because a process can have multiple threads. Remember that statement that a process can have multiple threads. Threads always exist within a process. And whenever you start a process, there will be at least one thread attached to it. And each thread is basically a task. For example, the voice recording can be a process, and inside that, the mic recording expression or the mic recording task can be run by a particular thread. Let's take another example that when you play games, let's say you're playing a racing game. So when you play the racing game, there are multiple things happening at once. You see the current speed of your car or bike on the screen. You also see your leaderboard position, what ranking you have in the race currently. You also see some other kind of features like player's health or the car's health or the fuel consumption available and lots of other stuff. The graphics, the motorcycle, the other competitors' bikes and their speeds and their distance to you as well. So if you see, all of these are running on different threads. There's a different thread to show your current speed. There's a different thread to show the current leaderboard position. There's a different thread to show the fuel indicator, etc. Everything is running in a different thread. So all of these threads need to run at the same time in your program for a complete immersive user experience. And that's what we mean when we say multi-threading, that we want multiple threads to run at the same time to create a better experience in the application. So that's basically the theoretical part of it. Please do read more about how threads work and how processes work. And there's a lot more documentation available in the Java docs as well when we talk about threads. But I will keep the theoretical part to this particular point. And now we will move to an Eclipse example to see how we can create threads. So with that, let's move to the Eclipse IDE. And here I have a demo prepared basically. So what I have here is a threading demo class, which has a public static void main method, and it has a simple for loop. And inside the for loop, I see this strange code here where I am initializing two threads and starting them. So that's all I'm doing here. But let's see how this thread1 and thread2 class have been written and why do I see two different ways of initializing them. Let's go deeper into this now. So let's see how thread1 can be created. So first of all, you can create a thread by just creating a simple class, but make sure that you extend it with the pre-built thread class. This thread class is coming from Java. So from the JDK basically. So the moment you extend your normal class from the thread class, then you will have to override the run method. So if I show you the thread class here. This is the thread class implementation available inside the JDK. And this is the class which is getting called when you are extending it from the thread class. And this thread class will ask you to override a run method. Here the override annotation is missing. So let me just add this for better understanding. So you need to override the run method. And this is something which you need to do so that you can specify what happens when you run the thread. So this run method will be called whenever the thread is running. At this particular point, I would also like to tell you that there are different states in the thread. So there is a thread which says thread is ready. Then there is a state which says thread is running. There is also a state where the thread is waiting for an IO input from the user from the console or the command line. There can also be a state which says dead, where the thread has completed its task and it's not working. There can also be a state which is called sleep state, where the thread is paused. So there are different states of the thread. And in this example, we are going to focus primarily on three states, which is the ready state and the running state and the completed state. So when you call the run method, the thread state is going to change to running. And whatever code you write inside this particular run method will be the logic which this particular thread is supposed to execute. Here, I'm just putting a dummy logic where I'm just printing a sysout. But definitely, if you try to create your threads, this will contain your actual business logic. For example, that fuel indicator code or for the leaderboard position code will go inside this run method. And then I'm catching an exception if there's an exception, but obviously there will not be an exception coming in because I have nothing here literally. So that's what we are doing when we are creating this thread1 class. And let's come back to the threading demo now. So to initialize a thread, or initialize might not be the right word, to run a thread, the first thing which you need to do is to initialize the class containing the run method. So I would avoid calling this class as thread because technically this is just a class. So you basically create an object of the thread just like you create the object of any other class. There's nothing new here, right? So we just say new thread1 and then we call t1.start. Now, if you observe carefully, there is no start method here. We just had a run method, but this code is still compiling fine. And I'm calling the start method here because the start method is the internal method of the thread class, which in turn is going to call the run method. So you are never going to invoke the run method directly. You just need to start the thread, which is going to change the state of the thread from ready to running. So the start method has the responsibility of changing the state to running. And the way the start method is going to do that is by calling the run method internally inside the JDK itself. From developer perspective, you just need to call the start method and that's it. The thread will start running and whatever is present in the run method will get executed. So that's the way to start the thread. Second thing, I have one more thread created here, which is the thread2 class. So in this case, when I create a thread2 class, I'm not extending it from the thread class. Rather, I'm implementing the runnable interface here. So this is a different interface available, which is a functional interface, which means it will have just one method, which is the run method. But the interesting thing is that here, when I created thread1, I said extends thread. But here, when I'm creating the second thread, I'm not using extends thread, but I'm using implements runnable. Let's understand why do we do that first of all. The reason Java provides two different ways of creating threads is because there might be a use case that you need to extend your thread2 class from some of your custom Java class. Remember, Java does not support multiple inheritance. So at a time, you can only extend this class from one class. So what if there was no runnable interface and you need to extend this thread2 from student class, let's say. So you need to do class thread2 extends student, for example. The student is not present here, but let's assume it is. So you do this, and then you also have to extend it from thread. Now, Java doesn't support multiple inheritance, and this will not work. So what would you do if you have to also create it as a thread, but also extend it from some of your parent class? You will not be able to do that. And that's the reason Java provides the implements runnable, because then you can extend it from any of your superclass of your interest, and at the same time, also implement it with runnable interface so that you can treat this class as a thread. So that's the reason Java provides two different ways of creating threads. Remember that it's a very important concept. And once you implement runnable, again, it will ask you to override the run method. So I will just put override annotation here. So once you override the run method, again, you can write whatever logic you want this particular thread to execute inside the run block. Coming back to the main class. So when you are extending from thread, the initialization is very simple, where you create the object and you call the start method on the object. But if you are creating a thread by implementing the runnable interface, the initialization of the thread is a bit different. And it's different in this particular part. On the left-hand side, you still say thread T2. Remember, you are saying thread and not thread 2. This is the Java thread class. This is the JDK thread class, not your own thread class. So you say thread T2, then you say new thread, and inside the new thread, you provide your own class type. Thread 2 was your own class type. So you specified your own custom thread class here inside the new thread constructor. This thread class is the JDK class. If you click on this, you will see this is from the JDK class. So that's the difference. Extending thread, simple initialization, implementing runnable interface, do the initialization like this. And after that, you call similarly the start method, which is in turn going to call the run method. So that was how you create threads differently. And now let's run this program to understand how the output looks like when we run these threads in loops. Remember, I'm initializing 10 instances of each of these threads. So in total, there would be 20 output lines. So if I go to run as Java application, I see this output here. So let's observe this output for once. So thread 1, thread 2 is running in sequence in the first time, but then you see thread 1 is running twice, and then thread 2 is running twice. Then again you see a good sequence, but again thread 2 has run twice here. Again thread 1 has run twice. If I go further down, thread 1 runs once, then again thread 2 runs twice. Thread 1 runs once, thread 2 runs once. So there is no particular order here, though based on the code which we have written, we should expect thread 1 is running from here and then thread 2 is running output from here in a sequential fashion. But we don't see the sequential fashion here. And this is the power of concurrency. This is because threads never run in sequence, they run in parallel. And which thread will execute first, you can't really predict that. So so be very careful whenever you are writing multi-threading code, because you cannot predict the sequence of execution, because threads are going to run whenever they find the idle CPU. So the key is the idle CPU. Whenever a thread finds an idle CPU, it is going to occupy that CPU and going to run its own execution. And the moment its execution finishes, the other thread will jump in and take a piece of the CPU. So whichever thread gets the idle piece of the CPU is going to execute. And that is the reason you see this randomized output. The next time you're going to run, you will see a different random order. So this time you see thread 1 ran 4 times. You did not see this in the previous execution. If you run it again, you will see again a different output. This time the thread 1 ran thrice. So every time you will run this, you will see a different sequence. There is no guarantee of order because the threads are running in parallel and they're running whenever they get the idle CPU. That's the bottom line. So this is how we are going to create threads. And remember, you cannot guarantee the sequence of the execution. So write your code accordingly and use the threads for independently running parallel threads which do not depend upon each other. And that's all I want to cover in this particular session. In the next session, we are going to talk about how do we synchronize the threads. That's also a very popular concept, which is also called thread synchronization. So we are going to focus on thread synchronization in the next session. So in the previous example, we saw that when we execute threads, then we can't guarantee the sequence. But it's actually technically not a problem in the example which we had a look at before, but it can become a bigger problem when two threads are trying to access the same object. Remember, object has properties and state. So what if the first thread modified the object state and the second thread is reading the state of the object? The second thread is expecting the original state, but while it was trying to read it, the other thread modified its state. So you can see this can become a big problem. For example, if you are working with a banking system and if there are two persons accessing the same account at the same time, one is depositing the money and one is withdrawing the money from the account. And if the total balance is 1,000, and if both of them deposit 500 and withdraw 500 at the same time, then who sees what? And if these are handled by two different threads, then we can't guarantee if somebody sees a 1500 as the total sum or somebody sees a 500 as the total sum, or there can be a scenario where somebody sees 0 as the total sum. So the application can turn into really weird scenarios if two threads are trying to change the state of a particular object at the same time. And Java provides a solution of it with the concept of intrinsic locks and synchronizations. So the idea is that when a thread tries to work on a particular object, it basically takes a lock on that particular object. We also call this as an intrinsic lock or monitor lock. So it takes a lock on the object, and it means that that particular object becomes completely inaccessible to other threads in the system at that particular time. So the moment you put synchronization or you put lock on a particular object, only the thread which has taken the lock will be able to access the object, and other threads will be forbidden from accessing the object. So that's the idea behind intrinsic locks and synchronization. So that was about the brief theory of it. Now let's have a look at a practical example. So I have prepared another example for it. So here I have again created two threads, but these two threads, it's pretty much the same threads which we covered in the previous session, named as thread 1 and thread 2. One is extending thread class and other is implementing runnable. But that's same. But the interesting part is this: both of them have a reference to a class called mathutils. If you see, thread 1 also has the reference and thread 2 also has the reference. And what the mathutils is doing here is basically you supply a number and it prints the multiples of it till 5. So for example, if you supply 2, you will get the output 2, 4, 6, 8, 10. If you supply 3, you will get the multiple of 3 up to 3 times 5. So 3, 6, 9, 12, 15. If you supply 4, you will get the outputs in the multiples of 4 till 20. So whatever number you will supply, you will get the next 5 multiples of that particular number. That's what this class is doing. And another thing, interesting thing which I've done here is this thread.sleep, which means that when you run this loop where you are printing the multiples till 5 of that number, every time you do the first multiplication, then you sleep for 400 milliseconds. And when I say sleep, it basically means the current thread is going to pause its execution for 400 milliseconds, and it is going to leave the CPU idle. And if there is another thread running currently in the system, that thread will get the share of the CPU for that 400 milliseconds. And once the 400 milliseconds is finished, the thread is going to wake up and it is again going to hunt for the idle CPU to pick up and start doing its execution. So that thread.sleep happens for 400 milliseconds at every step of this iteration in this for loop. So thread 1 is going to use this particular method of this particular class, and it is going to ask the class to print the multiples of 2, and thread 2 is also going to access the reference of the class and access the get multiples method, but this thread asks to print the multiple of 3. So thread 1 asks for printing the multiples of 2 up to 2 times 5, and thread 2 wants to print the output to multiples of 3 up to 3 times 5. So that's the basic scenario. Two threads accessing the same object, supplying different values and expecting the output. So if I run this demo as is without any change, here I'm just initializing the mathutils class, initializing two threads, and then calling the start only once. So if I run this particular program, I see this strange output that even when I said t1.start first, so t1 was holding the multiple of 2, remember, but I still get 3 first, then 2, then 4, 6. So multiples of 2 gets executed here, but then the other thread takes the CPU and it starts running its own multiples outputs. And you see 9 printing first, and then 6 gets printed, then 12, then 8, then 15, and then 10 at very last. So the output looks very random. It would have been nicer if I could have seen 2, 4, 6 at 10 once, and then 3, 6, 9, 12, 15 once. If I see them in different sections, in different sequences, that would have been so nice, because then I know which thread is running when and when that particular thread is working on the object. So I'm just trying to replicate the same scenario where two threads are accessing the same object at the same time, but they are executing the object randomly. They're changing the state of the object randomly here. So how do we fix this? To fix this, we can we have this get multiples method, which is the bone of contention here. This is the method which is being randomly accessed. So what I can do here, that I can put synchronized keyword in front of the method. So once you put the synchronized keyword in front of the method which is being accessed by multiple threads at the same time, this whole method gets synchronized now. What this means that one thread will be execute this method at once. There will never be a scenario where two threads are simultaneously executing this get multiples method or even getting a hold of this get multiples method at the same time. There would be only one thread at a time executing this method. So if I put the synchronized here, and if I rerun this example, you see I get a more streamlined output. If you notice, everything is running like clockwork, where first the thread 1 gets executed. So I get 2, 4, 6, 8, 10, really well printed. And then the second thread starts, which says 3, 6, 9, 12, 15. The reason I get this output is because when I did t1.start, it immediately went to execute the get multiples method, but it saw synchronized there. So it took a lock on the method. And even when the t2.start might have got executed maybe milliseconds after that or nanoseconds after that, it still could not get hold of the get multiples method because thread 1 occupied this particular method. It took a lock on this particular method due to the synchronized keyword. So that's the power of synchronized keyword, that you can take a lock on a particular method if you put it in front of the method. Now there can be scenarios that you do not want to lock the whole method. You still want two different threads to access the method, but there can be very few lines of code inside the method which is thread sensitive code. Now, how do you spot thread sensitive code? There is no magic bullet, there's no silver bullet for it, and it comes with experience. So you need to have that experience to know which is the thread sensitive code which can create problems if two threads run that code at the same time. So the moment you have spotted that code, and if you don't want to lock the whole method, you can lock the exact lines of code by putting the synchronized block. So if I remove this and I enable this particular part, so what I'm doing, that I know that this is the code which is exactly causing the problem, which is creating this random output. So what I can do, that I can put the synchronized keyword right before the block of the code starts, which is thread sensitive. And the way you do that is you write synchronized and you supply this, which means whoever has the whoever has the object of the math utils, that whole object gets logged for this particular block of code. So whoever has the math utils object takes the lock on the object for this particular block of code. If there was some other code which was written in the get multiples method before the synchronized block or after the synchronized block, that block can be accessed by multiple threads at the same time. But this code will only be accessible to one thread at a time. There will never be a concurrent access to the synchronized block. That's the power of synchronized block, and it will work the exact same way. So to show you, if I run this particular program, I still get the output in the same streamlined way, where first the multiples of 2 get printed and then the multiples of 3 get printed. So that's how you can actually use synchronized methods or synchronized block to make sure that one thread is accessing a sensitive object at a time, and there will never be a scenario that two threads are mutating the same object at the same time. Again, like I said, be very, very cautious of when you use synchronized blocks and when you use threads, because threads have unpredictable execution sequence basically, and synchronized blocks also have problems if you have thousands and thousands of threads running in your application, and if you put synchronized on a particular method, your application may face severe performance issues because all of the threads will be executing that method in a sequence. Imagine you put this onto a huge application or a huge e-commerce application or a news website. It is going to create serious performance issues. So be very cautious of how and when you use synchronized method. And the key to that is to have that developer DNA to spot the code which is causing this problem, which might be thread sensitive. And maybe you might need to change the code itself. You might not need to go into the multi-threading scenario, and you might be able to fix it without using the threading or synchronized concept. It completely depends. But always have a good trade-off of when to use the synchronized methods and synchronized blocks. And that's all I want to cover for this particular session. And in the next session, we are going to talk about autoboxing in Java. So if you remember, in the very first sessions, I talked about the primitive data types, and then later on, we talked about the objects. For example, we had the int data type, but there later we also saw an integer data type, which can also pretty much do the exact same work which int data type was doing. And we saw the similar kind of experience for the float data type and the float class, double data type and the double class, char data type and the character class, and so on and so forth. So Java provides an easy way to convert a int data type variable into an integer data type variable, and also back from integer data type variable to an int primitive data type variable. Now you might be wondering why we need that. There would be scenarios, for example, if you had an int array as a primitive int array, and if you want to store that into a collection, now collection can only be of type of objects. It cannot be a type of primitive data type. So you might need to convert this int primitive data type array into an integer object collection. So you need to do this conversion of int data type to integer data type. And there would be cases where you might need to do vice versa. So that's the basic idea about autoboxing and unboxing. So when we talk about the definition, you can see autoboxing is the automatic conversion that the Java compiler makes between the primitive and their corresponding object wrapper classes. So whenever you are converting a primitive data type to an object class, this is called autoboxing. And when you do the reverse, it is called auto unboxing or simply unboxing. So let's understand this with the help of an example now. So I'm just going to open an example about autoboxing and unboxing so that we can have a look at it. And here it is. I've created a class which is called Autoboxing Demo. It has a public static void main method, and inside the method, I'm first simply declaring an int data type variable I with the value 10. Then if I need to autobox this, if I need to convert this primitive value into an integer object wrapper class or an integer class type, then I need to write the code like this, which says integer dot value of, and then you can supply the primitive data type value, and the output of it will be of type integer class. So you get an integer object, and then you can print the object to check if it is successfully doing the autoboxing or not. Similarly, doing the other way around, once I have converted this into an integer object, let's convert this back to a primitive data type. So from integer object, I'm converting this back into the primitive data type. And you see here, it's a simple assignment. I just have to assign the object to the primitive data type, and that's it. I can do the same for a character object and a char data type. So first I create a character object, char obj, and then if I have to unbox it, I can simply assign this char obj to a char primitive data type ch, and that would be it. So you can do the similar drill for any other primitive to object wrapper conversion. Let's say you want to convert a float data type to a float class, or you want to convert a double data type to a double class, then whichever primitive data type has an object wrapper class, you can do the auto boxing and auto unboxing like this. Remember, whenever you have to do auto box, it means you're going from primitive to object. And for that, you need to call the value of method. For example, if you were converting a double primitive to a double object class, double object type basically, then you are going to call double dot value of. And similarly, the same kind of behavior will be seen for other object wrapper classes as well. So for auto boxing, you call the value of, and for auto unboxing, you literally just assign this to a primitive, and the object wrapper class value will automatically be assigned to the primitive data type. So let's run this now and observe the output. So I had the int I equal to 10. Then I wanted to convert this primitive into the object wrapper. And the way I can do that is by calling the value of method and supplying the primitive data type's value. So that's what I'm doing here. And this iObj should get the 10 value now, which I can see if I print the sys out, and if I just print the integer object altogether, I get the value 10. So this concludes that I've successfully am able to auto box the primitive into an integer object. Now looking at auto unbox, like I said, you simply can assign the object wrapper to the primitive data type variable, and that should work as is. And that's why at line 15, we get this output which says value of I1 is 10. Similarly, when we try to auto box the character object. So I have created a character object here, and then I want to unbox this back into a simple char data type ch. So when I print ch, I get the same value. And when I print the char obj, I again get the same value. Remember, the reason I've put this as autobox is because this by default is being stored into a char data type. I can also write it like this. For example, I can say char x equal to a, and then I can refer here as character dot value of x. This will pretty much have the same impact or the same effect which I had just now. It is going to print the exact same output. If I read on this program, I'm going to get the exact same output. So this basically concludes our understanding that you can use the auto boxing and auto unboxing pretty easily whenever you have a scenario where you want to convert the primitive data types to the object wrapper classes, or you want to convert the object wrapper classes back to the primitive data types. And that's all I'm going to cover in this particular session. And in the next session, we are going to talk about IO streams in Java. So when we say IO, it basically means input, output. And the basic idea is that your program takes an input and gives you an output. So whenever you have to do some IO handling, generally the IO handling involves taking input from some external source. It can be the command line, it can be from a file, it can be from another consumer application, it can be from a hard disk. But the basic idea is that whenever you have to do that input-output handoff or input-output operation, we call that as IO. Generally, whenever you will hear the term IO, we refer to the input-output operations with respect to the file system or the hard disks or the external disks, basically. Now, when we talk about streams, what is an IO stream? So the basic idea is that you have an input source, you have an output destination. Now, the way the input source sends the data to the destination is via streams. So basically it converts the data into 1 and 0, and that 1 and 0 travels as a stream. For example, you can see this pretty good image here where you have a data source and you have a program, and your program is trying to read the data from this data source, which is basically sitting on the file system. And this data gets converted into zeros and ones, and then this is streamed to the program bit by bit or piece by piece. Similarly, when the program wants to send the data back to the data source, it again goes in the form of stream. So when we talk about stream, we also use the terms as input stream or output stream. So a program uses an input stream to read data from a source. Remember, whenever we are reading, we will call it as input stream. And whenever we are writing something, we will call that as output stream. Remember that because I will be using these particular terms again and again in the demo. So that's the basic idea about streams, that you convert this into 1 and 0, and input stream means reading something and output stream means writing something. So now that we have built that understanding, let's have a look at what kind of classes support Java provides to do this IO streaming operations. So this is the Java IO hierarchy where you have the object superclass, and then you have different types of stream classes. So you have input stream, you have output stream, you have reader, and you have writer. So if we talk about this particular section, in the input stream, you have a file input stream. In the output stream, you have a file output stream. This is basically showing an inheritance relationship. So you have the input streams for reading something, you have the output stream for writing something, and you have Java provides the classes to read from a file or to write to a file using the file input stream and the file output stream class respectively. There are more classes under it, but only a few of them are shown for simplicity. Similarly, if I go to the right side, I also have a reader class and a writer class, which also have an input stream reader and output stream reader. And again, these have multiple other subclasses like file reader, buffer reader, and file writer. So I will also try to showcase the understanding of why we need this and why we need these. I mean, ultimately, you have to write a stream, right? So why creating two different types of classes? I will come back to that in a while. With that understanding, let's go into looking at an example and let's build an understanding of how do we work with streams. And this is also the session where I will talk about the file handling operations in detail. So to understand that, I have created two different examples, one for byte stream and one for character stream. So let's take that concept first. Why do you need two different types of streams? And the reason is pretty simple. Whenever you are reading data from some data source or writing data to the data source, so the data can either be simple character strings like English characters or the Unicode characters, or it can be some tabular data sitting in a table in a database. It can be an XML file, it can be an HTML file, it can be literally anything. It can be a mathematical expression file, it can be an image. You don't know that. So that's the reason Java created two different types of classes, that if you want to work on a particular file which is holding characters, then you can use character stream. And if you don't know what kind of data the file is going to contain, then just use byte streams. Character streams also internally will be using the byte stream only, but it is much more simpler and much more faster to use character streams if you just have character files. Also, it is worth noting that when you're using character stream, the file will be read character by character. And when you are using byte stream, the file will be read byte by byte. So one byte at a time and one character at a time. So let's look at the byte stream example first. I've created a class called byte stream example. It has a public static void main method. And then I'm using the file input stream and file output stream classes. Basically, what I'm trying to do in this example is I'm trying to read a file and write to a file. And like I said, when we look at the theory, whenever we are using the input stream term, we are primarily doing a read operation. And whenever we are using the output stream term, we are writing something to the file. So for these kind of operations, Java provides, for file handling, Java provides these two classes, which are called file input and file output stream. So I create null references and then I enter a try block. And inside the try block, I basically provide a location to read the file from. So I've created a source.txt in the Java tutorials location. And if I show you what this source file is containing, so if I go to this location, Java tutorials, and if I open the source file, it just has a simple text which says this is a sample text file. Let me delete this dest.txt for now. So I just have a source.txt here, which is containing a sample text. This is a sample text file. So I am reading the source.txt using the file input stream and storing the output into this in stream, which is a byte stream. And I'm also creating another output stream where I will be writing the destination file. So I'm saying this particular location, write the file with the name test.txt. But these are still just containers. I haven't done much here. So you are going to initialize the reading stream and the writing stream, and then you are going to read one byte at a time till the time you reach the end of the file. The way to denote the end of the file, or the way Java tells you that you have reached the end of the file, is when the read operation returns -1. So you keep reading the file till the read operation returns the value as -1. Whenever it returns the value as -1, it means that you have reached the end of the file. So I'm going to read this source.txt byte by byte, one byte at a time, till I reach the end of the file. So I call instream.read. I store the output of instream.read into a variable called content. And at the same time, I also run this condition that till the time this output is not equal to -1, keep writing. Write where? Write to the out stream. So I want to write to this particular stream. So I call the write method. And remember, this is a byte stream, but here the output of instream.read was an integer output. So you need to convert this int output to a byte by doing the explicit casting here. So we do the explicit casting here so that the int content gets converted into a byte type, and then outstream.write writes that byte inside the stream onto this particular file. So that's what is happening here, that you load the in stream, you read the file byte by byte, and you start writing the output file byte by byte. That's what you do in this while loop. Once you have reached the end of the file, you will be broken out of the while loop because the whole file has been read, and whatever was written in that file has been written to the outstream to this particular file location. And then in the finally block, you close both of the streams. Remember, it's very important to close these resources. Otherwise, these resources will be present till the time Java runs a garbage collection. So it's very important to make sure that you close all the resources which you open in terms of file handling. These are costly connections and they take up a lot of memory. So make sure that you close them in the finally block. And that's why if you see, I don't have a catch block here, but I've put the finally block so that I can seamlessly close them. So that is what I'm doing here. And now if I run this, I don't get any output because I'm not printing anything. But if I go to this particular location and see if I have a dest.txt. So yes, our dest.txt has just appeared, which was not there earlier. And if I double click on this, it has the exact same text as I had in my source.txt. So the source.txt and the dest.txt have the same content because I've just written the source.txt to the dest.txt. So this is how you can use byte stream operations to do file handling. Now let's have a look at the character stream example. It is doing exactly the same thing. It's just that you have to use different classes. So instead of file input stream and file output stream, we are going to use file reader and file writer. So I create the file reader and file writer references. Let's call it as reader for simplicity. And let's call this as writer. So I initialize file reader and file writer, again pointing to the same location. Let me delete the dest.txt again so that we can observe the output. So I create the object for file writer and file reader, and I again do the same thing. I call the read operation. The read operation is going to return an integer value output, and I'm going to continue reading the file character by character. This time the byte is not read, but the actual character of the file is being read. So I'm going to read this file character by character till I reach the end of the file, which is denoted by this condition. And as the output is int, I need to convert this into char. So I cast the int output to a char output and then write it to the writer. Then I close the reader and writer both, and that's it. So if I run this now, and if I go back here, I will see dest.txt and I see the output here exactly as same. So in terms of output, there was no difference, but since this was a purely character file, the character stream demo is a better use case, or like file reader and file writer classes are a better use case. But like I said, there would be cases where you have to read it as bytes because, for example, if you're dealing with databases or if you're dealing with another type of files, for example, image files, etc., that will be traveling as bytes. So using a byte stream might be a better example in that case. And that holds true for any other different type of data source as well. So this is all I want to cover in this particular session. And in the next session, we are going to have a look at how we can connect the Java application to a database using JDBC drivers. In this example, I'm using the open source community edition PostgreSQL, but you can use any database vendor provider if you want to. If you want to use Oracle or MySQL, feel free to do that. But in this demo, I'm going to use Postgres. So you can download the Postgres Windows installer. Since I'm using a Windows machine here, you can download the installer from the official postgresql.org website. And you can also download the JDBC driver for PostgreSQL going to this particular official website, which is jdbc.postgresql.org. Similarly, you will be able to find the JDBC driver for all other database vendor providers as well. Once you download this, this is going to download a jar for you, and you can store the jar anywhere. Like I've put this jar into this particular location. You can see this latest JDBC driver jar for PostgreSQL. So for every database vendor, there would be a different JDBC jar which you need to download. So that's that. You install the PostgreSQL, you set up its database, and when you install the PostgreSQL, you also get a nice SQL client to talk to the database because database has a server and database has a client, right? So to deal with that, you install the server, and all these database vendors like Postgres, Oracle, Microsoft SQL, etc., they also provide a nice thin client with it. Postgres also provides a client. When you install the Postgres server, it will also ask you, or it will actually automatically install the SQL client for it as well, which is called pgadmin. So this is how the pgadmin client looks like. The current edition of it is pgadmin 4. So you will get that installed automatically. And once your Postgres server has been successfully installed, if you just go to search and type pgadmin, you will get this option. Once you click on this option, a new browser window will be opened and you will see this client here. You will not see this particular window. Let me close this one, but you will see something like this. You will see a server here. So you can go inside it. You will see a PostgreSQL edition here. And if you go inside it, you will see a database here. If you open the database, you will see the Postgres database by default created. So you can just right click on this and create a database here. You can name it as whatever you want. You can leave everything as is for now and hit save. Another thing which you need to do when you do the installation is it will ask you to set a database user and password. So choose whatever database username and password you are comfortable with, and you will be using that username and password in your program as well. So create your database here and just leave the database at this particular point. And now we will try to connect to this particular database. In the example which I prepared, I'm going to connect to this test database. So let's go to the JDBC demo and see what is happening there. So for this purpose, I've created a class called JDBC demo. It has a public static void main method, and there's a lot going on here. So let's take it step by step, and I will be keep shuffling between the database SQL client and this particular class to build a nice narrative. So if you think carefully, what you need to have if you want to connect to a database, the obvious answer is the address of the database. Where is that database? You need to know the location of the database to connect to it. So that is called the connection URL. Every database vendor will provide its own connection URL, and you can find that connection URL from the official documentation. There are tons of examples available for it as well, but always refer to the official documentation for that particular database provider. The general syntax is JDBC colon your database vendor's name colon / the host name. This can be any IP address or your local host. Generally, we also put a port here, something like this. 5432 is the port on which the PostgreSQL server runs. But again, you can put the port here on which your database server is running. Every database vendor has their own default port. The PostgreSQL server has the default port as 5432. So you provide the host name, you provide the port, and then you provide the database name. You provide the database name to connect to. So if you remember, I told you that I have written the program to connect to this particular database called test. So whatever that be, you provide that name here. And this is going to form the connection URL. I can remove this for now, but this is how the connection string is going to look like. And it is going to, it follows the same format for any database vendor, that you say JDBC colon, you write the database vendor name, and then you say colon /, you provide the host port, and then you provide the database name. So that is your connection URL. After that, to connect your Java program to a database, you need to use the java.sql.connection class. This is a very critical class and very important, and probably the single most important class which you need to have in your program if you want to connect to a database. So you say connection con equal to null. I'm just creating a null reference to it. And before we go any further, let me also tell you why we need this JDBC and what is actually this JDBC. So Java is a programming language. It does not come with its own database, but there are multiple other vendors like PostgreSQL, MySQL, Microsoft SQL, Oracle, etc. So Java wanted to provide a uniform way to connect to all of these databases. Because imagine all of these databases building their own API contract. It would have been a nightmare for the developers to connect to different databases or shift from one database to other database. And that's the reason Java created this nice interface called JDBC. And it said, whoever wants to connect to Java should follow this JDBC specification and provide their implementation, similar to the interface and concrete class thing. It's not exactly that, but you can think of it in that manner, that JDBC provides an interface with the method declarations. And then Oracle, PostgreSQL, MySQL, all these database vendors are supposed to implement that interface and provide their own implementation. But JDBC APIs will always remain the same. Whoever wants to connect to Java has to create a driver, and that driver contains that implementation. And that's the reason we downloaded that JDBC driver. And I will come to how do we include that, but that's the background of JDBC. And that's why you need JDBC to build that uniform contract and your vendor will provide their own jar, which will have the implementation of the JDBC interface. And in this program, what I'm trying to do is basically I'm trying to insert a record into a table. So what is a table and how do you create that? So let's go back here. So in this test database, you will see a schema. By default, you will see a public schema, and you can create a new schema if you want to, or you can just use the public schema. So inside the public schema, you will go under and you will see an entry for tables. So you just right click and you say create table. You can also write in complete SQL statement, but I'm just showing you how to do that in pgadmin. And you can give the table name, you can give the column information, and that's how you create the table. So I have created a table here, which is called student. And the student table has 3 columns: roll number, name, and age. If I show you the exact query or the whole create TDL for it, it looks like this. So I created the student table in the public schema, which has a roll number field, a roll number column, which is of type numeric. It has a name column, which is a varchar or a character varying, and it has a age column, which is again a numeric. So roll number, name, and age. These are the 3 different columns which I created inside the student table. So I have a student table with these 3 columns. So that's that. Now let's go back to the program. So I have the student table, and now I want to insert some records in the student table. So let me just change the values here so that we can see a different entry. So I have just hard coded some values. Generally, you will be getting these values from somewhere in the program. But for simplicity, let's say you have got those values. Once you have got those values, the next thing you need to do is to build the SQL statement, the exact SQL statement which which is going to be run on the PostgreSQL server. So you write that statement. In this case, I'm showing you a creation example. So it is going to be an insert query. So I say insert into table name, which is student, and then I provide all the column names. It is always a better practice to provide the column names in these brackets. Even if you're inserting the values to all the columns, still provide the column names. So I say insert into table column values, and then you provide the actual values as the roll number variable, which I created here, the name variable, and the age variable values. So I just supply the values here. Remember, when you are inserting the values, roll number and age are integer, so you don't need to put any single commas, single inverted commas for it. But name is a string variable, so I've put this single inverted commas. It's a simple string concatenation, nothing fancy here. So I'm just writing a plain SQL statement here and storing that into a string. Once I've done that, the next piece which I need to do is to get a connection to the database. And the way you are going to get a connection is by this uniform method. No matter which database provider you are using, you are always going to use the driver manager.get connection method to get a connection to the database. And how do you get the connection? You supply the connection URL, you supply the username to connect to the database, and you supply the password. In this case, I've just set the username and password as Postgres and Postgres. So Postgres is the username and Postgres is the password. Pretty lame, I accept, but this is just for demonstration purpose, so it's fine. But generally, you will be getting these values from some application property file. So these are the 3 parameters which you need to supply to this get connection method, and then you will get a live connection to the database. This is the line which is going to make it all happen to connect to your database server. So if this line gets executed successfully, you have a live connection. Once you have a live connection, the next thing which you're going to do is to create a statement object on the connection. Statement it can be anything. It can be an insert statement or a select statement or an update statement or a delete statement. Everything is a statement there, right? So that's why you need to create a statement object. So you create a statement object and then you execute the SQL. This insert SQL which you prepared, you're going to execute the SQL here saying st.execute update. Execute update is the method which is used for any insertion or deletion operations. So that's the method you're going to use and supplying the SQL query which you built with the actual values of roll number, name, and age. The execute update method returns the number of rows affected once this statement got run on the database server or the SQL query got run on the database server. It might impact 1 rows if it's an insertion. It might impact multiple rows if it was an update query, right? So it is going to return the number of rows affected, and that is what we are going to use to check if my insertion successfully went or my insertion failed. So if this execute update is going to return 1, which means that my row got inserted successfully in the database. So I'm just printing a sys out here. And if this particular M returned 0, which means none of the rows were affected by my SQL query, which means my insertion operation failed. So I'm just printing a sys out here. And then I'm just putting this in a catch block here to print any error, and finally closing the connection. This is again very, very important. Database connection is one of the costliest connections you will be creating when you will be writing your Java applications. Always and always make sure to close these database connections. Otherwise, your application is going to face serious database bottlenecks. So we close the connection. So that's all we are doing here. We prepare the URL. We just create a placeholder for connection object. We prepare our SQL query with all the relevant values. We get a connection to the database. We get a create statement. We get a statement object from the create statement method, and then we execute the statement. And then we can validate the statement execution if there is a way to validate it. Once you've done all of that, you close the connection. So let's run this program and see if we can see this new record inside the student table. And before we do that, let's also validate what is present in the student table as of now. So if I go here and I say view all rows, this is just going to run a select star on the student table. So currently student table has one record with roll number 1, name as John, and age as 20. And now I'm trying to insert another row with roll number 2, name as Jane, and age as 22. So if I right click and run as Java application, I get this entry which says inserted successfully, which is coming from here. Inserted successfully, and it also prints the exact SQL so that you can see what SQL actually got executed on the database server. This is the same string SQL which I built. So this is the SQL which got run on the server, which said insert into student values, and the roll number was 2, and the name was Jane with single inverted commas because this was a string, and then age was 22. This was the exact SQL which got executed. So my SQL has been executed, my connection has been closed. If I go back to the pgadmin client and if I try to rerun this query, now I get 2 records. So if you remember, this record was already there, but now I get this second entry, which is the new entry which just got inserted because I ran the program, and you see the roll number 2, the name as Jane, and the age as 22. So this was a very simple example to show you how you can do the JDBC connection. But one of the things which I still haven't covered is the usage of the JDBC driver, the jar which I talked about. So the way you are going to add the jar is you go to the project, you right click on the project, you go to the build path, go to the configure build path, and there you will see different tabs: source, projects, libraries. So go to the libraries tab and select the class path here, and you can choose the add external jars option. Click on this, load your SQL JDBC jar for your particular database vendor. For my case, it was PostgreSQL. Let me just quickly remove this jar and show you right from how it's done. So this is how it will look like for you. You select the class path, you click on add external jars, you go to the location where you have downloaded your JDBC driver jar for your particular database, select that, click open, it will come here, hit apply and close. That's how the jar is going to be there. If you don't provide the jar, your program is going to fail miserably. It is not going to work. So make sure that you have the jar, and then only it is going to be able to create a successful connection and be able to successfully execute the query. Remember, JDBC provides the specifications, and then the particular database vendor like PostgreSQL provides their JDBC driver, which has the implementation for that JDBC API. And that the Java has this uniform JDBC API, and every database vendor is expected to honor and implement that API only, so that Java developers can work on the JDBC contract and everything should work as is. So this is all I want to cover in this particular session. And in the next session, we are going to have a look at generics in Java. Before we go about generics, let's understand why do we need generics and what was the requirement that led to the creation of generics. So as we know that when we work in any object-oriented programming language, we created classes, we create objects, we create variables, and everything has a type. Everything has a type, and that type is static. The type cannot be changed. That's why we call Java as a strong type checking language at compile time. It checks the types of the variables of the classes at the compile time, and if the classes are mismatching or their types are mismatching, then you basically get a compilation error. But what we see as we moved along, we saw that we were creating the similar kind of functionality again and again in different classes. For example, if there is a login functionality which should allow a person to log in and we should also allow an application to log in, then these are the two different use cases, but the functionality still remains the same. So how would the login functionality allow both of the types of entities, be it user or application, to get into the application or log in into the consumer application? How do you do that? And that's what led to the creation of generics, that you can reuse the same code with different types of inputs. Remember, the stress here is on the types, and that's what it is mentioned here, that we will like to reuse the same code with different inputs. We will just keep changing the type parameters and we'll keep using the same code again and again. It has some benefits over the non-generic code, like I mentioned earlier, that when we work with the non-generic code, we have the statically assigned types to the variables and objects. And if we use generics, then we don't have to do that. And at the same time, you don't even have to explicitly cast them. I already touched upon this concept of generics in different bits and pieces in different sessions throughout this tutorial series, where we saw that whenever I was creating a list, I was supplying this type into these brackets, right? And I told that this is the generic type. But now we'll go deeper into this concept and we'll see how we can create our own generic types if Java does not provide it. So with that, let's move to an example and see how we can implement our own generic types to create generic code where we can supply the types dynamically. So I've prepared an example for this. I've actually prepared two examples for this and we'll go through both of them one by one. So here what I'm doing, that I'm creating any class. You can think of it as any class holding any functionality which is applicable to multiple entity types. Think of it as the same login class which I just talked about. So if your class has a functionality which should be reused by many different types, then one of the way to not repeat the code or repeat the class or repeat the functionality again and again is to make that class use a generic signature. And how you do that? You write the class name and then you put these brackets and you just type T. You can write any variable A, B, C or whatever you feel like, but T is sort of the default standard the Java developers have been using since generics was launched. So you put this T here. Now, whoever calls this class or whoever initializes this class will have to supply the type of the class on which this particular functionality is going to get executed. Now, remember the collection examples I took in the past series. What if this was a list class? Because we have used the exact same syntax, right? We use list, we put brackets, and then we wrote string, and we said, okay, now this list is a list of strings. If we said list of integer, then we just write integer in these brackets, and that list became a list of integers. So you see the same list was being reused for different data types. And the exact same concept is applied here for your custom classes and your own custom functionality. So I write T here, then I can do whatever with this T I want. So I just put a reference of it inside the class. I create a constructor. Constructor is also assigning the T type. I do a get object, and that's all. It's a very simple toy example, but just to get the point across, you can write as complex logic as you want inside the class, depending upon your use case. But this is just a straightforward example that you can use generics in the classes as well. Once you do that, then how do you initialize this class? So let's have a look at that as well. So I've just created a public static void main method inside the same class. Obviously, you can create this method outside this class as well. There's no stopping that logic. But for the sake of simplicity, I've just put the main class here. So it's a simple public static void main method. There I am initializing the single generic holder class, the same class. And here the T type is of integer. This T type can be of anything else as well. For example, your own student class can also be supplied here. And then this single generic holder will become of student type. In this case, I'm just using a pre-built Java class. So this single generic holder becomes of integer type. I give a reference, I create an object, and I provide a value to the object. Because you see the constructor is this. whatever t you supply, so if the t is the integer, this t becomes integer, and this obj is going to hold the value 10 because that's the constructor being called here. And after that, you can do whatever you want in terms of the logic. Here, I just have a get object method. So I'm just calling that method and printing the object. That's all. Similarly, you can also initialize the same class with the string type. So you see, I'm reusing the same class and the same functionality again and again for different class types. So this time I'm using the string type instead of integer, and I'm supplying a string parameter this time. And this constructor still will work because this is generic. When you created with integer, this constructor, this t, became of integer type, and when you initialized it with the string type, this constructor started accepting the string objects. So I just supply a string called SimpliCode, and then I call getObject. So let's run this method. So when we run the main method, from the first invocation at line 16 and 17, when you call the getObject, the value of the object gets printed, which is 10 for the integer, and then at line 20, the value of the string gets printed, which is SimpliCode. So that's how you can use generics inside a class or for a class. Now, there might be use cases where you have to create a class which can accept multiple types of generic types. Let's take an example. If you remember when we talked about hash map, we had the exact same situation. So you had the key and you had the value. Now, key can be of any type, any data type. It can be string, integer, whatever. And then value can also be of any data type. It can also be your custom data types. For example, the key becomes a roll numbers and the value becomes student object. So map is a situation where you have two generic types. So I'm just trying to replicate that similar kind of behavior, that if you have to create a class with 2, 3, as many generic types as you want, you can still do that by just providing a comma here. You can go on doing as many generics as you want. In this example, I'm using 2 generics. And then it again goes to the same drill that I created references for both t and u. I have initialized both t and u in the constructor. And then I have a display method, which is going to call display the obj1 and obj2's values, or they are two string methods basically, because when you try to call the object inside the system.out.println method, by default the two string method of the object will automatically get called. So that's all I have in this particular class. So it's a simple class accepting two different types of generics and then calling the display method. And here is the public static void main method for the same. Here I am initializing the dual generic class, and here the t is string and u is integer. So these t and u are assigned these class types. And then I create the class. I again write the same types and I provide the value. So for the string one, I provide SimpliCode. For the integer one, I provide 10. This constructor gets called. obj1 gets the value SimpliCode, and obj2 gets the value 10. And then I call display method. There I am printing obj1 and obj2. So let's run this method. Okay, I'm getting SimpliCode and 10 because when I call the display method at line 13, obj1 gets printed. obj1 is holding SimpliCode value, and at line 14, obj2 gets printed, or the toString method of the obj2 gets printed, which is holding the value 10. So this was a quick tour to tell you how can you use generics. You can obviously use generics in the variable types as well. You can use generics in the method argument types as well, wherever you want. The simple idea is that one, you would like to reuse the functionality again and again. And second, you would not like to have a strong, strict type checking. And like I said, try to relate these generic concepts with the collection framework we listen, because collection framework is completely built upon the concept of generics. Whenever we initialize a list or a map or a hash set or a linked list or array list or anything, we always supply the type. And the type is coming from these. If you look at the implementation of array list class, you will see that. Let me see if I can open that for you to show you how that looks like. If I go to an example of collections, and if I try to just open the class, you will be able to see that. Yep. So if I click on this list class, you see list of E type. So here E is the type which you are going to supply. So in this particular case, when you say list of integer, this integer gets typed into E. So this whole list class, whatever operations you're doing inside the list class will be applied for the integer type. So similarly, you can look at other collection classes and you will always see these generics everywhere in the collection classes. And that's all I want to cover for this particular session. And in the next session, we are going to look at different examples of string handling. So string handling has a lot of utility functions and APIs which can come very handy, and we will have a deep dive onto that particular topic. String class is very versatile in Java, and it provides a lot of handy functions which can help you manipulate strings in multiple ways. For example, if you want to trim a string, or if you want to append a string to another string, or if you want to find a particular character at a particular index, or if you have an index and you want to see what character is present at that particular index, or if you want to do any other kind of pattern matching in the string. So string is very versatile in that context. And today we will have a look at some of those methods. So I've just opened the Java docs API for string, and you can see in the method summary, you will find a long list of methods. We will go through some of these methods. For example, if I just show you a snapshot of what I'm talking about, it has a char at method. So you provide an index, an integer index, and this particular method will tell you which character is present at that particular index in the string. Remember, string is basically a zero-based character array, zero index-based character array. Similarly, you can also call code point at, which is going to return the character in the Unicode code point at a specified index. Similarly, compare to method can be used to compare two strings with each other. Compare to ignore case is also there, which can compare two strings, ignoring whether they are in uppercase or lowercase. You can use concat method to join two strings together. You can use the contains method to find if a particular character or a particular sequence of character exists in a particular string or not. You can do a content matching. You can do copy. You can also see if a particular string ends with a particular character or a sequence of characters. So there are tons of different methods available here. And please do check out the API, because like I said, this is going to come very handy when you start writing real-time projects or the real life projects. So with that knowledge, let's go to our IDE and let's have a look at some of these examples in action. So here also you can obviously have a look at the string class from the IDE itself. Just write string and hit control, and you will see an underline and a hyperlink. So just click on this and the string class will be opened, and you can actually read on about the documentation of the whole string class. But we are not going to do that. We are going to have a look at some real life examples of how we can use different methods of the string class. So here I've created two strings, str1 and str2. str1 is holding a string which says John is studying, and str2 is holding a string which says in college. Now, the first utility function which I'm going to talk about is the length method. So if you want to find out what is the length of this particular string, then you can just call the length method on the string, and that is going to return the length of the current string. Let's see that in action. Let me comment the rest of the code, and let's see this one in action. So if I run this program, I get the value 16. So if you count this, 1, 2, 3, 4, space is also counted, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you get the exact length of the string when you call the length method. Similarly, another method is concat method, and concat method is used to concatenate two strings together. Concatenation basically means joining two strings together. So if you want to join the string 1 and string 2, then just call str1.concat with the string you want to append or you want to concat. So the concat method on the left-hand side of the string is going to get concatenated with the argument which you pass in the concat method. So let's see that in action now, and let's see the result as well, because I'm storing the result of concatenation into a new variable and printing that variable. So I get this whole text here, and you see the studying in just got merged. There was no space in between because there is no space here. If you just put it like this, and if you rerun this, you will see the proper space as well while concatenation. One of the things which I also want to call out is strings are immutable in nature. When I say immutable, it means that once you have created this str1 holding this value, then this particular object's value pointing to str1 cannot be changed. You cannot mutate the strings. If you try changing str's value, Java is going to create a new object and point str1 to that object. but the object which was created initially is not going to be overwritten. So remember that concept that whenever you're doing manipulations on the string, the previous string object still remains there. It doesn't get overwritten or it doesn't get modified. Whenever you modify a string, you get a new object. That's the property of string. So we saw the concatenation. Let's move ahead. There's also a format method. Format method is used to dynamically populate some parts of the string. For example, if you have a long list of students and if you want to print the name of students, then what you can do here is that you can you can assign those names to certain variables, and you can point or refer those variables in the string with the percentage syntax, percentage S syntax basically. So the string.format method is used to supply dynamic values inside a static string. So in this case, this part of the string is static, where I'm saying the name of the student is. Then in the next string, remember plus also can concatenate it. It is also doing the exact same thing as the concat method. It's just a shorthand. So I'm creating first string, then I'm creating second string, but here I'm writing percentage S. I will come to that. And then I've created one more string where I'm using percentage D. So what happens that Java format method supports certain special type of references. For example, if you want to dynamically place a string, you can use percentage S. If you want to dynamically place an integer value, you can write percentage D in the format method. Similarly, you can also write other percentage F for a float value, and there are more other similar placeholders which are available in the format method. So do check out the format method documentation if you want to know what all percentage types or variable types can be dynamically placed inside the format method. Here I'm just using percentage S and percentage D. And then once you have created the first part of the format method, which is string with dynamic placeholders till this particular point, then you put a comma and you start providing the values. Remember, the sequence of the values have to be exactly the same way in which you have used them here. So if percentage S is coming first, then you have to supply a string value. If percentage D is coming after that, after the string value, you have to provide an integer value. If there was another percentage S after percentage D in the same string, then after 21, you had to provide another string value. So that's the contract which format method needs to honor. And if I run this particular program, and if I try to see the output, let's try to see the output as well. And for the output, I need to store this whole string.formats output into a variable. So let's say I say string R, and then I can print R and see what comes out. So that's it. Let's run the program now. And now you will see this line. The name of the student is John, comma, and the age is variable is 21. I think it's coming because I've just wrote variable is here. But if you remove this and if you say the age is percentage D, then you'll get a nice human readable output without any extra formatting. So the name of the student is John and the age is 21. And that there was a comma, that's why you still see the comma. But this is the basic idea with using the format method. Now, another method which I want to talk about is the char@at method. Let me comment the previous output so that we can follow along. So I'm just going to comment all of this, which we have covered already. And let's focus on the char@at method. So char@at method can be used to find the character present at a particular index in a string. So whatever index you specify in the char@at method, the character present at that particular index will be returned. So when I say str1.char@5, remember strings are 0 based indexed character arrays. So 0, 1, 2, 3, 4, 5. At 5, I is present. So this char@at method should return I. So if I run this particular program, yes, I see the output as I. Now let's move ahead with the next example or the next API call. The next API call is the usage of equals method, where I can see if the two strings are equal or not. So here I'm saying str1.equals str2. If both strings are same, it is going to return true. Otherwise, it is going to return false. So if I run this, I get the output as both strings are different. It goes in the else block because str1 and str2 are different. They are holding different values. So here the exact content of the string is going to be matched. The next one is the index of method. So index of method can be used just for the reverse functionality of char@. In char@, we were supplying the index and getting the character. Here we can supply the character and get the index of it. So what is going to happen that you write the string dot index of, and then you supply the character for which you want to find the index of. So I supply y here, and if I run this particular program for this line, the output is 12. Let's see if the output is correct. So here, if you try to find what is sitting at the index number 12 in this string, so again, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So yes, y is present at the 12th index, and that's the output I get. What if you provide a character which is not present in this particular string? Let's say z, which is not there, and see what the output is. In that case, you will get the output as -1. So if the character is not present in the string, you will get the output as -1. Another thing, what if the character is present more than once in the string? For example, I is present more than one time in the string. So if I write I here, whether I get the index of this I or this I, let's see. So I'm going to run this program again, and I get the value 5. So 5 is basically this I, because this I is definitely not 5. It's farther index. So the first match of the index is going to be returned in terms of the index of method. Okay, so that was about the index of. Let's look at the next one, which is the replace. In replace, it's as the name suggests, you can replace a character or a sequence of characters in a string by calling the replace method on the string on which you want to do the manipulation. And remember, you're doing the manipulation here, so the previous object is not going to get overwritten, but a new object is going to get created. So what I want to replace is with R. So in this particular string, I see an occurrence of S here. So this S should be replaced with R if the replace functionality works as I just explained. So let's run this program. And yes, I can say instead of S, I see R being replaced there. And that's the usage of the replace method. Next one is the split method, where if you want to split the string into multiple elements, so you just call the split method and you provide the separator. Here I'm separating the string whenever there is a space. I'm basically breaking up the string into multiple substrings. That's what I'm doing here, or multiple strings, I would just call it as. So whatever separator you provide, whenever the string is going to encounter that separator, it is going to split one part of it. So I'm providing the separator as space. It means in this particular case, I'm going to get 3 items. The first breakup is going to happen here. So the John part of it will go out, and is will go out in a separate string. Then again, between is and studying, I have another space. So there will be another break here. So I should get 3 elements if I call the split method. One element will be holding the value John, the second element will be holding the value is, and the third element will be holding the value as studying. And then I'm printing all the elements of the array. Remember that split method returns a string array. So that's what I'm using here to store the output of the split method. And then I'm just using the streams API to iterate over this string array, outputting or printing the each element of the array. So let's run this program. Okay, so I can see 3 different outputs through this system.out.println. First John, then is, then studying. Like I said, split method is going to create a 3 element size array of strings because I'm separating it based on the space. The last utility function which I want to talk about. So this is the last one, but I'm skipping some more due to the interest of the time. But like I said, do check out the documentation to read or understand more about other string utility methods, which I'm not covering here in this session. So the last one I'm going to talk about is the substring method. And substring is basically going to take a mini string out of the long string. So what if you want to trim the string? What if you have a long string and you only want to get a part of the string? So you can specify the starting point. You can specify the end point, and whatever string characters are present between the starting index and the end index will be taken out from the string, and you can store that output into a new string and print that. So here I'm calling the substring method, providing the starting index as 1 and the ending index as 5. Let's run this program and interpret the output. So I'm getting the output as OHN. So what is happening here? Let's go back to the str1. So I said start with 1. Remember, string is a 0 based index. So It starts with 0, 1. It starts with O because O is present at the first index. And then I'm going up till 5. So 1 gets printed, whatever character is present at one index get printed, second index get printed, third index gets printed, fourth index gets printed, which is just a space, and then the fifth index is I, which is not printed here. So it means that when you call the string substring method, then the end index position will not be printed. It starts from the beginning index and it will go till end index minus one position in terms of printing. Because if you select this, you'll see an extra bar here because the space is also getting printed. So it is printing everything before the fifth index. It will not include the fifth index character. Remember that when you use the substring functionality, that the end index is not included in the substring. If you want to include that, you need to increase the index by 1. So for example, if you want to print I as well, then you have to write it as end index as 6. And if you run this, then you will also see I now. Yep. So that is how this substring functionality works. And that's all I want to cover in this particular session. In the next session, we are going to have a look at some of the methods and utilities of the java.lang package. Java.lang package is one of the most core and fundamental packages in Java, which is provided out of the box to the developer. You never explicitly import this package in your Java program because you don't need to. Java provides this automatically the moment you create a file with .java extension and you are running that particular program inside or on a JDK, you get the java.lang package automatically. For example, when we were running the string handling demo, I was using the string class, but I never imported this string class. You can see there's no import for string because string class is also part of the java.lang package. It's automatically imported for you. You never need to explicitly import the package or any classes of that package. So this is going to be more of a theoretical lecture where we will just have a look at or a quick overview of all the java.lang package classes and other utilities. You don't need to remember all the classes and utilities, but this is just to give you a sense of what all it contains. So in terms of the interfaces, it has the appendable interface, auto-closable, char sequence, clonable, comparable. If you remember, we also used comparable when we were writing the comparable implementation to compare different objects in a collection. So this also comes automatically as part of the java.lang package. Iterable, runnable, again, we use this in the threading example. So this also comes automatically to you. You never need to import the runnable class from the java.lang package. When we move to the classes, all the data type classes which you can think of in terms of Boolean, byte, character, class, class loader, compiler, enums even, float, integer, long, math. So all the classes which we were using, the data type classes which we were using in different examples are also part of the java.lang package. Okay, so this is a long list. It also has the thread class. So whenever you are creating thread, you again never imported thread class, but it still just worked fine because this was also coming as part of the java.lang package. There are also a bunch of enumerations which it provides in terms of Unicode, thread state, etc. It also provides exception classes like arithmetic exception or the different runtime exceptions which we dealt with, like array index out of bound, array store, class cast, class not supported, the root exception class. So a lot of exception classes also come as part of the java.lang package. It also provides some error classes. If you remember when we talked about the exception framework, you have the error types and you have the exception types. So it also provides some error classes. If you want to use that, you never need to import any of these classes and you will automatically get them from the java.lang package. Similarly, it also provides some annotations as well, like functional interfaces, or you remember we use this annotation a lot, the @override annotation, but we never imported the override class or the override annotation because it's part of the java.lang package. So this basically tells us that there are a lot of different classes, utilities, enums, errors, exceptions, data types, which are provided out of the box from the java.lang package, which makes our life so much easier whenever we want to work with Java, because we don't need to import the very basic classes which we use very frequently. And another very important package is the java.util package. We have been using the java.util package in all of the collections, examples, and tutorials we walked through in this whole tutorial series. So let me just open the java.util package for you. So if I go here to java.util and I will be able to see the java.util packages, different classes, etc. Yes. So here it is, the java.util package. And remember, java.util package is not imported automatically. You have to explicitly import the java.util package to use the classes of it. So that's the difference between java.lang package and java.util package, that you can use the classes coming from the java.lang package without explicitly importing those classes or importing the java.lang package. But java.util package is something which you have to explicitly import in your Java program to make it work or even make it compile. So what java.util provides? First of all, the collections framework. The whole collections framework comes from the java.util package. So for example, all the interfaces which we use while we work with the collections framework classes, interfaces like collection, list, set, map, you can see the map interface, you can see the list interface with the generics. So all the interfaces which we use from in the collections framework are present in the java.util package. Similarly, when we talk about the classes, all the concrete classes implementation of the collections framework in terms of array list, linked list, hash map, hash set, tree set, tree map, you will see all of those classes here. Here we are covering all the, this is showing all the classes summary. So you see some abstract classes, and you will also see some concrete classes as you move further down in this particular list. So you see hash map, you see hash set, hash table, linked hash map, linked hash set, linked list. We used all of these classes while we were going through the collections framework tutorials. So it provides all of these and a lot of other classes like the scanner class, which we covered in the Java project for taking the inputs from the command line from the user, stack class again from the collection, some time classes. And it also provides a bunch of enumerations like the locale, basically setting the language categories for a particular program. It also provides some exceptions which we used while we were working with the collections framework. So most of these exceptions are or some of these exceptions are related to the collection classes. For example, the concurrent modification exception gets thrown whenever the whole execution detects concurrent modification of an object when such modification is not allowed. You will see other different types of exceptions like illegal format, etc. in this particular exception section of this particular package. Then it also provides just one error class as well. So this is what the java.util package contains. And just to refresh your memory, whenever we ran any collection demo, we always imported the java.util classes. You can see this is all coming from java.util. So this is something which you have to import, without which your program will not even compile. So that's also one of the difference between the java.lang package and the java.util package. And that's pretty much all I want to cover in this particular session. So we basically did a quick tour of the java.lang package and the java.util package. And like I said, it's impossible to cover all of that or all of the classes and enums and interfaces and errors and exceptions with all the examples. So I would suggest you to just keep this in mind about the java.lang package and java.util package. I told you the basic concept that java.lang contains all the types, the class and the variable types or the data types we dealt with, and java.util majorly contains all the collection classes. That's the basic thing which you need to remember whenever you work with Java. And your java.lang package never needs to be imported, but java.util package needs to be imported always whenever you use the util classes. And that would be all for today's session. In the next session, we are going to have a look at networking classes in Java. So when we talk about the networking in Java, Java has a whole dedicated package called java.net package, which has all the different classes which you need to have to write a networking program in Java. So you will see a bunch of classes with two classes, most important ones, which are inet4 address and inet6 address. So as you can understand that inet4 address is the class which can be used to represent the IPv4 addresses, and inet6 address class can be used to represent IPv6 addresses. And then you can learn about sockets. It also has socket classes. It has a lot of interfaces, with the prominent one being the networking interface. There are some high-level APIs. For example, the URI class is there, which can be used to represent a universal resource identifier as specified in the RFC. And this is just an identifier. This doesn't provide the means to access the resource. If you want to access the resource, then you need to use URL, which is the class representing the universal resource locator, which is a slightly older concept than URI, but with URL, you can hold the address as well as access the address. URL connection is also one of the class which is created from the URL class to set up a communication link with the URL. And similarly, HTTP URL is for an HTTP connection, and you have protocol handlers. There are a lot of interesting classes which you can explore if you want to learn more about what all networking support Java provides. But when we talk about the basic ones like IPv4 address, the URL, URI classes, these are the ones which generally most developers interact with. If you want to write a socket programming socket program, then you can still do that with the classes and interfaces support provided by Java. So you can see a bunch of interfaces here, cookie policy, socket option. Then in terms of classes, you can see again content handler, cookie manager, HTTP cookie, INET4 and INET6 address with the classes which I talk about. It also has a generic class, but I would always recommend to use one of these if you know what address you're dealing with. The URL connection, the jar URL connection class, proxy class, some bunch of socket classes, URI URL classes, and some enums and exceptions as well, which are related to networking connections. For example, malformed URL, if the URL itself is not correct, then you get a malformed URL exception. Socket exception, if there's a socket timeout exception, then also you have a dedicated exception for that. So there are a bunch of different exceptions, classes, enums, and interfaces available, which you can have a look at if you want to dig deeper into it. So I've also prepared a demo where we will be using some of these functionalities of this particular package. So let's jump to the IDE and see what I've built. So here I have created a class called networking demo. And what we are trying to do that we will provide the SimpliLearn URL, and we will try to get bunch of information about how this website is hosted. So you just create a simple string variable and you can type any string. You can write any favorite website of your choice here. And then we create the inet address class. And like I said, you always use the concrete implementation of the inet address class, which is in this case, inet4 address. So I use the get by name and we supply the URL to get an inet address object. And what does inet address contains? It contains all the information in terms of the internet address on which that particular website is hosted. So you will see a lot of different functionality in this class. Let's explore some of the functionality and methods which are provided by the inet address class. So once you do this, you will get an inet address object if the URL is correct. If the URL is incorrect, you will get a malformed URL exception anyways. If you want to just see the address of the IP address where this particular website is hosted, you can call the get address method. And if you want to see the host address method, then you can call the get host address. Now you might be wondering what is the difference between get address and get host address. So let's get first that out. Let me comment the rest of the code and let's first focus on this particular part. So let me comment the local address part as well. We will come to that in a while and I can just remove this comment. So we are printing the get address and the get host address, and let's see what values do we get and how do we see if it's a different value. So this explains, right? When we call inet address.get address, we just get all the values. As we know that when we deal with IPv4 address, the address has 4 values, something dot something dot something dot something. If you want to verify it, just go to your own laptop and you will be able to see some address like 192.168.something.something. So that IPv4 address has 4 sections, and all the 4 sections will have some values. So if you use the get address method and you try to convert this into a string, it basically will return an array. The get address method will return an array which will look like this. But if you want to see it exactly in the format in which the real world networking protocols understand it, then use the get host address, which is going to show it exactly in the way in which we write the IP address, where we write some integer dot some integer dot some integer dot some integer. So that's the difference between get address method and get host address method. Same value, different representation. The next function which I'm going to talk about is about local address, and the local address or the method name is any local address. So this method is going to tell me if there is a wildcard address which is associated with this particular host. You can also see what this method is doing from the documentation. So if you go to the documentation and if you search for this particular method in the inet4 address class, you will see it says utility routine to check if the inet address is a wildcard address. The result will be a Boolean, which will indicate if it has a wildcard address or not. So let's run this program and understand if it has a wildcard address. No, there is no wildcard address associated for this particular website. Similarly, there's another method which we can explore, which is link local address. So let's search for the documentation of it first. So this is the class. If you search it, it will just show you the exact class which is present with the method. And this method provides basically a check to see if the inet address is a link to a local address within the domain of the website. So the result again will be a Boolean. If it says true, it means there is a link to the local address. And if it returns false, it means the address is not a link local unicast address. So let's see the output of this with respect to the Simplilearn website. So if I run this program now, I again get false. So there is no wildcard address attached or associated with the website, and it does not point to a local unicast address either. Is there a loopback mechanism? Now, these all are networking concepts, and since this is not a networking session, so I will not go deeper into what a loopback address means in detail, but to give you an understanding of where it present and how you can use this in Java is what we are going to focus on. So if you want, you can always read about what is a loopback address. But if you want to know if the URL which you are pointing to is the address which is returned by that website has a loopback address or not, then you can use the isLoopback address method. And this again returns true or false based on whether it has a loopback address or it does not have a loopback address. So if I run this particular program, I get the output false again. So no, the Simplilearn website does not even also have a loopback address. The last one, or the second last one, which I want to explore is the site local address method. So let's see what does this method do. Let me just remove this extra commented lines. So let's look at the documentation of this method. So this says a utility routine to check if the init address is a site local address. The result is a Boolean indicating if the init address is a site local address, or false if the address is not a site local unicast address. Again, this concept is again a networking special concept, similar to the loopback address. So this is just basically showing if the site also has basically a local unicast address associated with it or not. So if you want to see the site local address output, I have enabled that code, and if you run this particular program, we get false for that as well. Yes, that means that the Simplilearn website is built with pretty good practices. There is no loopback address, there is no site local address, which we don't need for this particular website in this case. The last one is just a simple thing just to see the hash code. It's not much of a relevance, mostly in the programs, but just to tell you that this is also available. So you can also see the hash code, which is contained by the inet address object. So we covered a bunch of functionality in this particular example. We had a look at the java.net package. It has an inet4 address class and inet6 address class, a lot of networking exceptions and interfaces support as well. And the simple way to use it is to you point it to a website, call the get by name, call the get host address, and you will get the IP address in the exact format in which the networking world deals with it. Similarly, you can call the get address to just get an array of it, just as we saw here. And then there are a lot of utility functions available in the inet address class, like is any local, is link local, is loopback, is site local, and there are actually more. If you look at this class, you will find more methods here. In terms of what, like for example, it also has a is multicast address. This is basically to check if the init address is an IP multicast address. So there are a lot of different methods here. There are some MC methods as well, which will check, which are specially created for the multicast address scenarios. So a utility routine to check if the multicast address has a global scope, if it has a local scope, or sorry, it has a node scope basically, or it has a link scope, or it has a site scope. So there are a lot of different methods available for the multicast as well, which you can have a look at. And we already covered the get address, the get host address, and the hash code address classes. There are some URL classes as well. Like I mentioned, URL and URI classes are also very important classes, which you might need to use whenever you are building a connection with a particular application based on their URL. If you're doing socket programming, there are socket classes available, which you can also use while using the networking concepts in Java. So you can build a pretty decent and robust application using the networking classes and the networking support provided by Java to build a networking application. And that's all I want to cover for this particular session. And in the next session, we are going to have a look at the image handling concepts in Java. How can we handle images in Java? We deal with images on a daily basis, and you will often be required to deal with image handling in Java programs as well, where you might need to read an image or write an image or load an image into memory and do other kind of manipulations on the images. So Java does provide support for image handling as well, and you can pretty much load any type of image, be it a GIF image or be it a PNG or be it a JPEG image. Basically, it converts into a Java 2D image to render it, and it basically creates a byte representation of the image to serve and save the contents. So in this section, we are going to talk about the image handling aspects of Java. And to do that, there are broadly two classes which Java provides. As you can see in this official documentation, the first one is java.awt.image class. And the second one is java.awt.image.bufferedImage class, which extends the image class. So this is basically the super class, as you can see here, which you can use to represent any kind of graphical image as a 2D array of pixels. And buffered image is a concrete implementation of the image class, which you can use to construct instances of the class. And buffered image is sort of the, I would say, the de facto standard or the go-to class whenever you are dealing with any kind of image rendering tasks in a Java program. And we will also have a look at how we can use the buffered image class to basically read a sample image and also write a sample image to a file system. So you can read more about this in the documentation, and there are also a bunch of documentations available in terms of how you can read it, how you can load it into the program, how you can draw an image, how you can create and save the image, etc. And like I mentioned, we will be covering some aspects of it in today's demo as well. So this was a very brief theoretical introduction about image handling. And like I always mention, if you want to know more about this, do check out the official documentation of Java, where you can learn more about the image handling classes and utilities. So with that, let's move to the demonstration part. So I have prepared a demo here, which talks about image handling. So I've created a class called image handling demo, which has a public static void main method. And I'm just giving some sample dimensions for the image in terms of width and height here. And then, as I mentioned, that we will be using the buffered image class. So I'm creating a reference for the buffered image. It's currently assigned to null. So basically there's nothing. And then I am calling the method read from file. So like I mentioned, you mostly will be dealing with reading from an image or writing to an image. So here we will look at both of the aspects as to how you can load an image from your file system into a Java program and then write it back to the file system from your Java program. So let's first look at the read from file method, which will tell us how we can read a Java file. So I provide some sample dimensions. These dimensions will vary based on your use case, and I supply the buffered image object. Inside that, I have created a try block, and in the try block, the first thing you need to do for image handling is to basically create a file object, because image is also technically just a file, right? So you provide the file image path here at this particular location. So let's go to the sample image path. This is the destination path, and let me open the sample image path as well, which is somewhere in the C drive. So this is the image which we are loading. This is the path which I have mentioned, which is c/sample.jpg. So let's first have a look at the image as well as to what this image contains. So this image is basically from a clinical trial and showing some blood sample or some vaccine bottles, which is probably the very popular image nowadays because we are living in this pandemic world. So this is the sample image which I've chosen to read, and then I will load this into the Java program, and then we'll try to write it back to the file system to a destination location. So this is where my image is present in the C drive named with sample.jpg. And this is what I've supplied here. So you just need to supply it in double quotes. Remember, when you're dealing with Windows file system, you always have to use double forward slashes, which is different if you're working with on a Mac machine or you're working on a Linux system where only this will work fine. So that's a bit awkward thing which Windows has and you have to respect the operating system's restrictions or way of doing things. So once you have loaded the file or created the sample.jpg file object, then the next thing we are going to do is we are going to create an object of the buffered image. Remember, we just created a reference. We did not create an object yet of the buffered image class. And now is the time to do that. So we supply the width, we supply the height, and then we supply the type of the image. Let's go to the constructor of this image to see what this image type means. So this image type can be basically the type of the created image, which comes from the color space. So whether it's an RGB image or ARGB image or BGR image or byte gray image, there are multiple different types of images in the media space. And whatever type of image you have, you need to basically supply that image type in this particular argument. So in my case, it was an ARGB image, so I supplied that particular. If you click on this, you will see that currently it's inside Java. An 8-bit RGBA image basically has a static constant, which is denoted by 2. You can read more about this inside the buffered image class documentation as well. So once I've supplied that, my buffered image object is ready, which has all the details, dimensions, and the types of the image. Now, the next thing is that you need to fill this image object with the file. So you basically need to read the file and store the output of this read operation into the buffered image object. Then what will happen that along with this information, whatever is present here will also be added to the same buffered image object. So to read a image or simple a file, Java provides an IO utility, which is called image IO. And there is a read method available, which is a static method on this particular class. As you can see, I'm calling the class dot method name here. And then you supply the sample file name. Once you have done that, then it will basically be reading the whole image into a 2D byte array and copying that over into this buffered image object. Once that is done, if this particular line is successfully executed, then you will get this message, which will say reading complete, and it will try to print some hash code of the image object. And after that, if there's any exception in this block, for example, this particular line may raise an exception, or this particular line may raise an exception if the file does not exist, then you need to have the IO exception caught. Remember, IO is a checked exception. So if you are using these operations, file, new file, and image IO.read, you need to catch the IO exception because it's a checked exception. So either you need to catch it or you need to rethrow it. These are the only two options you have with a checked exception. So once we have done all of that, if everything goes fine, if everything is happy till line 35, then we just return the image object and our read from file operation will be done. Going back to the main method, once the read operation is done, the next thing I'm going to do is writing this image object to a new destination file. So let's see what is happening in this write to file method, because this is the method which is responsible for writing this image to a new destination location. So I've created a public static void method inside the same class where the public static void main method is present. As you know that static methods can only call other static methods. That's why this had to be static. And I'm supplying the same image object which was returned from the read operation. That goes in as the argument of this particular method. And again, I'm using a file object. And this time I'm providing a destination location where I would like to write this image. So this is the destination location I've chosen, which is F drive Java tutorials folder, and the image should be stored with the name out.jpg. So this is the location. There's already an out.jpg here. So let me just remove it so that we can observe the output. So we create the file object. After that, we again use the image IO utility. We call our static utility method called write. We supply the whole image object. We supply the image type extension, and we supply the output location. Again, if I take you to the signature of this, you take the rendered image, you take the format name, which is JPG, and the output location. So these are the three things which you need to supply once you call the write method on the image IO utility class. Image IO is a very handy class, and do remember this class whenever you are dealing with the image handling operations. It will provide a lot of static convenience methods. So we write this write this image object to a file, to a destination location. And if everything goes fine in these two lines, we will get this message, which will say writing complete. If anything goes wrong, we again catch the IO exception, and the exception will be printed here. That's all is happening in this particular program, where we are reading from file and we are writing to the file, reading it from here and writing it on this particular location. So let's run this program and see if we are able to read from file successfully and also write it to the specified location. So run as Java application It's a slightly memory heavy operation, so it takes a bit of time because the whole image needs to be loaded into memory. Be very careful about that. It might eat up a large portion of your RAM if the image is too heavy. So here it says reading complete, and then it prints the hash code details of this particular object. And then it also executed the write to file method, and it said writing complete. So just to show you the reference back again, this is what we read, sample.jpg in C drive. And if I go to the F drive, Java tutorials, where I provided the output location, I do see an out.jpg here, which was not there earlier. And if I double click on this, it's exactly the same image. So Java was able to read the image and render the exact same image by converting the 2D byte array representation back to an image exactly the same form. There's no change in this image. So this was a very short and lightning tutorial for you to show you how you can use image handling classes, for example, the image IO class and the buffered image class to do basic image handling operations. Obviously, you can do more complex operations with it as well, but for the demonstration purpose, I've just kept it simple. And that's all I want to cover as part of this session. And in the next session, we are going to talk about the concurrency utilities in Java. Concurrency is a huge topic, and it's not possible to cover this into a 10 or 15 minutes tutorials. So treat this particular session as an introductory session where I will talk about some of the most relevant classes which you need to know when you talk about concurrency. We have been talking about this whole concept of concurrency programming throughout the thread tutorials as well. And the basic idea is that you would like to do multiple things at the same time. That's the basic idea. Now, in that context, Java does provide a lot of utilities and packages, especially the java.util.concurrent package is one of the most popular package which you need to use whenever you are dealing with concurrency programming paradigms in Java. So with that, let's have a look at what does this java.util.concurrent package contains. So broadly, it contains a lot of utility classes, which can be very useful for you when you are writing the concurrent programming code. Apart from that, it will also provide some basic ideas around the locking functionality and the atomic packages as well. When we talk about locks, again, we discussed about locks when we talked about the whole thread synchronization concept as well. And it basically marries very well with the whole concept of locks and atomic packages as well. Atomic is again a different topic, which is used for thread safe types basically. But whenever you will hear about concurrency utilities, be it in your discussions or be it in your interviews, you will be seeing a discussion happening around executors. You will hear these terms like executors, executor service, future, completable future, callable, all of these. You will hear the name of all of these classes quite frequently. So these classes were first introduced in Java 8 and have been there since then to support the concurrency programming paradigm. So I will talk about these three classes broadly in today's session, and we'll have a look at a demonstration of these three classes as well. Let's first talk about executor. Technically, it's an interface. It's not a class, though I said that it's a class, but it's basically an interface. An executor is basically a very simple interface which will help you define the subsystems which you would like to create with the help of threads, maybe including thread pools, or if you want to do a disk reading and writing operation in an asynchronous way, or you want to create some sequence of task frameworks as well. So executor will provide you a very lightweight framework to do all of that, especially around thread pooling and asynchronous IO is where it shines most, because in your computer you have limited resources and you would like to dedicate a certain pool of threads for a particular task or for a particular executor object. So with that, the second class which we would like to know about is executor service. An executor service will provide a more asynchronous task execution framework. And this is probably the class which you will be using whenever you're dealing with asynchronous programming in Java. Asynchronous programming basically means that you submitted a particular task, but you did not wait for it to be completed. You did not hang your process or your thread for that particular task to be completed. It's very simple. It's very easy to relate this to a real life. For example, if you are, there are times when you do two things at the same time. For example, let's take a very, very simple example. If you're just boiling milk on your gas stove, so you put the milk on the gas stove and then you move out for a couple of minutes to do something else. For example, maybe checking your mobile for new emails or doing some other work, maybe just doing some laundry. So you submitted the milk boiling task, then you moved away from that task because you know that this particular task is going to take some time and you utilize your time somewhere else. That's what we mean by asynchronous programming, and executor service will provide you with constructs to create a similar behavior in your Java program as well. So remember about executor and executor service. We will look at the implementations later where we can talk about that. Another interesting class which I would like to talk about is future, if we have it here. Yeah, so future is another class which we will be looking at, and future is basically to fetch the result of the submitted task. Again, taking the same naive example of the milk boiling example. So it would be great, right, if there is some mechanism or some alarm which just sets off the moment the milk is boiling and it's about to be spilled out. It would be great to know that in advance via some alarm or something. So future provides that kind of a carrier or that kind of a holder where you submitted a particular task, you moved your threads to something else, you did something else, and then you can check with the future object, and future object will tell the status of that submitted task, whether it is completed or whether it's still in progress. Once it is complete, then you can fetch the result of that submitted task based on with the future object. So that's the concept of future. So remember, executor service and future, they will work quite hand in hand, because executor service will be used to submit the task and future will be able to fetch the result of that particular task asynchronously. So that was about a quick theory. You can read more about it in the documentation. You can see in executor service, future class, what does this basically in these class do. But to have a look at or get a greater sense of this, let's have a look at our demonstration of it to understand these classes better. So let's move to the Eclipse IDE to look at an example. Let me close all the classes and just open a relevant one. So yeah, so let's first deal with the executor interface itself. So if I just minimize this one, here I've created a main class and I've created a public static void main method, and you see two static methods here, executor invoke and executor service invoke. I'm basically showing you how you can use executor and executor service. So if you're just using executor, then how you would do that is basically you are going to create a reference of the executor, and then the executor needs basically an executor object, because it's an executor reference, so you need to supply an executor object. So either you can supply an inner class right here, or you can call you can create a executor type of class, which I've created here, which is called caller class. So I've created a class called caller which implements the executor type, and the moment you write implements executor, it will force you to override the execute method, and inside the execute method you are going to run your own thread. So this is how the current thread or the executor's own thread will be running. So once you have done the initialization, then you can call the execute method on the executor class. Remember, you got this object, so you can call the execute method on the executor object here, and inside this you can provide this particular Lambda function implementation, which is going to ask you what exactly you want to do when I run this particular thread. So when I run this thread, when Java runs this particular thread, what do you want Java to do? That's something which you will provide here. So this is how you can use, it's a very simple example. Like I said, if I build a more complex example, it will take a lot of time and a lot of other concepts to cover. So treat this as an introductory session, and you can basically try to run a very simple example of this, writing whatever complex logic you want to write while the thread is running, and put that into this execute. Similarly, if you want to use executor service for doing the asynchronous operations, then it will follow the same way, but there are some differences along the way as well. So this is the method which is showing the executor service implementation, or the way of using executor service. So again, I create a reference of executor service, and then here you see I'm saying executors dot new fixed thread pool with a size of 10. So that's the power of executor service. It is going to create a pool of threads dedicated to itself to do the tasks whichever are written inside here. So whatever you write here, these thread pool will be utilized to execute that particular task. You can assign the size of the thread pool based on how many threads you need. There are multiple static utility methods, like there is one new fixed thread pool which I've used. But if you just do Control Enter, you will see cached thread pool, single thread execution, a new work stealing pool. So like I mentioned, there are a lot of classes, interesting classes here, which you can use. For simplicity, I've just used a fixed thread pool here. Once you get the executor service object, then here you called execute, but here you will be calling the submit method. And then the drill goes exactly the same way that you write the Lambda function implementation inside here, basically the functional interface implementation, and you provide your own implementation code which you would like to run whenever you call the run method, whenever this executor service calls the run method on that particular thread. You can actually go to the submit method and you will see it accepts a runnable. It basically accepts a thread object. So whatever you write inside this particular code will be the public void run implementation of that particular thread class. If you don't remember how runnable works, please go back to my threading tutorial and watch that, where I explained the runnable interface and the run method in detail. So that's what we are doing here. So this is for executor and this is for executor service. So let's run this program. And yes, I mean, nothing, because I'm not doing anything much apart from just doing sysouts here. And that's what you see here, the executor example and the executor service example. So this was about executor and executor service. Now let's deal with another interesting class of called future, which I said that I will also talk about. So for that, I've created a separate demo because it deserves a separate demo. It's a very interesting class. So let me just make it full screen. Yeah, so I've created a class called future demo, which has a public static void main method. And again, I'm doing this executor service initialization, but this time I'm using a new single thread executor. Now, what does this do? This will basically create an executor which will use a single worker thread operating from an unbounded queue. Remember, even if this single thread terminates due to, let's say, a failure during the execution, before the graceful shutdown, a new one will automatically be spawned and will take its place if the execution is still pending. So that's the power of single worker thread from an unbounded queue. That's what I've used here. Based on your use case, you can use other ones as well, like I mentioned earlier. Then I have the executor service object with me, and similar to the previous example, I'm going to call the submit method. And inside the submit method, I need to provide the runnable class runnable interfaces implementation. And that implementation will basically be of the public void run method. And this is what I want to do in my run method, where I'm sleeping the thread for 10 seconds. Thread.sleep method takes millisecond values as the parameter. So this is 10,000, which means 10 seconds. So I'm sleeping this thread or pausing this thread for 10 seconds and then returning a string called completed. This is what I am doing in the executor service.submit implementation. The result of it is going to be a future object. Remember, the result of the submit task is going to be a future object. So I store that future reference here, and then at line 20, I'm using the same future object to ask Java to check if this task is done. And the way you do that is just by calling is done. So till the time, there's a negation condition, till the time the task is still in progress, because this means future is not done because I've put a negation, then just print this out where you say the task is still in progress, it's still not complete, and you pause this particular thread. Remember, this was a different thread. If you pause this particular thread for 500 millisecond, or basically half a second, and you again check this condition. If it's still not done, you print this, again pause for half a second, again check this, till the time future.isDone becomes true. When future.isDone becomes true, that means that this particular task is completed. Now you see, I mean, generally when we execute the programs, the execution happens sequentially, that after line 17, the control will automatically flow to line 20. And before the control can reach line 20, everything above line 17 has to be completed. That's basically synchronous programming for you. But when you talk about asynchronous programming, using the power of executor service and future objects, you can do something here which will go into a separate thread. And then you can continue your execution here. So this can be in a different method altogether, where you submit something, and this is basically checking the status of this task. Understand this very well. This is very important concept, that it's not though it's a sequential execution, after line 17, line 20 is getting executed, but line 20 is not waiting for everything above line 17 to be finished. It will continue. That's the power of asynchronous programming. So here we are checking this, and once the future.isDone says true, then we say task completed. And then you probably would like to fetch the result of this particular task, right? And for that, future provides a method called future.get. This is going to pick the future object state, and whatever you are returning from here will be returned here, and then I'm printing the result. So if everything went fine, this result should say completed because that's what I'm returning from this future object. And always remember to shut down your executor service to release the thread pool which you created here. I've also put a catch block here because I'm using the thread.sleep method, which will ask you to handle an interrupted exception. And then there is an executor service exception, which is execution, and a timeout exception as well. There are other interesting methods as well on the future class, future object, sorry, which is like future.cancel, where you can cancel explicitly a future task, which is currently in progress. You can check the status of it by calling isDone, which I've used here. You can also call isCancel to check if the user or some other process explicitly canceled the execution of the submission of the executor service task. So hope this is you are able to understand the flow of it, that these block and these block will program will execute them, but they will run in different threads. So let's see what happens. Now I'm going to run this particular program. And if I bring this here, you see the task still in progress keeps getting called. So we submitted the task here, and now this block is getting executed. This block kept getting executed. So this task did not finish, right? The thread.sleep was this whole thread was sleeping for 10 seconds, but line 20 did not wait for 10 seconds. It continued execution and it kept checking the future object 10 times at least, or till the whole 10-second sleep was taken away. And once this thread woke up, it returned completed. Feature.isDone became true, and it came out and it said task completed. So that's what we get here. And at the end, in the result, you get completed, which is what you returned from here. So this is the power of asynchronous programming. Please, like I mentioned, please do read more about these classes and how they work and what is the paradigm of asynchronous programming. It does make debugging a bit hard at times, but it's a very interesting concept to be used in concurrent applications. And that's all I would like to cover for this particular session. And in the next session, we are going to talk about regex and NIO utilities. When we talk about regex, let's understand why do we need them and how Java actually provides support for that. So the basic idea behind regular expressions is to find a pattern in a text corpus. If you have a lot of strings available, if you have any kind of text, any kind of string, and if you would like to find a particular pattern saying, okay, does this whole text paragraph contains any character or contains any number or contains any special characters or contains characters after numbers or numbers after characters. So if you would like to find those kind of patterns in your text corpus, then that concept is called regular expression finding. And Java provides the support for that particular regular expression finding through a package called java.util.regex package. So this is the package which you would need to use when you want to do any kind of regular expression finding in the text. Now, you may be thinking that why do I need to use this? I already have the string handling methods, right? You can do substring, you can find a particular character in the string, etc. But that is limited because it only provides string methods, ways to manipulate and find and replace strings. But regex is generic. You can literally find any kind of character in your string. It can be a special character. It can be a square bracket. It can be a multiply sign. It can be a divide sign. It can be, like I said, integer, capital letters, small case letters. So any kind of pattern you would like to find, java.util.regex can be used to find that kind of pattern. Now, this package is very interesting and it provides lots of classes. And again, this is a very, very big topic and very complex topic. So we will just scratch the surface of it. And like I always say, whenever you would like to read more about it, go back and read the documentation. Currently, the documentation I've opened is for Java version 8, but when you are reading it, you can go for the latest Java edition documentation. So with that, let's talk about some of the interesting classes which we will be dealing with and we must know when we talk about regex in Java. So I already explained what are regular expressions. Let's go to the interesting classes. The first class which we need to know about is the pattern class. So pattern class, or an object of the pattern class, will basically be representing a compiled regular expression. So you write your regular expression in a certain way. Regular expression has its own language, I would say, to write the pattern. For example, if you would like to write a pattern saying that check if this particular text paragraph has the characters first, then the integers, then the characters, then this particular special character. So that is your pattern. You write that pattern, then you need to compile that pattern. To compile that pattern, you can use the pattern class. This class generally does not provide any kind of public constructors to you, so you cannot initialize the pattern object explicitly. But to create a pattern, you need to basically call the static method named as compile. So compile is the method which you need to use to compile your regular expression, which will then return the pattern object. Once you have compiled written your pattern and you compiled your pattern, the next class which you need to know about is the matcher class. Matcher class will provide that particular engine framework which will understand and interpret the pattern, and then will try to find that pattern on the text paragraph which you're supplying, and it will result in true or false. If it finds that pattern, it will say true. If it's not finding the pattern, it will say false. So that's the basic idea. So you need to know about the pattern class, and you need to know about the matcher class. So the matcher class also does not provide any kind of public constructors, and you obtain a matcher object by calling the matcher method on the pattern object. So once you created a pattern object, just call the matcher on that particular object, and that will get you a matcher object, and then you can use that object to find the patterns in that particular text corpus. There is also a dedicated exception which is called pattern syntax exception, which will be thrown whenever you have written the regular expression syntax incorrectly. Like I said, it has its own language, so you need to write the expression in a way regular expressions are supposed to be written and supposed to be understood. I will touch upon that in a while, but that's the basic idea about the three classes. Now, when you would like to find a pattern, it can be a string pattern, it can be some characters, it can be some predefined characters, some quantifiers. You can also create subgroups within the regular expression. So like I said, there's a tons of functionality which is available in this particular concept, and we will just cover some of the relevant ones, or just run through some of these concepts, and then I will switch to a demonstration. For example, if we talk about the string literals, then you can do the string matching. For example, if you want to find this particular word or this pattern, this is just a text pattern, right? So if you would like to find this particular text pattern in the text string, then you can write this particular text pattern as a string pattern inside the pattern object. So that's about the string literals. Now let's move to some interesting ones like meta characters. And the meta characters are very interesting because they have a special meaning. For example, if you write your regular expression like this, where you say cat and then you say dot, then when you are applying this particular regular expression to find the match into a string, it is only going to find the match for cat. It is not going to find the match for cat dot, because dot is a meta character in regular expression. It has a special meaning. It does not mean dot, but it has a special meaning. And that special meaning basically means that even though the dot is not present, it will basically mean that after cat, it can be any character. So the meta character dot means any character, which is why you see this match succeeds, because it will search for this pattern, which it matches. And after that, it can be any character, it doesn't care. So even if it's S or D or whatever, it will say true because CAT was found a match. So dot means any character after the pattern you have specified. Similarly, there are a lot of other characters, special characters or meta characters, like the ones which have been listed here: question mark, star, plus, dot, and all of these have their own dedicated special meaning. They are not your normal arithmetic operators or other operators. They have their special meaning when you are dealing with meta characters. So do read about them in detail, and I will be using a bit of meta characters in the example as well. Then the character classes are also very interesting. Similar to the example which I told you before, if you want to find a particular string or a particular integer into a text corpus, then you can use the character class patterns. For example, you just put a square brackets and you write ABC. This means that it will try to find exactly ABC in the string. If you put a cap in front of ABC, then it will try to match any character or find any character except A, B, or C. So it's a negation. Similarly, if you specify small a to z and capital A to z, it means any character can be there between small case a to z and capital case a to z inclusive. Similarly, you can provide specific ranges like A through D, or M through P. So only the characters which will match the union of this condition will be returning true, and rest of the if this particular pattern is violated, then you will get false. So similarly, you can build a lot of complex combinations and permutations with these special meta characters and character classes. Do read about these in detail if you are curious to know about it, and there is tons of materials available on this on internet which you can read about to learn more about. Similarly, there are predefined character classes as well. Dot is something which I already explained, which means any character. Then you can use /d to find a digit in a particular string or in a particular text corpus. /D is for non-digit, or you can use the classic negation condition as well. /s is for a white space character. /S is for a non-white space character. Word, non-word. So there are a lot of different examples. So I think by now you would have built a decent understanding of what I'm trying to tell you is that you can specify these patterns, compile them, and then use the matcher. So let's move to a very simple demonstration. It's not a complex example, but very simple example just to get the point across. So I'm creating a regex string here, and this is the pattern I've specified. I'm saying any character, star means any number of characters, so it can be anything here. Then the string, the pattern expects an alphabetical string or alphabetical section. After that, the alphabetical section should be followed by a numerical section. And after the numerical section, again, it can be any character. So this is my pattern. I create a simple string with this regex pattern. And like I mentioned in the documentation, you call pattern.compile to compile the regular expression. So I compile the regular expression, I get the pattern object. And after, again, as per the documentation, it said that you can call the matcher method on the pattern object to get a matcher object. So I say pattern.matcher, and I provide my string on which I want to test it. So I've just put a random string where there are some integers, then there is some alphabets, and then again there are some integers. Once you have got the matcher object, just call matcher.find. This will return a boolean where you can test whether the matcher found a hit in the text corpus or not. If it found a match, the match found will be true, and if it didn't find the match, you will get a false value in this result. So with that understanding, let's run this program. So I get the output match found. Why did I get that? Because I said that start with anything. So it started with anything. I don't care what it is. It's an integer or any special character. I don't care. After that, there should be some alphabets. So there are some alphabets, and right after alphabets, there should be some numbers. So again, there are some numbers. And after that, there can be any character, 0 or more characters. So there is nothing here. That's why you see a match found. Let's do an interesting test here. Let me do this. I put A to Z again here. So now I'm saying start with anything, have alphabets, have numbers, and again after numbers, you should have some alphabet, which is not the case here because you start with something, you have alphabets, you have numbers, and after numbers, the string ends. There is nothing after that. So let's see what happens now. You get a match not found because this particular pattern, when got compiled and got applied on this particular string, did not find the string following the regex pattern which you have specified. So this is a very simple example to show you how you can build patterns. You can use groups concepts as well to group the patterns. It can get very, very complex and very, very nasty. So use them very wisely, very carefully. And do read about the documentation and other examples which I talked about to get more understanding and more comfortable with regex. And that's all I want to cover in this particular session. In the next session, we will quickly talk about the NIO library in Java. Let's first understand why do we need this package and where will we be using this package. Let's talk about the where first. You can use the NIO package to read from a file or write to a file. Now let's talk about the why, because the obvious question will be that we already have the IO package in Java, right? Where you can use the classes from that particular package to read from a file or write to a file. Then why do we need another package doing exactly the same thing as NIO? So the basic reason for launching the java.nio package was providing the multi-threading capabilities to the IO library. And we could not do this in the existing IO library because we had to probably rewrite and change the functionality of it. That's why Java created a new package called java.nio package. And this package is basically, if you understand what NIO means here, generally, as per the popular perception, it means non-blocking IO, that you don't want to block your threads while you're reading to a file or writing to a file. Classically, NIO meant networking IO, but as per the popular perception, people know it as non-blocking IO. So the basic idea is because whenever you are reading a file or writing to a file, the thread gets blocked until the whole file is written or until the whole file is read. So the NIO package provides an improvement over that. It provides an improvement in a way that you can read the file into a different thread, but at the same time move on to another thread and write to a file. So you get this multi-threading capabilities and non-blocking capabilities out of the box from the classes provided by java.nio package. So that's the brief about this package. Now, some of the popular classes which you will be dealing with and some of the concepts which you need to know about NIO package are buffers and channels. This is probably the core concept of the whole NIO package of how channels and buffers work. So let's say you are trying to read something, then the read operation will be happening from the channel into the buffer. And similarly, the write operation will be happening in the reverse way, which means to the channel from the buffer. So that's how the buffer and channel work together, that whenever you are trying to write something, you have to first open a channel, create a buffer, and then you can read from the channel into the buffer. And similarly, when you're writing to the buffer, you again have to go via the channel route. So channel is that route basically. Buffer is basically just a plain container for the data. And channel is basically representing the connection to the entities which are capable of performing the IO operation. So think of channels as a pipe, a channel literally, basically. If you understand the English meaning of channel, that's exactly what we mean by here, that it provides just a means to an end. It provides sort of a wire to the buffer. And then you also have selectors and selection keys classes, which together with selection channels work to provide the non-blocking IO functionality. There are some other APIs, interesting APIs as well, like charset and some more, but I will not go into the detail of that because if we know about buffers and channels and selectors, then we will be able to figure out what exactly we would like to do with this. I would also like to talk a bit more about the buffer class. So if you go to the buffer classes operations, the popular operations, you will see there will be the read operation, which is for reading the files basically, or reading the content of the file. This works on the byte stream concept, first of all. So to read the bytes from the file, you will call the read method. There's also a very interesting method called flip, which I will be using, which makes a buffer ready for the new sequence of operations. So once you have done something and you want to, let's say you read a particular file and you have come to the end of the file. Now you would like to reset the buffer and go back to the beginning of the file. Then you can use the flip method for that particular piece to bring the current position back to the position to the zero index or to the starting of the file. So that's about read and flip, and we will have a look at some of the other methods. And there are a lot of interesting classes in this NIO package. Do read about the documentation and check out the other methods as well to learn more about this package. But the basics are, like I said, channels, buffers, some methods of the buffers, and there's also a path class which is used to basically provide a particular path to a directory, which I will not be covering in this example, but something good to know. So with that understanding, let's move to an example and understand how we can work around with this NIO package. So for that, I have prepared an example where I will be reading from a file and then writing to a file. So I have a main method here. The first section here basically is about reading from a file, and the second section is about writing to a file. So let's go through both of these sections one by one to understand what is happening. So in the read section, I use the file input stream class from the IO package. I'm still not using the paths class here, just to show you that both of them still can work together if you want to use the old constructs. So I use the same file input construct to read a file called source.txt, which is present at this particular location in my directory. And this source.txt has just a one line of text, nothing more. So I basically create the file input stream object, and then I create a channel because we are dealing with files. So you create a file channel. If you're dealing with network socket, then you might have a socket channel. So that's also something which you need to know about, that this NIO package is generic. It can be used for any kind of communication of reading and writing, not specifically to file handling. So we create a file channel object here by calling file input stream dot get channel. It's that simple. Once you call that, you will get a reference or the object basically of the file channel. Then the next thing is to create the buffer. Like I mentioned, that channels and the buffer are the two main tools through which you work with an NIO library. So we create a byte buffer, and we allocate some starting size to it, just some threshold size. So you can put it any number which you think is practical for your file and for your use case. Here I've put just 1024 bytes or 1 megabyte because my file is pretty small. So I just put that and initialize the read buffer, and then I call read channel dot read operation. So the file channel object you created, you just call the read method on this particular channel and supply the buffer. And then it is going to read the file via the channel into the buffer, and this read method is going to return a result to denote if the file was written successfully or not. I'm just printing a sys out here, just a bare bones sys out, nothing new here. So this section will be used to read a file. So let's see if I can read the file successfully, and then we'll move to the write section. So I go to run as Java application. Yeah, it says file read successfully, and it read 27 bytes. It means that there were a total of 27 bytes in my file, which had a single line of text. So it read all of that, and it completed the execution. Now let's move to the write section, and I can comment the read section because we have covered that. So here I'm again creating a file output stream object because I need to write something. So again, using the same construct of the IO package I have covered previously in the previous sessions. Once we have the file output stream object created, the next thing is to create a channel. So I again create a file channel, but this time it's the write channel. I again create a buffer, which is the write buffer, allocate some size to it. Then this is the string which I want to write to this particular file. So my destination file will be called dest.txt, will be present in this particular location, and this file should have this string written if this whole operation goes successfully. That's my end goal. So to do that, I say write buffer.put, and whatever string you have created, just call get bytes on it, and you get a bytes representation of the whole string. So that's what I've done here, because this put method expects byte, because if you go inside this, it expects a byte array. So that's what I'm supplying here. I'm providing the bytes array on the string by calling message.getByte, or any string object.getBytes will get your byte array. Once you've done that, then I'm calling the flip method. Remember I talked about this flip method to basically reset the index. That's something which you need to do in this particular case, so that the index goes back to the initial position and the buffer can be written successfully to a file, to a channel basically. So once the buffer has completed its operation, then I can write the buffer to the channel. And once that is done, then if these operations went successfully, then I will see a file called dest.txt in this particular directory. Currently, there is no dest.txt in this directory. You can see there are just 3 files, but there is no dest.txt. So let's run this program. So it says file written successfully, which was the last sysout at line 28. But let's also see what is happening in the directory. So now I see a dest.txt popping up here. It's a 1 KB file. And if I double click on this, I see the same string, which says this is a test string, which is the same string which I supplied here. So you can see you can use the NIO packages to do the file read and write, and much more than just read and write using the NIO package. But this is just to get the point across that this can be done using the NIO or the non-blocking IO package as well, so that you get maximum performance on your machine while you deal with file IO operations. So that's all I want to cover for this particular session. And in the next session, we are going to talk about an interesting concept called Java beans. We have been creating Java classes and creating objects of those Java classes to work and manipulate, transfer data, call methods, create properties, etc. And Java beans just use that as the groundwork to create a specification. First of all, let's understand that Java beans is just a standard. It is just a specification which has been provided by Java to be followed while you are implementing production grade or enterprise grade applications. So it's just a pure specification, set of standards. If you want to read more about this, please go to this particular link, which is written here. I mean, if you just Google Java Beans spec Oracle, then you will be able to find this particular link. You will see a download option here. If you go here, you will get these 2 specification documents option. So you can just accept the license agreement and click on this particular Beans 101 PDF, and you can read about the whole Java Beans specification. I've already downloaded this particular PDF, which is opened in this tab. And if you go to the TOC here, it's an official Sun Microsystem white paper basically. And if you read about this is going to explain the whole Java Beans API specifications. It's going to specify the core components of the Java Beans component architecture. So it's a specification. Let's understand that very well. If you go to the table of contents, let's go to the interesting one, which says what is exactly a bean or a Java bean. So a Java bean is basically a reusable software component that can be manipulated in any visual IDE like Eclipse or IntelliJ or NetBeans, etc. So technically, a Java bean is just a Java class. But that Java class should follow three main properties. The first property is that Java class should have getters and setters to access the properties. Second property is that Java class should have a public no argument constructor so that anybody can create an object of it. And third is that the Java class should implement serializable. The reason Java Beans specified these three conditions, which I said, let's talk about the third one where we are saying that it should be implementing serializable interface. Why is that? It's because a Java Bean would be required to be exported between applications, may be required to be written to a database or to a file system, or to be converted into an XML or a JSON document, sent over the network, again being deserialized. So this will be moving across a lot because that's what we mean by reusable. Multiple different software components and applications might be reusing that bean again and again, and that bean needs to travel across. And to enable that bean has to be serializable, because if you can't serialize it, you just cannot transport that object to another application. It's just not possible. This is how Java has been. So that's why you need to implement serializable. You need to have a public no argument constructor, and you need to have getters and setters to access your properties. You can actually read more about this if you scroll down. It will also talk about the difference between beans and class libraries. Remember, not class, but class libraries. And here it explains what I just said, that a Java bean can have properties, it can have events, and it can have methods. So properties are nothing but the normal attributes which you create inside a Java class. Nothing fancy. The same attributes are named as properties. For example, you may have a foreground property, and then you can have a method which is just a normal Java method which can be called from other applications or from an environment. And by default, all of the beans public methods will be exported. By exported, I meant when you export this, when you serialize and export this object, all the beans public methods will be exported by default. But then a bean can choose to export only a subset of its methods if it wants to. A bean can also have events, and events basically provide a way for one object to notify other objects that something has happened. So something similar to the producer consumer example or the producer consumer pattern, where you can notify other objects. Threads also have this particular pattern where a thread can notify other threads that it has completed its task, and other threads can start. So that's the property behind event, where something has occurred, and then the object can tell other objects that something has occurred so that they can react to that particular event. So these are the three main traits, which are properties, events, and methods. You can read more about this particular white paper. I will not go into the details because it's a long white paper, but it's a very well written white paper which will give you a very good understanding of how Java Bean specification was written, what was the thought process behind it. So coming back to the code, if you want to just write it, it can be very simple to write. Just write any class and say implements serializable. So it will ask you to provide a serial version UUID. So you can write this here. Then you can create your attributes as normal private attributes. You can create public methods to access and manipulate these attributes in the forms of getters and setters. So these are the public methods to access and manipulate these attributes. Here we have a parameterized constructor which will not be required, or which should not be there when you're creating a Java bean. It should just be like this, because when we talk about the public no args constructor, as we discussed in the very first lectures, that you do not need to provide the default constructor. Java will automatically provide a default constructor for every class. So you don't need to write something like this. It's just not needed, because you can write it, but it has no value attached. It has no meaning, because this is something exact. This kind of code is already generated by Java compiler when it compiles this particular class. So a public default no argument constructor implementing serializable private properties and public methods. And you can have additional event methods as well, which I talked about just when we were going through the white paper. And that's all pretty much what a Java bean is. So you can see it's just a Java class, but some additional specifications which a Java class has to follow to be called as a Java bean. And that's all I want to cover in this particular session. It was just a very quick conceptual walkthrough of what we mean by Java bean. And in the next session, I'm going to introduce the Spring framework to you. Spring framework is the most popular web application framework available out there today. And all of the big companies from Netflix to whatnot use Spring framework to build the modern day Java applications. So before we go any further, let's understand why do we need a framework. So let's understand this with the help of a diagram. So let me just open a blank paint page and let me show you what I mean by a framework and why do we need this. So we built simple applications so far, but if you have to build a enterprise grade web application, you will have a front end probably where you will have what you see in the browser. So you will have the HTML, the JavaScript, or any other Java Enterprise Edition classes like JSP, Servlet, etc. Then you will have a backend where your Java classes are present, which contains the business logic. So the business logic. And then you have a database where you have you store the basically the whole data. So you have these three different layers. We also call this a three-tier architecture. So you cannot build all of this by just using the core Java classes, which we talked about. You need to do more integrations. You need to use more different programming languages and concepts to build a complete enterprise grade application. And if you try to build all of this by yourself, then it's going to take a lot of time and a lot of effort. That's why we have frameworks which basically provide the structure to create these three layers. So that's why we have these frameworks. And in the frameworks, Spring is the most popular framework. It provides the structure to write all these three layers. One of the reasons I did not talk about the Java Enterprise Edition technologies like servlets and GSPs because nobody works on them today. Even if you learn about servlet, it's good to know the conceptual overview of servlets, but nobody today builds applications on GSPs and servlets. That's the reason I did not talk about it, because today we have sophisticated front-end frameworks like AngularJS or React.js or Ember.js and whatnot, and it is iterating at a very faster speed. So there is literally practically no need for a Java developer today to learn about GSP, because I can bet you on that. You can take it in written from me. Nobody is going to build the GSP based applications in 2021. Everybody is going to use some sort of front-end framework to build that. And then you have a backend. In the backend, you have the exact core Java classes like I just explained. So you will be using the Java beans, and you will be basically using the pure Java concepts of collections and etc. to write the backend logic using the Java classes. And then you will need a JDBC connection to write to a database as well. So you would need a database as well. And Spring provides connectors and specifications to support all of these three layers. That's the reason. So generally, when you talk about a web application, let's talk about web application because Java primarily is used in web applications. So in a web application, you basically see a browser window where you load a particular page. But what happens behind the scene? This browser has some HTML and some JS maybe, and this code is basically calling some endpoint. This endpoint is present in the backend layer. So this endpoint is present in the backend layer. That endpoint transfers the control to the business layer where you have your core business logic written. And then the business layer transfers the control to the data layer, or some people also call it DAO layer. This DAO layer then talks to the database. That's how a web application works. And that's the architecture you will mostly be following whenever you are building any enterprise grade application in any organization. So Spring provides support for all of these parts. This obviously is written by Angular and React and other frameworks, but this whole section is basically presented or supported by Spring. So with that, let's understand a bit more about Spring Framework. So if you go to the Spring official website, it talks about some of the value propositions. Spring is used heavily. Like I said, it's used everywhere. It's very flexible framework. There are a couple of concepts which Spring provides, which is around inversion of control and dependency injection. And I will talk about these concepts in a while when we'll talk more about the Spring's components. it makes it's quite productive and quite fast as well. So it's very fast to build application on Spring. It has a whole dedicated security module as well. So it's quite secure by design. And the Spring community is huge. So you can find a lot of support on internet. Let's learn a bit more about the Spring's core components or core technologies. So if we talk about the Spring's core components, these are the Spring's core components. So you have a testing module, you have a core module. First of all, inside the in the core components, you have a core module which has IOC containers, resources, events. I'll talk a bit about that. It has its own testing component, so it provides very good support for testing applications. It has a data access component. The data access component is used to provide connections, utilities to the database, because like I mentioned, your application will be talking to the database, and Spring provides a complete dedicated component to be used whenever you are talking to the database. It also provides a web servlet component to provide support for Spring MVC, which I will be covering in the next session, WebSockets and Stomp and messaging frameworks, etc. It also supports reactive or asynchronous programming if you want to do that. It provides a lot of integration capabilities in the integration modules if you want to do JMS or JMX or email or task scheduling, etc. And it also provides language support to support internationalization of the applications. So it has a lot of different components, but we will focus on this core component, which is of the interest here. So let's talk about that. The first thing which you need to know about Spring is its support for inversion of control, and it provides that support by creating an inversion of control container. What do we mean by inversion of control? The basic idea is, let me take any random example and I will be able to communicate the idea behind this. So let's go to any simple example which I have already covered. Let's go to method calling, for example. So we had a student class. We created a student class, simple student class, 3 properties, constructor and public getters and setters. And then I created a main class and I initialized the student object. So the responsibility of creating the student object lies with the student class itself. Student class have to be explicitly initialized to be having an object of the student. So this creates a problem because when you're dealing with enterprise grade frameworks, you might need to create a lot of objects on the fly whenever the endpoint is talking to the business layer. If I take the reference of this architecture, if the endpoint is talking to the business layer classes are talking to the data access layer classes. So when the business layer classes needs to talk to the data access layer classes, the data access layer classes needs to have an object because the communication happens between objects only. So who creates those objects? If every time the data access object has been called, and if we pass that responsibility to the DAO class to create the object, or every time the endpoint talks to the business class, we ask the business layer to create the objects, it becomes a lot of painful process because every time you will be doing this new student everywhere, you need a student object, which is very painful process. So what Spring says, it says, okay, invert the control of creating the object. So let's not give the responsibility of creating the object to the class. Let's give that responsibility to the framework. So the framework will be responsible for creating the objects of a class, and it's not the class who will be responsible for creating its own objects. So generally, outside the framework, a class is responsible for creating its object, but with Spring inverts this responsibility. That's why we call it inversion of control. The control is inverted, it's reversed, and now it's the framework's responsibility to create the objects. You will also hear about a concept called dependency injection a lot in context of IOC, and dependency injection is an implementation of the IOC concept. So using Spring's dependency injection mechanism, you can inject the object of any class into any class. Once you do that, Spring dependency is going to use the inversion of control concept and create the object. That's about IOC and DI, or dependency injection. Then the other modules like resources will provide a way to refer different files in properties if you want to. Then you have a validation module as well, which will provide different validation constructs, because once you receive the data, you might need to run a lot of validation, right? And writing the validation by yourself can be very painful. So it provides a validation framework as well by providing the validator interface. You can use this particular framework to write the validation rules. checking the name not empty, etc. Similarly, it also supports an expression language if you want to use that. So the expression language support is wide, very wide in fact. You can create an expression parser and you can do the expression language evaluation using the a Spring expression language. Similarly, it also provides support for aspect-oriented programming. Now, again, all these concepts of validation and Spring expression language and resource support, you probably would need hours of reading to learn about these concepts, and I'm just running through them just to tell you about these concepts. And do read about why do you need resources, why do you want to do validation, why do you need an expression language, what is aspect oriented programming. Read about all of those concepts because they are not related to Java. They are generic concepts which will be applicable to any programming language. So any enterprise application you build in any programming language, you would need to do the validation, you would need to do the resource reference management, you would need to have an expression language, you would need to have aspect oriented programming support. So this is just to tell you that Java does provide an AOP or aspect oriented programming support as well. And it has a lot of APIs available for that. Along with that, it also provides very good logging capabilities because you definitely need to log all the actions which the framework or your objects are taking. So this was a very quick lightning overview about Spring. I understand it's not possible to cover all the concept of a framework as sophisticated and as smart as Spring in a 10 to 15 minutes lecture. So treat this as an introduction session. And like I said, read more about all of these components. I just explained the core because this is sort of the main building block of Spring framework. And then you have other supporting components as well. So do check out the documentation. There are tons of examples available. In fact, in the Spring's official website itself, if you go to the Spring Guide section, if you go to the Learn and you go to the Guide section, there are awesome getting started and topical guides and tutorials available. So for example, how to build a RESTful web service, how to schedule tasks, how to consume a RESTful web service, how to build a simple Java project with Maven, how to upload files with Spring, how to do messaging with Redis, which is basically a caching framework, how to do messaging using Spring to RabbitMQ. RabbitMQ is a messaging framework. So there are tons of examples available here. Very good documentation and very robust documentation. Do check out the examples to learn more about this. And in the next session, we are going to look at an example of Spring MVC application. Before we go any further, let's first understand what do we mean by an MVC application. So in the previous lectures, I discussed about the three-tier application where you had a presentation layer, you had a business layer, and then you had a database layer, which is talking to the database. And that's how we built a three-tier application, which can also evolve into an N-tier application. But when the web development started, the most popular concept which came out was MVC. M stands for model, V stands for view, and C stands for controller. So the idea was that these three components together can render a web application. And how they render the web application is basically that the controller is going to receive the request which is coming from the web browser. Then the controller will have the knowledge of where the business logic for that particular request will be residing. So the controller is going to invoke the model, the corresponding model which is required to execute the business logic of the request. And the controller will also have the knowledge of what response page to be sent back to the user. So we are talking about the response page here, not response. Remember that because it's a web application. So the model view controller architecture basically was designed to keep in mind that you have a web application where a request is coming from and you need to process some business logic, and then you need to return back with a page response which is going to be displayed on the web browser of the client machine. So that's why we had these three components as model, view, and controller. Controller taking up the request, then finding the right model for it which can execute the business logic, and then also finding the right view for it which can render the business logic processed by the model. So that's a quick overview about model view controller or MVC architecture. Do read about it in detail to understand how this works. But like I mentioned that MVC, the most popular MVC implementation is provided by Spring. Spring is the most popular MVC framework, and the way Spring implements it is something which I have drawn already here. So let's understand how this works. So first, the request comes from the web browser, and Spring has a
a very first welcome servlet, which is called dispatcher servlet. Any request which is coming to the Spring enabled web application will first hit dispatcher servlet. And once the request comes to the dispatcher servlet has all the knowledge of all the controllers, of all the view resolvers, which I will talk about in a while, and of all the views as well. It also has knowledge about handler mappings, which again I will just discuss now. So the basic premise is that dispatcher servlet is the component which has knowledge about literally everything happening in your application, and that's why dispatcher servlet is the first servlet or the first component which receives your web request. So once the request comes here, first of all it looks at the path and finds out the right handler for it, the right controller for it. And the way it does that by using the handler mapping component or handler mapping logic, which is provided out of the box by Spring Framework. So the handler mapping logic will tell the dispatcher servlet which particular controller is going to process the request which is coming, because every request will have a different controller return. So whatever the type of request is, whatever the path of the request is, based on that, the dispatcher servlet is going to find a particular controller. Once the controller is found, like I mentioned earlier, the controller will have knowledge about the right model to invoke for that particular request. Model is nothing but basically a Java class holding the business logic for this particular request. So it will invoke that Java class and get all the business logic processed, and then it is going to return a model and view object. View is here simply pointing to the UI response which you are going to send back to the user. It can be a JSP page, it can be an HTML page, it can be any other view technology. So anything which is used to render a web application on a web page is view, and controller is going to send both the model and view information back to the dispatcher servlet. The dispatcher servlet will take the view part of it and go to another component which is again provided by Spring, which is called view resolver. The view resolver will have the knowledge to see which particular actual JSP or template to invoke for the view value coming from the controller. So based on the value which is returned by the controller, a view resolver is going to return the right page mapping. And once the dispatcher servlet knows the page mapping, it is just going to invoke that page by calling the view component. So dispatcher servlet, handler mapping, controller, view resolver, and view, these 5 components together help render a web MVC application in the Spring framework. So that was about the theory of how Spring works. Now let's move on to an example to understand how this works in action. So here I have already built a Spring MVC application, and if you're wondering how to build that, there's an easy way to do that using Spring Initializer. And that's also the recommended way. Actually, if you go to the documentation of Spring, you will see that it recommends creating a new project from scratch using the Spring Initializer utility, which is provided by Spring out of the box. So just go to a web browser and type start.spring.io. You will get this page where you can specify what type of project you want to create. So it is going to create the basic skeleton for any Spring application automatically for you. It's probably, like I said, it's probably the fastest way to get started with Spring. So we will choose a Maven project. Maven is again a dependency management tool which is used to download any kind of jars for your application. So we are going to use a Maven project and we want to create a skeleton for a Java application. We are going to use the latest released version of Spring or Spring Boot, which is 2.4.2. It says Spring Boot here, but don't get confused with it. We are going to use just the MVC classes and not the Spring Boot specific logic yet. Then you provide your group artifact ID and the name for your jar. You provide a description. You can provide a welcome package name, whatever suits you. And then how you would like to run your application. Whether you would like to package your application as a jar file, which is a Java archive, or you would like to run it as a web archive, which is a var file. So you can choose either packaging mode, and it is going to add appropriate dependencies inside the project to support the packaging of jar or the packaging of var. Then you can also choose a Java version. So you can see there are 3 Java versions listed here, which are 8, 11, and 15. So whichever Java version you are working on, you can choose that particular version. And once you have set everything, just hit generate. Once you do that, it is going to create a project here, and then you can import this project just as a normal project inside the Eclipse IDE. And that's exactly what I've done for this initial project, which is showing a very basic hello world sort of example for how Spring MVC will work. So this whole structure will automatically be created for you. And like I said, it was a Maven project. And in every Maven project, you will have a pom.xml. If I double click on this, it is going to open this XML and it will list down all the dependencies which my project needs to have. Let's understand the dependencies as well. So this project is currently using the properties of 1.8, but that's fine. You can obviously definitely change this value. I just kept it as 1.8 for now because I'm not using any new functionality yet. In the dependencies section, you will see all the dependencies or all the jars which are required by the Spring application to run successfully. The first dependency we see here is about DyMyLeaf, and DyMyLeaf basically is a view technology similar to JSP or similar to Servlets technically, where you can use this DyMyLeaf templates, which are basically just HTMLs with some dynamic values, and you can use these DyMyLeaf templates to render web pages for your Spring MVC application. If you want to use some other view technology, you need to include the dependency of that view technology here instead of DyMyLeaf. So that's about that. Then you need to include the Spring Boot Starter Web. The Spring Boot Starter Web is going to enable your application to become a web application. Then this is basically a good to have dependency which you can have in your project, which will help you deploy the project at runtime automatically without restarting the server, because the web application will be running on a server, on a web server basically, or an application server technically, because it needs to run somewhere so that so that clients can access it. That's how a web client architecture works, or the server client architecture works. So this dependency will allow you to deploy changes dynamically at runtime without restarting the server. Then this dependency is for tests, if you're writing any unit tests. And then you have a plugin which will allow to run this particular project with a single command, which we will see in a while. So that's about the dependency tour. Now let's look at what is in the SRC main Java. In the SRC main Java, I just have two classes. One is the main class, which will have a public static void main method, and this is the entry point of the Spring application. And then I have a controller class. I already talked about what controller is, but I will come back to that in a while. Let's understand the rest of the files as well. The next one is SRC main resources, where you will have your view technology data available. Like I mentioned, it is using DyMyLeaf templates currently, and basically, like I said, they are technically HTMLs with some dynamic data. So I've created a templates folder under SRC main resources, which will automatically be generated by Spring Initializer. And then under templates, I've placed an HTML file. It's a pure HTML file, with the only difference is this value. So this is what the dynamic value means, which is supported by DyMyLeaf templates. Otherwise, this is pure HTML. It's just a paragraph with a header, and this is the dynamic value which I'm populating. It also has application.properties, which has nothing, but you can use this particular file to supply environment specific properties for the development environment or the testing environment or the real production environment. If you have any unit tests, those will go here under SRC test Java, and this is the system library already provided, supported by Eclipse itself. And I already talked about the pom.xml. You also see a couple of more files created by Spring Boot. If you want to use that, you can use that to run the program from the command line as a utility. Otherwise, you can just use mvn spring boot command, which I will show you in a while. There's also a Gradle folder which you can ignore. Probably we don't need this because we are just using Maven and we are not using Gradle. Gradle is another dependency management tool very similar to Maven. So you can ignore this folder right now. So that's the structure. And now let's come back to the controllers. Remember, I told you that controllers are the ones which receive the request. So from the dispatcher servlet, which I talked about here, after the dispatcher servlet, the request comes to the controller. So once you hit a particular URL, then you need to create a controller for that URL mapping. Remember that you need to create a controller for almost every URL mapping you are having in your application. There should be some mapping to some controller somewhere. So I've created a greeting controller, and the way you specify or you make a simple class as a controller is by putting the @controller annotation. This is the annotation which is supported by Spring, and you can put this annotation on top of any class, and that class will be treated as controller by Spring. And the moment you put this class will also be registered with the dispatcher servlet. And like I mentioned, the controller's main purpose is to receive the requests, the web requests which are coming from the client. And the way you can receive the requests to a controller by providing the exact URL mapping. So if somebody runs this web application and says /greeting, then this particular method should get invoked. And how you define that is with the get mapping annotation. Use the get mapping annotation to provide the URL path. Whenever somebody invokes this URL path, this method would be getting called. And when this method is getting called, at that same time, this URL can also accept some query parameters. We call that as request parameters in the Spring language. So you can use the request parameters as an annotation to provide a placeholder for the variable for which the value will be supplied in the URL. So /greeting, if you call this URL something like this, then it will work because you have a variable called name which is being parsed as a query string because you have used the request param annotation. So we'll see an example of that once we run this application and how we can supply the query string. But you use the request param annotation to supply the query string parameters to the URL. You can mention if the parameter is mandatory or non-mandatory. If the required equal to true was there, then this parameter would be mandatory. You can also supply a default value if the client is not providing this query parameter at all. Would you like to set any default value? If yes, you can supply that default value here. And then you just give a placeholder name like I said. Then the second argument which your methods which are intercepting the request should have is the model argument. And remember I told you that the controller will have or should have the knowledge about the model. And from here that knowledge comes. This particular method will expect you to provide a model argument as well. So if somebody calls this application and provides the URLs with /greeting, this particular method will get invoked and then the code inside this method will be getting executed. So it's a very simple code right now, but this is where your whole logic will go. Remember that. But here I'm just saying model.add attribute name with the value which is coming from the query string parameter. That's all I'm doing here. And remember I told you that the model will hold the business logic. So here this is the business logic where whatever query string parameter which is coming from the request param, I'm capturing that and I'm adding that value with the variable name in the attributes of the model. So my model is set and after that I need to return the view so that this particular file name will be intercepted by the view resolver here. If you remember, we talked about the view resolver. So when we return greetings as a string, that string goes here and then dispatcher servlet asks the view resolver to find a particular HTML matching with this particular text. So view resolver is going to look at under src main resources /templates to see if there is a file with the name greeting available or not. Since we have that file available, the Spring is going to render this particular file supplying the model attribute value name. Now remember the greeting.html had the exact same variable name. So this variable name should exactly match with this variable name here. If you make a mistake here, this is not going to work because the model is holding the business logic and I'm printing that business logic inside the view using the die-my-leaf template syntax, which is $curly braces. So whenever you have to print any variable or a model attribute or any runtime value inside a die-my-leaf template, then you need to use the $curly braces syntax to do that. So that was about a quick overview of how this application is written right now. And that's all the code is here. Now it's time to run this application. So one of the simplest way to run this application would be to provide a Spring run configuration here for the Spring application, or you can choose another way, which is to first have a look at the Spring Web Content application, which is the entry point. So once your application boots up, this is the first line of code which is going to get executed. And to make sure that this code works, make sure that you have the @Spring Boot application annotation on top of the entry point class. So this is sort of the mandate which Spring will force you to put in front of the or on top of the entry point class to treat this class as the first entry point when you run the project. So to run the project, what we will do, that we will just go to the command line and we will say mvn spring boot run. So let's do that and let me open the terminal for that. So I have opened a git bash prompt here. You can also open the classic Windows terminal, but this is something which Git installs by default if you install Git on your system. It's pretty much exactly the same. It's just more Unix-like, but it's also just a simple terminal shell utility to access your file system. So I have gone to the project which we were working with in the Eclipse IDE, and this is the path of the project. So once you reach to the path, what you would like to run is just say mvn spring-boot:run. That's it, and you hit enter. Once you write mvn spring-boot:run, you will see a lot of code, lot of logs here where it is going to run compile all the Java classes, run any tests if there are any, and then it is going to start the web content application, you can see. And once the application is started, you will get this message that everything is run. One of the interesting thing which you can see here is that it is also spinning up an application server automatically for you, and that application server here which is being used by Spring is Apache Tomcat. Technically, Apache Tomcat is a servlet container and it's not a full-fledged application server, but just to get the point across, you can use Apache Tomcat as an application server which is being used here out of the box by Spring. If you don't want to use Apache Tomcat and you want to use something else, you can do that as well. So now everything is ready and we can now execute the application to observe the output. So for that, let me open a fresh browser window so that we don't get any cached response. And now I can just type localhost 8080. And if I hit enter, I get a white label error page because there is no home page for Tomcat defined, but there is a home page for my application defined. In fact, let's try to access the URL which we wrote in the greeting controller. The URL was /greeting. So let's copy this and let's put this here. So localhost 8080 /greeting. And if I hit enter, I get the message hello world. Let me just zoom this in a bit so that you can see. So you will see this hello world message here by putting this URL. Why do we see hello world? Let's go back to the controller. So when you call this URL, this greeting controller got invoked. Since we did not provide any query string parameter, the default value which was world was picked up, and this world value was stored in the name variable, and the name variable was added as an attribute to the model. And then we were using the greeting.html and we were printing the name variable. Since the name variable was holding the value world, so the message came as hello world with an exclamation, and that's the output which we see here. Now let's try to supply the query string parameter. The way you do that is provide a question mark, provide the key of the query string parameter and the value you want to put here. So let's put SimpliCode as a value and hit enter. So now the message got changed and now it says hello SimpliCode. So what happened here is that whatever query string parameter we supplied, that got passed here as part of the request param, and the value of SimpliCode got stored in this name key and in turn in this name variable, and then I added the same value into another name attribute and added that attribute to the model. So now this name here is storing the value SimpliCode, and then all the things work exactly as the same as I just described. It goes to greeting.html and it prints whatever is stored in the name attribute coming from the model. And that's all I want to cover for this particular session. In the next session, we are going to look at how we can build a Spring Boot application to build a REST web service. Before we go further, let's understand why we need Spring Boot. And the basic idea of Spring Boot is to build RESTful web services. If you want to know more about what are RESTful services, please, you can read about the RESTful concept as a concept. What does REST stand for? But the basic idea is that if you are accessing anything over HTTP, then that particular component can be built as a RESTful component. And Spring Boot is the most popular choice for building RESTful web services today. And even in fact microservices, which you might have heard about. So you can build microservices which also run on HTTPs using Spring Boot. So what I'm showing you right now is the official guide of Spring, which you can use to build an application with Spring Boot. It will list down all the requisites which you need in terms of the JDK installations, Maven, on and how to complete this guide, etc., etc. You can again use the same Spring initializer which I talked about in the previous session. You can use this to generate a Spring Boot project for you specifically. So all those options are available here. So I've already done that, and I'm not going to repeat what I just did in the previous session, and will directly jump to an IDE where I have created a sample Spring Boot application. And the structure here, you can see the structure would look very similar, with one change, that in the previous example when we were dealing with MVC, we had an src main resources folder, and that src main resources folder was having all the web components or the HTMLs. But since in RESTful web services you do not render the HTML, but you just send back the response. The response body can be pure XML or it can be pure JSON, but you do not send back an view, and that's the main difference between Spring MVC and Spring Boot. That in Spring MVC, you are required to return a view technology. Like in the previous session, we sent a thy_mylif template, which is basically an HTML. You can also return a JSP, but with Spring Boot, you do not deal with the view technology. And that's the world we are living in today. When you write Spring Boot, you do not have to worry about how this is going to be rendered on the web page, whether it is going to be rendered using HTML or whatnot. What you need to take care of using Spring Boot is to return the right response body, the exact text of the response, and that's it. So with that in mind, the Spring Boot was born, and the structure, apart from that, the structure would look very similar. There's a pom.xml here which will provide all the list of jars and dependencies which are required for this particular project. So you can see all the dependencies here, pretty much the similar ones. We have a starter web, we have a starter test, and we have a Spring Boot Maven plugin. And we have an application file, which is the entry point, again having a public static void main method. So you need to put the @Spring Boot application at the top of the class to make it an entry point. If you don't do this, Spring Boot will not run this class, and Spring Boot will even not run your application. So what we are doing as part of this example, that we are just printing all the beans which are provided by Spring. That's all we are doing. Like I said, it's a very lightweight and an introductory session, so we will keep the logics to minimum. And I'm just getting all the bean definitions, sorting the bean definitions, and just printing them one by one. How do you get the bean definition? You get that with this application context class, which is returned when you run the application. And how you run the application is basically using this line where you say Spring application dot run, and you supply application dot class with any command line arguments which you might want to use. Once you do this, it is going to return an application context object to you, and the application context object can be used to get all the bean definitions by calling this method which says get bean definition names. So that's the basic logic which is being run in the main class. Now we also have a controller, but this time it's not a web controller, but it's a REST controller. So you see, in the previous example, we just had written something like this. It was just a pure controller. But here we have become more specific. We are saying that, hey, this is not a simple MVC controller, but this is a Spring Boot controller, or technically a REST controller. So Spring provides a separate annotation for that, which is @REST controller. So you write that particular annotation on the top of the controller class which you're creating, and then you provide a request mapping similar to what we did in Spring MVC. But while you return it, you do not return a view technology. You just return the raw response. Here I'm just returning a string, but you can return a JSON object, you can return an XML object, or whatever you want to, but not a view technology. That's what I'm doing. Like you can see, there's literally nothing I'm doing in this. It's just a simple string return statement which I've printed here. And that's all the code I have right now here. I just have these two classes. Okay, so that was all about what I have written in the project, and now it's time to run the project. So I have just reached to the location inside my terminal where the project's pom.xml was present, and if I just do an ls, you will see that there is a pom.xml available here, and all the code directories are also available here. So now I will just run this application, and to run this application I'm just going to type mvn spring-boot:run and hit enter. Once I do that, the Spring Boot application is going to get started. And let's go back to the controller and actually the main endpoint and see what we were doing there. I did a sysout here which said let's inspect the beans provided by Spring Boot, and then I was printing all the bean names. And if I go back to the output, I will see the same line being written here, which was around let's inspect the beans. So you can see that message which says let's inspect the beans provided by Spring Boot, and then all the beans which are available in the application context are printed here. So that's the basic idea which I want to give you, that you can actually build a Spring Boot application and you can write your REST controllers, return a string body from it, and once this is run, then you can also run your application from the web browser as well. So let's try to hit that particular URL which I wrote here. So the URL of hello country. So for that, let me just open a new Cognito window, and our application is already running. So if I just say http localhost 8080/, I get this message here which says greetings from Spring Boot. And this is the message which we were sending from the REST controller. So this validates our understanding that we can invoke a REST controller, which is a Spring Boot REST controller, via the same method, but this time we are not getting an HTML, but we are just returning this particular string. Now you can use the string in any ways you want, so it depends upon the consumer. So that's all I want to cover as part of the Spring Boot. Now Spring Boot is a huge topic, and we can spend hours and hours talking about Spring Boot, but since this is more of an introductory session, so I just wanted the concept to get introduced and remember the value proposition of why you would need Spring Boot. The basic idea is to build RESTful web services or build RESTful microservices. That's the basic idea behind using Spring Boot in your applications. And also remember the difference between Spring MVC application and Spring Boot application. Spring MVC is for building web application. Spring Boot is for building RESTful applications which might not have a web interface integrated with them at that moment. So that's all I want to cover for this particular session. And in the next session, we are going to have a look at an advanced Java project using some of the concepts which we might have learned during this whole journey.
So a RESTful web service is nothing but any endpoint which you can access or you can consume the data from via an HTTP layer or via a simply web layer, because most of the web traffic which we deal with is built on HTTP. So to take an example, if you go to any website where you sometimes see on the top right corner, you see today's weather. So how is that today's weather coming in? It's coming in via a REST web service. The website which you are accessing is basically hitting an HTTP endpoint, which is where the weather application is sitting, and it asks for the weather data, and that REST web application just returns the data, and that's how the website is able to show you the current weather. So RESTful web services are everywhere, and they are the most popular way to build applications today, where you just build your RESTful web service and you expose an HTTP URL. And then the consumers need to just access that HTTP URL to consume the data from your application. And you see, this makes it very easy because there is no data type restrictions. There is no tight coupling here. It's just an HTTP endpoint. So that's the basic idea. And we will look at a project where we will be using Spring Boot to build a RESTful web service. And then we will try to run that web service to save some data and also to return some data. So here on the package explorer, you see I have created a project called REST service. And let's just walk through the structure of it, and then we'll go into the details of it. So we have an src main Java where I have a package and I have a bunch of classes here. And before we go to the classes, let's first also access the dependency file, because every project needs some dependencies, some jars to execute it. For example, Spring itself is basically a jar. So you need to include the Spring jar in your project so that your project can become a Spring project. And there are generally two dependency tools. One is Maven and one is Gradle. In this particular project, I am using Maven dependency tool for downloading and managing the dependencies which are needed to run this project successfully. And the way you will find if it's a Maven project or if it's a Gradle project, for a Maven project, you will see a file called pom.xml. And if it's a Gradle project, you will see a .gradle file. That's how you can spot whether the project is using Maven for dependency management or it is using Gradle for dependency management. So let's open the pom.xml. Since it's an XML file, it will be a bit verbose, but if you just read it piece by piece, it will become easier to understand. First of all, since this is a Spring project, I need to include the parent dependency, which brings a lot of good defaults, sensible defaults from Spring Boot automatically. And this is the jar name. This is the artifact ID, which is Spring Boot starter parent. So any Spring Boot project you are starting, do include this parent. This parent is basically bringing all the dependencies from some other jar, and you can make your project as a child of this particular parent. So all the Spring Boot projects have this as a parent as a standard practice. After that, you provide your own details in terms of what is the package name, how do you want to see the jar name, and what is the jar actual name, what is the jar version, etc., etc. You also set the minimum required Java version to run this application. And then you, in the dependency sections, you provide all the jars which you need to run your project successfully, both compile and run your project successfully. So we added the Spring Boot starter web dependency, which basically brings all the dependencies around making a controller or making a repository, context component scan, all the interesting features which Spring provides get wrapped up inside the Spring Boot starter jar. And you can actually go to the MVN repository and have a look at what all classes it provides. It's a lot of classes. So I'm just telling you in a brief that it provides all the RESTful functionality. Then you have the next dependency as Spring Boot starter data JPA, which is going to enable this project to also have a database. And if it has a database, then you need Java to talk to the database. And the way Spring suggests to talk to the database is via using the Spring Boot Data JPA library. We will see this how this library can be used, but basically this provides ways to represent your Java object in the database. And then you need to also add the actual dependency of the database. And in this case, we are using an in-memory H2 database. So I'm not using an external database like MySQL or Oracle or PostgreSQL, because that will just make more configurations more complicated. I just wanted to keep it simple. And generally, you in this H2 database, you can easily access by adding this dependency, and it will be an in-memory database created for you. Then I've also added Spring Boot starter test here, which will be used whenever you are writing unit tests, and you must write unit test for your project. And then we need to add the plugin so that Spring Boot can run this project. That's all I have in the pom.xml. Now let's move to the interesting part, the Java section part. Let's start from the main class. So this is how the main class looks like, where you just create any name with the class, and then you add a public static void main method. Inside the public static void main method, you call Spring application dot run. And this run method is basically going to run your application, and you just provide the same class name which you just wrote here. So you just say dot class. And if you're supplying any command line arguments, it can interpret that command line arguments as well if you want. So you'd always need an entry point in an application, and this is the entry point which Spring Boot supports. And this is, if you see this code, this is just normal code. To make Spring be aware about this class being treated as an entry point, you need to add @Spring Boot application annotation on top of the class. This is one of the annotation which is coming directly from the Spring Boot library. You can see this import. So once you add this, then only Spring will be able to treat this class as an entry point. Otherwise, Spring doesn't know where to start from. So when you run Spring, it will try to find a class with an annotation Spring Boot application, and then inside the class, it will try to find a public static void main method. And once it has found both of them, then it will just run the application. So it's very simple, nothing fancy here. And what we are dealing with here is a student object. So we will try to insert a student object, and we will try to retrieve the student object. So if you ignore these annotations which I've added, it's just a pure POJO. It's just a plain old Java object. You create a student class. Let's ignore this field as well for now. I'll just come back to this annotation in this field. But this is just a student class. It has 3 fields as name, age, and address, an empty constructor and a parameterized constructor, and some getters. Intentionally, I have removed the setters because generally, whenever you are building any enterprise grade application, you would like to keep your objects immutable. Means once they have been created, you would not like somebody to allow to change the values of the object. This just makes programming much more easy if you treat all the objects in your application as immutable. That's why I have not added setters here. It's just considered a good practice. So apart from the standard things which we have already seen, there are 2 things here which I want to talk about. Let's first talk about this one. So @entity is the annotation which is coming from JavaX persistence entity, and this makes Spring Boot save this particular object into the database. This is the annotation which you need to put on your class so that Spring Boot knows that this class represents a table in the database. So you need to add this to make sure that this represents a table. Second thing, a table will have a ID. It will have sort of a primary key. So I've created a new column called ID, which is basically representing the student's roll number or something, or maybe a registration number. And here I'm using a couple of more annotations. If you see, these annotations are also coming from Java.x persistence library. And these annotations will basically allow a new ID to be created every time you create a student object. So you don't have to specify the value of this ID variable. Spring Boot will automatically generate a new ID value every time you create a new student object. And how does it generate? You can provide the generation type as well. So currently I've just set it as automatic, but you can set it as identity, sequence, or return or controlled by table. You can also see the explanation of each of these here, but I've just kept it as auto, which basically let the persistence provider pick any appropriate strategy for the particular database. In our case, the database is H2. So that's about the entity class. Let's call this as entity class. Now let's move to the repository. So you need a repository class. Like I explained in that 3-tier architecture, you always need a DAO layer or a repository layer to store your student object into the database. So we have enabled the student object to be saved, but we need a handler which can save this particular file, this particular object into the database. And the repository classes are the classes which will allow you to do that. So you create a very simple interface. You name whatever you want to name your interface as, and then you say extends JPA repository, the type of the object, and the unique identifier of the object. So the type of the object is student here, and the unique identifier of the student object is the ID, which is of type long. So you need to just supply the types: type of the object, type of the primary key, or the type of the unique identifier. And this annotation is coming from Spring Boot. You can see specifically Spring Boot data library, which we added. So you just need to create an interface, extend it from JPA repository, and make sure that you add this annotation as well. Spring heavily uses the concept of annotations, and this will help Spring understand that this is a repository layer class, and it will apply some more metadata to this class while this class is running in the JVM. So what happens here? You just created an interface. You did not provide any method to create or any method to delete or any method to get a student object, because all of that is automatically provided by Spring Boot via the JPA repository class. If we go inside this class, and if you scroll down, you will see the find all method, find all by ID, save all, flush, save and flush, delete, etc. And if you go further up, this also extends the paging and sorting repository, which provides pagination and sorting facilities. But the interesting one is that paging and sorting repository again extends a CRUD repository. And if you go to the CRUD repository, you will find all the basic methods to save an entity, save multiple entities, find an entity by the ID. That's why it needed that long type to make sure that it can execute this method. You can check the existence of an object, find all the entries, find all by ID, count them, delete them. So all the basic CRUD functionality. So we call them as CRUD because the reason it is called CRUD, because create, read, update, delete. That's basically the generic acronym. So because this CRUD repository provides all the methods and their implementations automatically, we do not need to write any code at all. So that's why Spring Boot is so awesome, and that's why Spring Boot is very popular, because it's zero code in the repository and you still get all the CRUD functionality. So that's about repository. Now we have covered the entity class, we have covered the repository class, we have covered the entry point class. Now the only thing which is remaining is the endpoint, the HTTP endpoint, which I talked about. And that you can create by creating any class. Generally try to suffix it with the controller so that your core developers can easily find this class. And make sure that you put @REST controller annotation on top of it. This annotation will allow Spring to treat this particular class as an endpoint class. Then you can auto-wire the student repository. So if you remember, I talked about the whole dependency injection and inversion of control. So here dependency injection is in action. So here you're just telling student controller to auto-wire the student repository. And now what will happen that at runtime, student controller, or actually Spring, will automatically create an object of the student repository and supply that object of student repository to student controller. So you as developer do not have to create an object of student repository explicitly. That's the benefit, and that's how the dependency injection is working, because you inverted the dependencies now. The dependency is just injected into the class, and as a developer, you don't have to take control of creating the objects. It's the Spring which will automatically read the auto word annotation and will automatically supply an object whenever it is required. Then I have two methods here since we are talking about HTTP endpoints. So I have represented a post method here and a get method here. The way you will write a post method is via @post mapping annotation. And then you can provide the URL path on which somebody should call your endpoint to save something. So for example, somebody can call it HTTP localhost 8080/student/create. Whenever they hit that URL, the control or that request will directly hit this particular method. Why? Because you have provided the URL mapping here in the post mapping annotation. So since it's a post method, there would be request body. What is the actual request body which the client is sending? And you can represent that request body with the @request body annotation, and you can provide the type of the request body. And here I'm saying that, hey, if you want to access this particular URL, yes, all good, but you need to supply me with a text representation of the student object or a JSON representation of the student object. And then inside the method, I'm calling student repository dot save, which is going to save the student object which is coming in. So you see there's a lot going on here. I will show you how the student is represented in the request body as well. And then I will come back to how it got converted from JSON to Java. But this is how you can store this particular student object. You can hit this API as many times as you want and keep inserting a new student object every time. Then if you want to fetch a particular student, then you can do that by supplying the /student. And then in the curly braces, there's an ID written here. So basically you can supply the value of the ID of the student. So generally there would be another method here, which would be find all to see all the students and with their ID, and then you can pick a particular student's ID, supply that student ID value here dynamically. That's why at the curly braces supports dynamic value. So here it can insert 1, 2, 3, or whatever the student ID you want to fetch the value for. You provide that value in the student/ID and all good. Then if somebody is hitting the URL with saying localhost 8080/student/1, then student with the ID 1 will be returned from the request. And you need to put @get mapping to make sure that this method is treated as an HTTP get method. And you can provide the type, you can say get student, and here this dynamic value is captured with the @path variable, because you need to know the ID, right? Whatever ID somebody has supplied it in the URL, you need to capture that IDE and then use that IDE for calling the repository. So you can do that by using the @path variable. So here I'm just saying whatever ID is coming in, I will store that value inside this IDE. Once I've done that, then I can again call student repository dot find by ID, which is again a built-in method provided to me by the CRUD repository. I can supply the ID, and this actually is going to return an optional object, which is an object which may or may not contain a value. So it's just a defensive programming style. So this will return an optional, and you can call a get method to return the actual student object. This will return an optional of student. So optional of student means that this optional object may have a student or may not have a student. Why did Spring do that? Because the ID somebody is supplying, that ID can be invalid also, right? So optional object takes care of that if there is no student found, then you will not get a null pointer exception. And if there's a student found, you can return that. So it's just a defensive programming style which Spring has adopted by returning an optional of the student object rather than directly the student object. But if you're confident that this particular optional of student object does contain a student object, then just call optional.get, which I've called here, which will return the actual student object sitting inside the optional object. You can read more about the optional object and its usage from the official Java docs, and there are tons of examples available on it on internet. So this is about the controller. We have covered all the classes. Now it's time to run the application. So you go to the command prompt, you go to the particular file folder location, and there you just say mvn spring-boot:run. So I just hit enter, and this is going to run the application. It's going to spit some logs here. And if everything is fine, you will not get an error, and you will just be getting a message saying that application got started. And it's running on Tomcat localhost 8080. with no context URL. So this is not a web application. This is a RESTful web service, right? This is a RESTful service. This is not a web application. So there is no web interface. So how do you access this? You just have an HTTP URL. So you can use any of the REST client available on the internet. There are probably hundreds of different REST clients available on the internet. You can choose any one of them. I am using advanced REST client, which you can also install as an extension from the Chrome browser itself. So if I just open the Chrome browser and I just say REST client, if you just write this and hit enter, you will get many different options. And the first option you get is from Google Play Store's App Store. So you can go to the App Store, basically the Chrome Web Store, not the Play Store, but the Chrome Web Store, and you can just install this. Since this is already installed, you can click on Launch App, and it will open this interface for you. So this is this is not a tutorial for advanced REST client, so I'll just be quick here. You can choose the method type which you want to hit. So let's say I want to do a post, and then you can provide the URL here. So remember the URL which we put here in the controller method, this has to exactly match. So HTTP localhost /student/create should be the URL. So let me just copy paste this one here. Okay, so the URL is good here. It's a post type of method which I want to do, and I want to hit this particular URL. Now I need to supply the content type and the body. So in the content type, you can choose application JSON because I'm going to supply a JSON object. And in the body, this is how the JSON object looks like. Advanced REST client also provides a nice visual interface to basically create this JSON. If you are thinking that JSON creation is very tough, it's not actually tough. It's just curly braces. And then you put key and value, comma, let me just put an enter here so that it's more readable. So you just put curly braces starting and end, and then you just put key value. You put a key, which is the variable name and the variable's value, variable name, variable value. And these keys have to exactly match the student's properties. So the student.java had this name, age, and address, right? So it has to exactly match. Otherwise, this request will fail. So this is all good. Now I can send this particular request. When you click send, it is going to hit my Spring Boot application, which is running on localhost 8080. It is going to call the student/create method. It is also going to convert this JSON into a Java object because here I'm supplying a Java object. So it will convert the JSON, which I'm sending from here, to Java object automatically, and it is going to automatically save it here because I've called the repository.save method. So let's hit send here. Once I hit send, I get a 200 OK. It means everything went fine. And in the response header, I get the object back because I have returned the object here. You see, this save method is going to return the same student object which you created. So everything is good here. My object has been stored here. And now it's time to fetch the object. So it has already been saved into the H2 in-memory database, and you can obviously go and connect to the in-memory H2 database and have a look at it. But for simplicity, I'm just going to do this here. And let's say the first object is generally added as the ID 1 by default by the H2 database. So let's hit this particular URL. When I hit this URL, it is going to hit the student controller here. And in the student controller, it is going to hit the getStudent method, which is having a student/ID URL, and it is going to find the database with that ID. And if it finds a student object with that ID, it is going to return that. So let's confirm that now. So let's hit this particular send button, and it is going to hit a get request with this particular URL. Spring Boot is going to find if a student with the ID 1 exists in its database. So once I hit send, I get a 200 OK. And you see in the response headers, I get the same student object back, which I added. Let's try with 2 now. Let's see what happens. I see 2 and I get 500 internal server error because there is no object stored in the H2 database of the Spring application with the ID 2 yet, because we only inserted one object. That's why only one student object is there, and the first ID which H2 database created for it automatically was 1. So when you hit for get request with a student ID 1, you get the object. When you put any invalid value and you hit this, you get a 500 internal server error. You can also make it look nice by not sending the 500 internal server error and sending a nice exception from the backend. So from here, you can also send a nice exception that if this object is not found, you can say something like that, or else throw, which is again an optional object. And here you can supply a particular type of exception which you want to supply instead of just throwing 500 internal server error. But that's just additional defensive programming you can do. You can add more and more validations and constraints into this project as you build this project in a more complex paradigm. So this is basically what I wanted to show you, that we have created a Spring Boot application. We have connected it to a database. We have created also an HTTP endpoint with student controller. We ran that application. We used any random REST client. In my case, I used advanced REST client. And we first did a post request. We provided the exact URL. The URL has to exactly match with the controller URL. And then the request body also has to exactly match with the student objects property, especially the case of the names have to exactly match. So if all this matches, then you will get a response back that the object has been created. If you want to fetch the value of the object, you're going to use the HTTP GET method, and you again provide a URL which has to exactly match to some method in some controller in the Spring Boot application, which is running on localhost. And if you provide the right ID, you are going to get a valid result. If you provide an invalid ID, you're going to get a 500 internal server error. And from here on, you can make this controller as robust and as mature as you want. You can add find all method. You can add a update student method. You can add a delete student method. You can have all different kinds of filters. Like, for example, return to me all the students starting with the name A, or return all the first students with the roll number 1 and 100, or between 1 and 100. So you can write as many endpoints as you want and build this application with as much maturity and as much complexity as you want. And that's all I want to cover in this particular lecture. And in the next lecture, we are going to have a look at another project, which will be pure advanced Java project with no Spring Boot involved.
The top 10 Java project ideas. So the first project that we will deal today is the online courier management system. So this particular project motto is to deal with the courier management system. The system will be used for day-to-day activities like buy, return, booking, delivery and non-delivery, and self-pickup, etc. It is not easy to build this particular project all alone, as the technicality of the project is a little complex for a single programmer. I would suggest you that you get a team with you and also look out for some automation in the process by developing the relevant software. Robotic process automation is the new normal in today's life. The web-enabled interface allows the user to log in from anywhere in the world and track their courier and also view the customer rating. The system is designed to integrate with financial accounting to eliminate duplication of data entry and is also scalable to grow along with your company. The system needs to be built with user-friendly screens, rich in functionality and features, and finally the major part. It should maintain a high level of data integrity. So with that abstract discussed, now let's look into the features offered by this particular online courier service. As discussed in the abstract, this particular project should be providing the features of order and dispatch of the product, information regarding the customer, delivery executive, and followed by the delivery executive, we should be also having a payment window which manages the accounts and bill reports. So having said that, let's now move into the software requirements. So the software used in this particular project is the programming language, that is Java. Database is the Microsoft Access and some convenient RPA tools. And finally the IDE. The IDE for this can be anyone which has a good support for Java. The most preferable one would be the Eclipse. And then comes the IntelliJ, NetBeans and many more. Now creating this kind of a project will give you a valuable experience based on building a fully fledged e-commerce website or an application. I mean, this is how the world's leading applications like Amazon, Flipkart, Zomato, etc. are basically planned and have reached greater heights today. This kind of project on your resume could make a huge difference. And who knows, tomorrow you might even get into one of those companies and start working on their projects or build a company of your own. Followed by the online courier system, we have the online voting system. Now thinking apart from getting a job or starting a new company of your own, this is something that we all need today in this pandemic situation especially. In the current scenario, the internet has brought all the ease to our living room. It has replaced physical banking to internet banking, ordering food online, buying movie tickets, buying clothes and household items, to consult your doctor for minor issues, bill payments and many more. Yet, for quite a long time, going to polling booth and standing in a long queue to cast a vote has been persistent, and it has been challenging for the government to motivate common people to participate in the election system and cast their vote. just because there is no other way to do such thing as such an online voting system. But all the credit can be achieved by software engineers who can make it possible soon for everyone to cast their vote to their respective candidate as their own choice with an unmatchable ease. This can be done just by click on their fingers. This is an advanced Java project developed to show online voting functionality. Followed by the abstract, we will get into the technicality of this particular project. So the first phase of this particular project has the admin phase, where the admin has the right to manage the candidates, manage the voters and their profiles and passwords, and finally election results. Followed by the admin, we have the voter or the user of this particular application. The voter or the user gets to register himself or herself into the application. Followed by that, he can use the login and logout options. And next we have the profile and password managements. So followed by that, we have the option to choose the positions to vote and finally to cast the vote. Now this particular project is an advanced level Java project developed to show online voting functionality. It showcases the use of Java servlets, HTML and CSS. Again, coming into the IDE. The IDE for this can be anyone who has good support for Java. The most preferable one would be Eclipse and IntelliJ. Followed by the online voting system, we will now continue with the online healthcare management. Named as the corporate Medicare management, this e-healthcare management system is a web-based project developed in Java. The main aim of this particular project is to provide effective management of data related to staff and patients in hospitals or clinics. The features offered by this particular project should be as follows. It should optimize bed occupation. The project should improve the use of operation theaters, avoiding the cancellation of operations. To know how much emergencies affect the administration of the hospital departments or services which include cancellation of operations. To optimize the allocation of human and material resources to wards and shifts. To detect the influence of certain diseases in the hospital services, and finally to find clusters of patients. The software requirement for this particular project are as follows. We need DHTML for the front end and Java as the programming language, and data mining tool which is Weka, and Oracle for the database, JavaScript for the scripting language, and finally Tomcat as our server. The e-healthcare management system is a web-based application that assists the management of staff, doctors and patients in an easy, comfortable and effective way. Here, the concept of data mining plays a vital role to develop an effective healthcare management system. The proposed application aims to create a friendly working environment for any healthcare centers to overcome the drawbacks in the existing system of healthcare management. This system is very reliable and flexible from all aspects, so new features and modules can be easily integrated into the system in the future. Followed by the e-healthcare management system, we have a new normal, online banking. Not interesting and arousing for a normal person, but for a hardcore programmer, it is as exciting as a roller coaster ride in an amusement park. Because this is how the major national and multinational banks implement their banking facilities in a wide range so that their customers could experience the ease of banking at their fingertips. One such type of project on your resume could bring major highlight to the recruiter, especially if the recruiter is from a banking or financial based company. Online banking system project is a model internet banking site. This project should enable the customers to perform basic bank transactions by sitting at a corner of their home or office through a phone or laptop. The customers can access bank's website for viewing their account details and perform the transactions on account as per the requirement. Bank employees can log in and add customer and account information to perform transactions with internet banking. With internet banking, the brick and mortar structure of the traditional bank gets converted into a click and portal mode, thereby giving the concept of virtual banking a real shape. Thus, today's banking is no longer confined to branches. E-banking facilities banking transactions by customers round the clock globally. The features you can offer through this particular project are homepage for online banking site, creation of new accounts, login and logout, manage profiles and passwords, view the balance of the account, deposit the amount into the selected account, withdraw amount from the selected account, transfer the amount from one account to another, close the account. So the software requirements for this particular project are Java programming language and JavaScript for scripting language and Oracle for database and Tomcat for server. So followed by the online banking project, we have the online examination project. Online exams are normal for us nowadays, but this is totally limited to high-end exams like CET, GRE, CAT, etc. The requirement for this particular project is increasing day by day because of the current scenarios. Many schools and colleges have now turned towards the online education system and are looking forward to hosting online exams for student safety. Online examination is a simple project developed to provide an online platform for faculty and students to conduct online examinations and their evaluations. This particular project has two parts. First is the admin part. Admin has the right to add students, create one-time login, adding questions, receive answers, and finally to evaluate. Followed by the first part, we have the second part which belongs to the students. So the students can log in, update their profile and password, select answers for the MCQs, write answers to questions, and finally closing the session and log out. This particular project can be made a grand success by making use of simple Java servlets and Java programming languages and server like Apache Tomcat. Followed by the online examinations, we have the Smart City. Smart City Java project can be a web-based software developed to store the details of a particular city. The main purpose of the project is to help tourists and other visitors to a city by providing information about hotels, transportation facilities, air ticket booking, shopping details, city news, etc. The Smart City Java project serves the visitors as a guide of the city, and hence the project is called as City Guide Project in Java. Using this project, the details of the city can be accessed from anywhere at any time. The implementation of this city project promotes tourism and business effectively. Hotels can be searched more easily from anywhere. With the help of this online software, students can look out for academic institutes located in the city. You can view the complete map of the city using this project. Followed by the abstract, we have the features of this particular project. The features offered in this particular project are login, update profile and password, search for the options, select an option like booking a ticket or hotel or anything like transportation, etc. And finally selecting that particular option, booking that option and payment window. Finally, the confirmation of the order. This particular project can be fulfilled by using the following software tools as mentioned below. They are the Java programming language, Tomcat server, scripting languages like JavaScript, etc. and database as Oracle for interactive data storage. This could be escalated to another level by following. Design drones that can act like a cop, act as a tourist guide for the people touring the city, a drone that has capability to take pictures, videos of suspected activities and store it for future reference. A drone can intimidate a cop if any suspected activities are detected. There can be many drones in the city with different functionalities, and finally you are required to implement the functionality of the drone to the users to interact with the drone. Users could be travelers or cops or travel agents or cab agents. The code for all these projects are provided in the description box below. Followed by the Smart City, we have the bug tracking system. The bug tracking system is a web-based application developed by Java programming language for software companies. The main aim of this project is to manage the errors or bugs that occur during the software development phase and cycle. After the implementation of this project, the employees can update the issue details, solve the issues, and update the system for any location with internet access. Below are the features of this project, and source code of this project is linked in the description box below. Coming into features, the software is applicable in managing the bugs that occur during the development of software and tracking the older issues. It facilitates searching the facility to bug history and solution. The system is fully secured and authentication method is adopted to manage security. It stores the older bug reports so that they can easily be solved when they reappear. The application helps the project manager in evaluating the works of the employees. And finally, the proposed software is capable of auto update when the latest version is available. So the software requirements for this particular project are programming language, which is Java, web-based applications such as JDBC, JNDI, Servlets, JSP, and Oracle database or Access database as the database. Followed by that, the server deployment is Red Hat, JBoss, AS, etc. And the client-side scripting as the JavaScript. And the IDE for this particular project would be Eclipse with all the My Eclipse plugins. And finally, the user interface can be designed using HTML and CSS. So with this, we can move ahead into the next project, which is the facial recognition. The face recognition with OpenCV is an open source computer vision library that has tons of modules like object detection, face detection, and augmented reality. The major features that this particular project offers are managing the use of faces, facilitate face identification, easy login and logout, store face IDs, identify suspects with just images, enhanced way to find cyber criminals. So followed by the features, now we should look into the software requirements to build this particular project. So the programming language we need for this particular project is Java, and followed by the programming language we need the Apache Ant framework, Ming W64, and finally the CMake framework. So followed by the facial recognition project, we have the next project, which is the vehicle recognition. So Java ANPR is a number plate recognition software which implements algorithmic and mathematical principles from artificial intelligence, machine vision, and neural networks. So the features offered by this particular project are high-level language for numerical computation, interactive environment for iterative exploration, mathematical functions, built-in graphics, functions for integrating MATLAB, and many more. So this particular project can be fulfilled by using OpenCV and Java programming language along with some natural language processing algorithms. So followed by vehicle recognition project, we have our last project, which is the speech recognition system. So speech recognizer converts audio to text. Java x.speech.recognition package defines the recognizer interface to build speech recognition plus a set of supporting classes and interfaces. So the features or stages in this particular project are to create a speech recognizer, allocate resources, load and enable grammar, attach result listener, commit changes, and finally provide the process results. So this particular library is readily available in Java, and you can code this project using the Java programming language and an IDE such as Eclipse.
So in this session, we are going to focus on a particular project. And the project we are going to focus is about an ATM application. So you might have interacted with different ATM stores in your cities where you go in, you insert your card, you enter your PIN, and then you can view the balance, you can withdraw some amount, you can also deposit some amount from the ATM. So we will try to look at it from that perspective, and we will see what kind of different Java and OOPS concepts we can use to build such ATM application. This is not a super versatile application, but this is just to give you the idea of how to use those OOPS concepts to build a simple or a complex Java application. So let's start from the options menu class, because that will give us the understanding of what kind of functionality I'm using. And here you will use that I'm using different concepts which I have taught you so far in this particular series. So for example, we are using the IO exception, we are using the hash map class, we are also using a scanner class, which is used to take input from the command line. So this option menu class is extending the account class, and I will come to the account class in a while, but let's see what this option menu class is doing. This particular class has it is using a decimal format money format class, which is to denote what kind of format of money you have. Then we have a hash map, which is storing the couple of records of account number to PIN mapping. So we create a map, and inside the getLogin method, we add couple of entries to the map. Here, the first entry, the first integer is pointing to the customer number, and the second integer is pointing to the PIN of the account of this particular customer number. So if we call the getLogin method, this method will insert the data. After that, it will ask the customer to enter the customer number, which has to be one of these two. If you provide any other value, then there should be a logic in the application to reject the input. So whatever customer number the customer inputs, we pass that inside this particular method called setCustomerNumber. Again, I will come back to that. And once you have provided a valid customer number, then this method is going to ask you to enter a PIN number. And remember, I told you this is the customer number to the PIN number mapping. So whatever customer number you select from here, you will be providing the corresponding PIN number. And again, if you provide an invalid PIN number, you will get an error. So that will all happen inside this try block. And if you enter any invalid characters in the PIN number or the ATM customer number, then you will get an exception, which I am writing inside the catch block. This is all what we have seen so far. After the successful enter of the customer number and the PIN number, I fetch those values from these two methods. Again, I will talk about what these methods are doing. And again, I'm doing some basic validation checks, but things get interesting in this method. So what we covered so far was the get login method. Let me close this method here. So we covered the get login method. The second method, which is defined in this particular class, is the account type. So here we will ask once the customer has provided the customer number and the PIN number, we will ask the customer to provide the account type. This application supports two different account types, which are checking account or a savings account. So the customer has to choose one of them. Again, we will be taking the input from the command line using the scanner class. And then I'm using a switch case. If the customer entered 1, then I will execute some code for the checking account, which is defined here in the case 1. And if the customer entered 2, then the case 2 will be executed. And if it enters 3, then I will exit the application by just printing a sys out. So here I'm using the switch case construct to provide different options to the customer. There's also a default case specified here, which says invalid choice. So this is what is happening in the get account type method. The next method is if the customer has used the option 1, then we call the get checking method. So let's go to the get checking method, which is the next method which is defined in this particular class. So if the customer has selected a checking account, then we provide the following functionality to the customer, which is the customer can view the balance, customer can withdraw the funds, customer can deposit the funds to the checking account, or they can just exit the application. And again, I'm using a switch case here. Based on the customer types 1, 2, 3, or 4, the corresponding case block will be executed. For example, if the customer wants to view the balance, then this block will get executed, and I call the get account type method. If the customer selects the 2 as the withdraw fund, then get checkings with withdraw input method gets called, and then get account type gets called. Similarly, if the customer enters 3, then we deposit the fund. And for that also, I have defined a method. I will go to the definition of these methods as we go along, but right now we are just building the framework. So the get checking deposit input method will be called whenever the customer selects the option 3. And for option 4, we just exit the application. So this is what is happening in the get checking method. Now, if from the account selection, if the customer selected second option, which was savings account, then we were calling get saving method. So this is where the get saving method is defined. And again, it is following the exact same format as we saw in the get checking method, where we present the following options like viewing balance, withdrawing the funds, and depositing the funds in the savings account. And I have some methods defined here. For example, get saving withdraw input, get saving deposit input. So we define the switch case here based on the customer's choices here. And that is what is happening in the get saving method. So let me close this method as well. And that's all what is defined inside the option menu class. So we ask the customer to enter the customer number, the PIN number from this get login method. Then based on that, we provide the customer the options to choose the account type, whether they can choose the savings account or the checking account. And based on that, whatever account type they use, we call the get checking or get saving method. And inside this method, we provide the customer the other options to either withdraw the money, deposit the money, or view the balance. That is what is happening inside this option menu class. Now let's go to the account class, and all the methods which we saw here will be provided a definition in the account class. You also see this option menu is extending the accounts class, so an inheritance concept is being used here. Let's go to the account class now. So this is the account class where I have defined some private member variables like customer number. So now you will be familiar with the customer number PIN number, which I just described, and also with the checking balance and the savings balance. You can also divide this account class into two child classes where you have a savings account class and a checking account class. But for simplicity, I've kept it to one class. I'm initializing a scanner input which will be used at multiple places, and then I have the setters and getters for these four member variables. So you see set customer number, get customer number. If you remember, this set customer number was called in the option menu class. If I go back to the get login, once we ask the customer to enter the customer number, we call the set customer number, which gets called here. Similarly, we call the set PIN number, which gets called here. Similarly, once we have set that, we were fetching the values using the get customer number and the get PIN number, and that is also defined here in terms of the getters, get PIN number and get customer number. Similarly, we also have the getters for the checking balance and the saving balance member variables. We do not have the setters for them because they are not technically setters, but we have to calculate the balance. It's not a simple setter where you can just return the value. So now let's look at some of the business functions of the account class. How do you deposit? How do you view the balance? How do you withdraw the balance, etc. So you see these two methods, which are specifically when the customer is trying to withdraw the money from their account. And these methods are basically called internally by other methods. So we will come to that. Let's just understand that we have two methods for calculating the withdrawable amount or executing the withdraw transaction for the checking account and the savings account. Similarly, I have two more methods here, which are calculating the depositing for the checking account and calculating the depositing for the savings account. And then we get the bigger methods, which are using these calculation methods. So I defined four calculation methods so far: calc checking withdraw, calc saving withdraw, calc checking deposit, and calc saving deposit, basically withdrawing and deposit for both of the classes. And then we have these business functions called get checking withdraw input and get saving withdraw input, get checking deposit input and get saving deposit input. So these getter methods are something which were being called from the option menu class, if you remember. If you go back to the option menu class and if you chose the checking account, you get these options. And let's say you chose option 2, which was withdraw funds, or option 3, which was deposit funds. Then the corresponding methods which were being called were get checking withdraw input and get checking deposit input. And this is the exact same method, get checking withdraw input and get checking deposit input. So if you see what is happening inside this particular method is a couple of sysouts. Then we take the scanner input amount and we convert that amount to the double. After that, we check if the amount which the customer wants to withdraw is smaller than the checking balance or not. And I'm running this condition to check that. If the amount is smaller than the checking balance, then we call the calc checking withdraw method, which was defined right here. Remember, I told you that these four calc methods will be used, and this is how they are used. So here I'm actually subtracting the value. So whatever amount the customer wants to withdraw, subtract that from the main balance and then return the new main balance. That's what you do, right? If you have 1,000 rupees and if you want to withdraw 500, you subtract 500 from 1,000 and then you send back the remaining balance. So that is what is happening when we call this method, and then we print the new checking account balance. That is what is happening in the get checking withdraw input method. Similarly, if you chose option 3, which was depositing funds to the checking account, then get checking deposit input gets called, and it is defined right here, get checking deposit input. And here, instead of subtraction, we are doing the addition. So here I'm again doing a condition check that the current balance plus the new amount which has been supplied by the customer from the command line the total sum of it should be greater than 0. What if the customer entered an amount minus 5,000? I should not allow that. So that's the reason I'm putting this condition in place. And if the current balance plus the new amount which is supposed to be deposited to the account, the sum of it is greater than 0, then call the calc checking deposit method. And this is where the calc checking deposit method is present, and where I'm just doing present balance plus the new amount and returning the new balance. That's all which is being done here. And you will see exactly similar logic running for the savings account as well. If you look at the get saving withdraw input, which is used to withdraw money from the savings account. So I take the input from the command line and I run a condition check that the amount which the customer wants to withdraw should be less than the current saving account's balance. If yes, then call calc saving withdraw method, which is defined here, where I subtract the amount from the current balance and I return the new balance. And similarly, you will see the exact same functionality in the get saving deposit, where we add the money instead of subtracting the money. And this is all what is defined in the account class. So we talked about the option menu class, we talked about the account class, and now we have the ATM class, which is the entry point, which basically initializes the option menu class and calls the get login method. Remember, get login was the first method which asked you to provide the customer number, and then get login called the method to choose the account type, and the account type methods then called the method to choose the option to withdraw, deposit, or exit. So now we have built a fair understanding of what is happening in this application. So let's run this application. So I just ran this application, and let me bring the console here. It's first asking for a customer number. So I will go to the option menu class and I will pick up one of the customer number which I have hard coded here. So I will provide that customer number and hit enter. Then it asks me for the PIN number. So remember, you have to provide the correct PIN number corresponding to the customer number. So I'm taking this PIN number, just copying it and pasting it here. Then this whole code got executed, and then it called the get account type, and the get account type method provided you with these options, which you see here on the screen. So based on what you select, the case block will get executed. And let's say I want to go for a checking account. So I press 1 and I hit enter. Once you select the checking account, the case 1 gets selected and it calls the get checking method. And the get checking method again provides you with another menu, view, withdraw, or deposit, or exit. So let's say I want to deposit funds. So I press 3 and hit enter. It says the current balance is 0 and enter the amount you want to deposit. Let's say I want to deposit 500 and I hit enter. You get the message saying the new checking account balance is 500 and you have successfully deposited the money. And that is what I did for the checking account. Now let's try to withdraw something from the checking account. So you again get back the same option, because inside the get checking method, we call once we have successfully done the business operation, we again call the account type method to display the menu again to the user. So let's say again select the checking account class, and this time I want to withdraw the funds. Remember, I've added 500 there. So let's say I want to withdraw, so I choose the option 2 as the choice. Current balance is 500 and it's asking me the amount you want to withdraw from the checking account. So I enter, let's say 100, and I hit enter. When I do that, the new checking account balance becomes 400. So the 100 got subtracted from the 500 and the new balance is shown to your screen. You can do exactly the same thing for the savings account as well. And let's also run a negative condition. So I again select the checking account and I want to withdraw the funds. I choose the option 2. Current balance is 400 and I would like to withdraw 1000. What happens? If you do that, we get a message saying balance cannot be negative. And this is coming from the calc checking method, which is defined here. So what is happening that I wanted to withdraw the funds from the checking account, and here get checking withdraw input got called. Here this condition was checked. So the checking balance was 400 and the amount I wanted to withdraw was 1000. So 400 minus 1000 is not greater than equal to 0. So it jumped into the else block and it said balance cannot be negative. So this is how you can also build some error conditions in your code which are mandatory and which should be built. Otherwise, your application will have a lot of bugs. We can also exit the application. So if you just type 3 and hit enter, you will exit from the application and it will again call the login method where it will again ask you to enter the customer number. So this is how you can run this application, and this was a simple use case for you to show how you can use the different object-oriented concepts like classes, objects, methods, setters, getters, switch case, etc. to build the application with the correct business logic. And this is all I want to cover in this particular session. And in the next session, we are going to have a look at another interesting core Java project just to build our understanding more better about the core Java concept.
Choose from over 300 in-demand skills and get access to 1,000 plus hours of video content for free. Visit SkillUp by SimpliLearn. Click on the link in the description to know more.
Let's get started with walking through a core Java project using all the different OOPS concepts we have learned so far. So in this example, we are going to have a look at a calculator application. And this calculator application supports primarily 4 different operations like addition, subtraction, multiplication, and division. So let's see how do we build that app. So in front of me right now is open the main class. So I have a main app class here, which has a public static void main method. And the first thing we see is a read input class, which is calling a read method. So if you go to the read input class, it has a simple static method here, which is the read method, and it is using the scanner class. If you remember, I talked about the scanner class, which is used to take inputs from the command line from the user. So we initialize the scanner class and we start taking the inputs, and whatever the user inputs in terms of the expression, let's say the user entered 4 plus 5 or whatever, that whole expression gets sent back into this input line as a string. And that comes back here in the input expression. Once we have captured the input expression, the next thing we do is divide the input expression in the numbers and the operators. Basically, an expression would be either something like 4 plus 5 into 3 divided by 2, let's say. Let's say the user entered this expression. So this has either numbers or operators. So that's what we are doing here. We are using the split method of the string API, the string class basically. And this split method is going to split the numbers and operators into 2 different string arrays. And here I'm providing the split expression that split at every time you encounter one of these symbols. So this, when you execute this particular statement, it is going to return a numbers array, which will be created based on this expression. So you will get an array with 4, 5, 3, and 2. And similarly, in the operator array, you are going to split or pick out the elements every time you receive a number. So this operator array is going to hold this plus sign, this multiply sign, and this divide sign. Hope you get the understanding that we are just splitting the whole expression into 2 different arrays, where first array is holding only the numbers and no mathematical expressions, and second array is just holding the mathematical operators and no numbers. And we'll see why we need to do that in the upcoming lines. Once I've created this string array, I just want to store or convert these string arrays into a queue. So I convert this array into a list by calling the array.asList. So this expression is going to return a list. And then I'm going to convert this normal list into a linked list, and then going to store this linked list into the queue of numbers. And I'm going to do exactly the same thing for the operator array as well, converting this into a generic list, converting that generic list into a linked list, and then storing this linked list as a queue. So I have an operators queue and I have a numbers queue. Both of them have been stored into a queue now. And then I'm using the poll method. If you remember, the poll method of the queue is used when you want to fetch the first front element, the head element of the queue. So whichever element is sitting at the head of the queue will be taken out the moment you call the poll method. So I fetch the first number from the numbers queue. So in this case, 4 will be fetched here in this variable. And after that, I run a loop on the numbers queue. And I'm going to run this particular loop till this particular queue is not empty. If you see, there's a negation here. So I'm going to pick up numbers one by one from this numbers queue till the number queue becomes empty. And inside the loop, I do the exact same poll operation for the operations queue. So this operations queue is holding all these mathematical operations like plus, star, and divide. So I'm going to pick the head of it. So in this case, plus will be picked up and will be stored in this variable called OPR. And then I'm going to run a switch case on this OPR. Basically, as I told you, in this particular calculator application, we are supporting 4 operations, which are addition, subtraction, multiplication, and division. So I define a case for each of the mathematical expression. So you see there are 4 different cases here. And for each case, I'm initializing a class. If it's a plus sign, then I'm initializing the add class. If it's a minus sign, then I'm initializing the subtract class. For multiplication, I have a class called multiply. And for division, I have a class called divide. Let's have a look at what these classes are containing. So if I go to the add class, first of all, it is implementing an interface called operate. And this operate interface has just a single method called getResults, which is accepting a variable argument array. If you remember, I told you that you can also use a var_arg array. This is called a var_arg expression. This means that these numbers will be an array of arbitrary length. It can be a 1-element array, it can be a 2-element array, it can be a 4-element array, or whatever you supply. But it is still going to be a fixed length array, but the length is going to be dependent upon how much argument you supply to this particular method. So that is what this interface operate is doing. It just has one method declared, which is called getResult, which is accepting an array of numbers. So if the add class is implementing the operate interface, then it has to override the getResult method. And here it is just doing a summation of all the numbers which have been supplied. So if you supply 4 numbers, it is just going to add up those 4 numbers and return the sum. And the exact same kind of logic or similar logic will be seen in other operate classes. So if I go to the subtract class, it runs the exact same operation, but it subtracts the values. If I go to the multiply class, it is also implementing the operate interface, and in the get result, it is just multiplying all the values. Similarly, in the divide class, it is also implementing the operate interface, and it is dividing all the numbers one by one. So it's doing pretty much the same thing in terms of the expression and the logic. The only difference is whether you are using an add operation or a subtract or a multiply or a divide. So we have checked all these classes and the operate interface as well. And let's go back to the main app now. Now you also see that I've defined a reference of operate here, and each of the switch case block, I'm assigning the object type to this interface reference. So I'm using the concept of dynamic binding, which we talked about when we talked about interfaces, that we can also do dynamic binding where we can assign an object to an interface type. And the object type will depend upon the expression. So once we have filled that based on the case, while filtering out this expression and picking up plus, star, and divide sequentially, then we go to the next line outside the switch case block, which is to pick the next number from the queue. Remember, we already did one poll here. So as per this example, 4 was here in this res. And now when we do this number.poll again, 5 will be picked up because that will be the next head of the queue. So we pick up 5 here, and then we call operate.getResult. Now this get result will be called based on the expression which was encountered first in the queue. Again, looking at the example, the first expression encountered will be plus. So the expression was plus. So the operate type object is of add type. And when you call operate.getResult, the getResult method of add class is going to get invoked, and it is going to sum 4 and 5. This res is holding 4 right now based on what I described here, numbers.poll. And this num is holding the second operand, basically 5 here. So 4 plus 5 gets evaluated here in this case. And then it again goes back here and it checks if the number queue is now empty. No, it is still not empty because we still have 3 and 2 left there. So again, it does the operations.poll and it picks up multiply sign here. Then it again runs the switch case. Since it's a multiply sign, it will go here and it will initialize the operate interface reference as the object of multiply class. Then coming here, it will do a numbers.poll. And this time the numbers.poll is going to pick up 3. So 3 will be picked up here. And then the current value of result, which is already 9, 4 plus 5 was 9. The current value of result will be updated here. So res will be 9 here and num will be 3 here. And when you call operate.getResult, the multiply classes getResult will get called and it will say 9 into 3, which will become 27. It will again go back here to this particular line and it will check again if the numbers queue is now empty. No, it is still not empty because we still have one element left. Then it polls the queue of the operations where the expression divide is present there, which is the only element left in this particular operations queue. And since we have the OPR value as divide, this case block gets called and the new divide class gets initialized. The divide class basically gets initialized. And we come here and we do numbers.poll. Now the last number which is available in this queue is 2, which gets picked up here. And then we again call operate.getResult. This time, since the operate operate reference type was of divide class type, so when we call operate.getResult, the divide operation or the getResult method of the divide class, basically this method will get invoked and it will divide the current value of result, which was 4 plus 5, 9 into 3, which was 27. So it is going to divide 27 by 2, which was the last value of the numbers.poll. It is going to execute 27 by 2, and whatever value it gets, it is going to store a value back into the rest variable. And then it is again going to go back here and again going to check the condition if the numbers queue is not empty, but now the numbers queue is empty because 2 was the last element. So it is going to come out of the loop and it is going to print the final result. That is how this whole program is working. Now let's try to see this in action and we'll try to execute the exact same expression. So if I right click and go to run as and run this as Java application, and I supply an expression saying 4 plus 5 star 3 divide 2. And if I now hit enter, I get the value as 13.5, which is exactly what we ran through because 4 plus 5 will be evaluated first, which will result into 9. Then 9 into 3 will be 27 and 27 divided by 2 will be 13.5 exactly. So this is how this whole program is running, where we first take the inputs and then we divide the input into numbers and operation arrays, or in fact queues. And once we have those queues built up, then we pick up the first number and we keep running this loop till the numbers queue is not empty. Inside the while loop, at each step, we pick up the first expression or the operator. We check what is the operator, whether it is an addition, subtraction, multiplication, or division operator. And whatever kind of operator we have, we initialize the corresponding class of it. And then we fetch the next value in the numbers queue. And then we call the get result based on the expression and whatever result we get from the get result, we store it back into the rest variable. So we keep updating the rest variable at every step. So that's the reason the result of 4 plus 5 gets stored in the rest, and next time you are calling the get result for a multiply operation, here the rest value is 9 now, and it says 9 into 3. Again, in the next time, the rest value will be updated to 27 because we are storing the result back into the result variable. So this is all I want to cover in this particular session, where we looked at an example of a calculator application purely from the console standpoint. Obviously, there can be a lot more stuff which we can do into this particular application, make it more error-free and cover a lot of corner cases like validating the inputs, etc. Also, looking at putting some conditions around the exception handling the divide by zero scenario, etc., which is not here. But this is just to show you the basic idea of how you can build simple to complex CLI applications using the core Java concepts. So in this example, we are going to have a look at a calculator application. And this calculator application supports primarily 4 different operations like addition, subtraction, multiplication, and division. So let's see how do we build that app. So in front of me right now is open the main class. So I have a main app class here, which has a public static void main method. And the first thing we see is a read input class, which is calling a read method. So if you go to the read input class, it has a simple static method here, which is the read method, and it is using the scanner class. If you remember, I talked about the scanner class, which is used to take inputs from the command line from the user. So we initialize the scanner class and we start taking the inputs, and whatever the user inputs in terms of the expression, let's say the user entered 4 plus 5 or whatever, that whole expression gets sent back into this input line as a string. And that comes back here in the input expression. Once we have captured the input expression, the next thing we do is divide the input expression in the numbers and the operators. Basically, an expression would be either something like 4 plus 5 into 3 divided by 2, let's say. Let's say the user entered this expression. So this has either numbers or operators. So that's what we are doing here. We are using the split method of the string API, the string class basically. And this split method is going to split the numbers and operators into 2 different string arrays. And here I'm providing the split expression that split at every time you encounter one of these symbols. So this, when you execute this particular statement, it is going to return a numbers array, which will be created based on this expression. So you will get an array with 4, 5, 3, and 2. And similarly, in the operator array, you are going to split or pick out the elements every time you receive a number. So this operator array is going to hold this plus sign, this multiply sign, and this divide sign. Hope you get the understanding that we are just splitting the whole expression into 2 different arrays, where first array is holding only the numbers and no mathematical expressions, and second array is just holding the mathematical operators and no numbers. And we'll see why we need to do that in the upcoming lines. Once I've created this string array, I just want to store or convert these string arrays into a queue. So I convert this array into a list by calling the array.asList. So this expression is going to return a list. And then I'm going to convert this normal list into a linked list, and then going to store this linked list into the queue of numbers. And I'm going to do exactly the same thing for the operator array as well, converting this into a generic list, converting that generic list into a linked list, and then storing this linked list as a queue. So I have an operators queue and I have a numbers queue. Both of them have been stored into a queue now. And then I'm using the poll method. If you remember, the poll method of the queue is used when you want to fetch the first front element, the head element of the queue. So whichever element is sitting at the head of the queue will be taken out the moment you call the poll method. So I fetch the first number from the numbers queue. So in this case, 4 will be fetched here in this variable. And after that, I run a loop on the numbers queue. And I'm going to run this particular loop till this particular queue is not empty. If you see, there's a negation here. So I'm going to pick up numbers one by one from this numbers queue till the number queue becomes empty. And inside the loop, I do this exact same poll operation for the operations queue. So this operations queue is holding all these mathematical operations like plus, star, and divide. So I'm going to pick the head of it. So in this case, plus will be picked up and will be stored in this variable called OPR. And then I'm going to run a switch case on this OPR. Basically, as I told you, in this particular calculator application, we are supporting 4 operations, which are addition, subtraction, multiplication, and division. So I define a case for each of the mathematical expression. So you see there are 4 different cases here. And for each case, I'm initializing a class. If it's a plus sign, then I'm initializing the add class. If it's a minus sign, then I'm initializing the subtract class. For multiplication, I have a class called multiply. And for division, I have a class called divide. Let's have a look at what these classes are containing. So if I go to the add class, first of all, it is implementing an interface called operate. And this operate interface has just a single method called getResults, which is accepting a variable argument array. If you remember, I told you that you can also use a var_arg array. This is called a var_arg expression. This means that this numbers will be an array of arbitrary length. It can be a 1-element array, it can be a 2-element array, it can be a 4-element array, or whatever you supply. But it is still going to be a fixed length array, but the length is going to be dependent upon how much argument you supply to this particular method. So that is what this interface operate is doing. It just has one method declared, which is called getResult, which is accepting an array of numbers. So if the add class is implementing the operate interface, then it has to override the getResult method. And here it is just doing a summation of all the numbers which have been supplied. So if you supply 4 numbers, it is just going to add up those 4 numbers and return the sum. And the exact same kind of logic or similar logic will be seen in other operate classes. So if I go to the subtract class, it runs the exact same operation, but it subtracts the values. If I go to the multiply class, it is also implementing the operate interface. And in the getResult, it is just multiplying all the values. Similarly, in the divide class, it is also implementing the operate interface, and it is dividing all the numbers one by one. So it's doing pretty much the same thing in terms of the expression and the logic. The only difference is whether you are using an add operation or a subtract or a multiply or a divide. So we have checked all these classes and the operate interface as well. And let's go back to the main app now. Now you also see that I've defined a reference of operate here, and each of the switch case block, I'm assigning the object type to this interface reference. So I'm using the concept of dynamic binding, which we talked about when we talked about interfaces, that we can also do dynamic binding where we can assign an object to an interface type, and the object type will depend upon the expression. So once we have filled that based on the case, while filtering out this expression and picking up plus, star, and divide sequentially, then we go to the next line outside the switch case block, which is to pick the next number from the queue. Remember, we already did one poll here. So as per this example, 4 was here in this res. And now when we do this number.poll again, 5 will be picked up because that will be the next head of the queue. So we pick up 5 here, and then we call operate.getResult. Now this getResult will be called based on the expression which was encountered first in the queue. Again, looking at the example, the first expression encountered will be plus. So the expression was plus. So the operate type object is of add type. And when you call operate.getResult, the getResult method of add class is going to get invoked, and it is going to sum 4 and 5. This res is holding 4 right now based on what I described here, numbers.poll. And this num is holding the second operand, basically 5 here. So 4 plus 5 gets evaluated here in this case. And then it again goes back here and it checks if the number queue is now empty. No, it is still not empty because we still have 3 and 2 left there. So again, it does the operations.poll and it picks up multiply sign here. Then it again runs the switch case. Since it's a multiply sign, it will go here and it will initialize the operate interface reference as the object of multiply class. Then coming here, it will do a numbers.poll. And this time the numbers.poll is going to pick up 3. So 3 will be picked up here. And then the current value of result, which is already 9, 4 plus 5 was 9. The current value of result will be updated here. So res will be 9 here and num will be 3 here. And when you call operate.getResult, the multiply classes getResult will get called, and it will say 9 into 3, which will become 27. It will again go back here to this particular line, and it will check again if the numbers queue is now empty. No, it is still not empty because we still have one element left. Then it polls the queue of the operations where the expression divide is present there, which is the only element left in this particular operations queue. And since we have the OPR value as divide, this case block gets called and the new divide class gets initialized. The divide class basically gets initialized, and we come here and we do numbers.poll. Now the last number which is available in this queue is 2, which gets picked up here. And then we again call operate.getResult. This time, since the operate operate reference type was of divide class type, so when we call operate.getResult, the divide operation or the getResult method of the divide class, basically this method will get invoked, and it will divide the current value of result, which was 4 plus 5, 9 into 3, which was 27. So it is going to divide 27 by 2, which was the last value of the numbers.poll. So it is going to execute 27 by 2, and whatever value it gets, it is going to store the result value back into the rest variable, and then it is again going to go back here and again going to check the condition if the numbers queue is not empty, but now the numbers queue is empty because 2 was the last element. So it is going to come out of the loop and it is going to print the final result. That is how this whole program is working. Now let's try to see this in action, and we'll try to execute the exact same expression. So if I right click and go to run as and run this as Java application, and I supply an expression saying 4 plus 5 star 3 divide 2. And if I now hit enter, I get the value as 13.5, which is exactly what we ran through, because 4 plus 5 will be evaluated first, which will result into 9. Then 9 into 3 will be 27, and 27 divided by 2 will be 13.5 exactly. So this is how this whole program is running, where we first take the inputs and then we divide the input into numbers and operation arrays, or in fact queues. And once we have those queues built up, then we pick up the first number and we keep running this loop till the numbers queue is not empty. Inside the while loop, at each step, we pick up the first expression or the operator. We check what is the operator, whether it is an addition, subtraction, multiplication, or division operator. And whatever kind of operator we have, we initialize the corresponding class of it. And then we fetch the next value in the numbers queue. And then we call the getResult based on the expression. And whatever result we get from the getResult, we store it back into the rest variable. So we keep updating the rest variable at every step. That's the reason the result of 4 plus 5 gets stored in the rest. And next time you are calling the getResult for a multiply operation, here the rest value is 9 now, and it says 9 into 3. Again, in the next time, the rest value will be updated to 27 because we are storing the result back into the result variable. So this is all I want to cover in this particular session, where we looked at an example of a calculator application purely from the console standpoint. Obviously, there can be a lot more stuff which we can do into this particular application, make it more error-free and cover a lot of corner cases like validating the inputs, etc. Also, looking at putting some conditions around the exception handling the divide by 0 scenario, etc., which is not here. But this is just to show you the basic idea of how you can build simple to complex CLI applications using the core Java concepts.
Let's get started with Spring Boot and how we can build a simple application using Spring Boot. Before we go further, let's understand why we need Spring Boot. And the basic idea of Spring Boot is to build RESTful web services. If you want to know more about what are RESTful services, please, you can read about the RESTful concept as a concept. What does REST stand for? But the basic idea is that if you are accessing anything over HTTP, then that particular component can be built as a RESTful component. And Spring Boot is the most popular choice for building RESTful web services today. And even in fact, microservices, which you might have heard about. So you can build microservices which also run on HTTPs using Spring Boot. So what I'm showing you right now is the official guide of Spring, which you can use to build an application with Spring Boot. It will list down all the requisites which you need in terms of the JDK installations, Maven, and how to complete this guide, etc., etc. You can again use the same Spring initializer which I talked about in the previous session. You can use this to generate a Spring Boot project for you specifically. So all those options are available here. So I've already done that, and I'm not going to repeat what I just did in the previous session, and will directly jump to an IDE where I have created a sample Spring Boot application. And the structure here, you can see the structure would look very similar, with one change, that in the previous example when we were dealing with MVC, we had an src main resources folder, and that src main resources folder was having all the web components or the HTMLs. But since in RESTful web services you do not render the HTML, but you just send back the response. The response body can be pure XML or it can be pure JSON, but you do not send back an view, and that's the main difference between Spring MVC and Spring Boot. That in Spring MVC, you are required to return a view technology. Like in the previous session, we sent a die-my-leaf template, which is basically an HTML. You can also return a JSP, but with Spring Boot, you do not deal with the view technology. And that's the world we are living in today. When you write Spring Boot, you do not have to worry about how this is going to be rendered on the web page, whether it is going to be rendered using HTML or whatnot. What you need to take care of using Spring Boot is to return the right response body, the exact text of the response, and that's it. So with that in mind, the Spring Boot was born, and the structure, apart from that, the structure would look very similar. There's a pom.xml here which will provide all the list of jars and dependencies which are required for this particular project. So you can see all the dependencies here, pretty much the similar ones. We have a starter web, we have a starter test, and we have a Spring Boot Maven plugin. And we have an application file, which is the entry point, again having a public static void main method. So you need to put the @Spring Boot application at the top of the class to make it an entry point. If you don't do this, Spring Boot will not run this class, and Spring Boot will even not run your application. So what we are doing as part of this example, that we are just printing all the beans which are provided by Spring. That's all we are doing. Like I said, it's a very lightweight and an introductory session, so we will keep the logics to minimum. And I'm just getting all the bean definitions, sorting the bean definitions, and just printing them one by one. How do you get the bean definition? You get that with this application context class, which is returned when you run the application. And how you run the application is basically using this line where you say Spring application dot run, and you supply application dot class with any command line arguments which you might want to use. Once you do this, it is going to return an application context object to you, and the application context object can be used to get all the bean definitions by calling this method which says get bean definition names. So that's the basic logic which is being run in the main class. Now we also have a controller, but this time it's not a web controller, but it's a REST controller. So you see, in the previous example, we just had written something like this. It was just a pure controller. But here we have become more specific. We are saying that, hey, this is not a simple MVC controller, but this is a Spring Boot controller, or technically a REST controller. So Spring provides a separate annotation for that, which is @REST controller. So you write that particular annotation on the top of the controller class which you are creating, and then you provide a request mapping similar to what we did in Spring MVC. But while you return it, you do not return a view technology. You just return the raw response. Here I'm just returning a string, but you can return a JSON object, you can return an XML object, or whatever you want to, but not a view technology. That's what I'm doing. Like you can see, there's literally nothing I'm doing in this. It's just a simple string return statement which I've printed here. And that's all the code I have right now here. I just have these two classes. Okay, so that was all about what I have written in the project, and now it's time to run the project. So I have just reached to the location inside my terminal where the project's pom.xml was present, and if I just do an ls, you will see that there is a pom.xml available here, and all the code directories are also available here. So now I will just run this application, and to run this application I'm just going to type mvn spring-boot:run and hit enter. Once I do that, the Spring Boot application is going to get started. And let's go back to the controller and actually the main endpoint and see what we were doing there. I did a sysout here which said let's inspect the beans provided by Spring Boot, and then I was printing all the bean names. And if I go back to the output, I will see the same line being written here, which was around let's inspect the beans. So you can see that message which says let's inspect the beans provided by Spring Boot, and then all the beans which are available in the application context are printed here. So that's the basic idea which I want to give you, that you can actually build a Spring Boot application and you can write your REST controllers, return a string body from it, and once this is run, then you can also run your application from the web browser as well. So let's try to hit that particular URL which I wrote here. So the URL of hello country. So for that, let me just open a new Cognito window, and our application is already running. So if I just say http localhost 8080/, I get this message here which says greetings from Spring Boot. And this is the message which we were sending from the REST controller. So this validates our understanding that we can invoke a REST controller, which is a Spring Boot REST controller, via the same method, but this time we are not getting an HTML, but we are just returning this particular string. Now you can use the string in any ways you want, so it depends upon the consumer. So that's all I want to cover as part of the Spring Boot. Now Spring Boot is a huge topic, and we can spend hours and hours talking about Spring Boot, but since this is more of an introductory session, so I just wanted the concept to get introduced, and remember the value proposition of why you would need Spring Boot. The basic idea is to build RESTful web services or build RESTful microservices. That's the basic idea behind using Spring Boot in your applications. And also remember the difference between Spring MVC application and Spring Boot application. Spring MVC is for building web application. Spring Boot is for building RESTful applications which might not have a web interface integrated with them at that moment.
Let's get started with our demo of a project which is using Spring Boot to build a RESTful web service. So a RESTful web service is nothing but any endpoint which you can access or you can consume the data from via an HTTP layer or via a simply web layer, because most of the web traffic which we deal with is built on HTTP. So to take an example, if you go to any website where you sometimes see on the top right corner, you see today's weather. So how is that today's weather coming in? It's coming in via a REST web service. The website which you are accessing is basically hitting an HTTP endpoint, which is where the weather application is sitting, and it asks for the weather data, and that REST web application just returns the data, and that's how the website is able to show you the current weather. So RESTful web services are everywhere, and they are the most popular way to build applications today, where you just build your RESTful web service and you expose an HTTP URL. And then the consumers need to just access that HTTP URL to consume the data from your application. And you see, this makes it very easy because there is no data type restrictions. There is no tight coupling here. It's just an HTTP endpoint. So that's the basic idea. And we will look at a project where we will be using Spring Boot to build a RESTful web service. And then we will try to run that web service to save some data and also to return some data. So here on the package explorer, you see I have created a project called REST service. And let's just walk through the structure of it, and then we'll go into the details of it. So we have an src main Java where I have a package, and I have a bunch of classes here. And before we go to the classes, let's first also access the dependency file, because every project needs some dependencies, some jars to execute it. For example, Spring itself is basically a jar. So you need to include the Spring jar in your project so that your project can become a Spring project. And there are generally two dependency tools. One is Maven and one is Gradle. In this particular project, I am using Maven dependency tool for downloading and managing the dependencies which are needed to run this project successfully. And the way you will find if it's a Maven project or if it's a Gradle project, for a Maven project, you will see a file called pom.xml. And if it's a Gradle project, you will see a .gradle file. That's how you can spot whether the project is using Maven for dependency management or it is using Gradle for dependency management. So let's open the pom.xml. Since it's an XML file, it will be a bit verbose, but if you just read it piece by piece, it will become easier to understand. First of all, since this is a Spring project, I need to include the parent dependency, which brings a lot of good defaults, sensible defaults from Spring Boot automatically. And this is the jar name. This is the artifact ID, which is Spring Boot starter parent. So any Spring Boot project you are starting, do include this parent. This parent is basically bringing all the dependencies from some other jar, and you can make your project as a child of this particular parent. So all the Spring Boot projects have this as a parent as a standard practice. After that, you provide your own details in terms of what is the package name, how do you want to see the jar name, and what is the jar actual name, what is the jar version, etc., etc. You also set the minimum required Java version to run this application. And then you, in the dependency sections, you provide all the jars which you need to run your project successfully, both compile and run your project successfully. So we added the Spring Boot starter web dependency, which basically brings all the dependencies around making a controller or making a repository, context component scan, all the interesting features which Spring provides get wrapped up inside the Spring Boot starter jar. And you can actually go to the MVN repository and have a look at what all classes it provides. It's a lot of classes. So I'm just telling you in a brief that it provides all the RESTful functionality. Then you have the next dependency as Spring Boot starter data JPA, which is going to enable this project to also have a database. And if it has a database, then you need Java to talk to the database. And the way Spring suggests to talk to the database is via using the Spring Boot Data JPA library. We will see this how this library can be used, but basically this provides ways to represent your Java object in the database. And then you need to also add the actual dependency of the database. And in this case, we are using an in-memory H2 database. So I'm not using an external database like MySQL or Oracle or PostgreSQL, because that will just make more configurations more complicated. I just wanted to keep it simple. And generally, you in this H2 database, you can easily access by adding this dependency, and it will be an in-memory database created for you. Then I've also added Spring Boot starter test here, which will be used whenever you are writing unit tests, and you must write unit test for your project. And then we need to add the plugin so that Spring Boot can run this project. That's all I have in the pom.xml. Now let's move to the interesting part, the Java section part. Let's start from the main class. So this is how the main class looks like, where you just create any name with the class, and then you add a public static void main method. Inside the public static void main method, you call Spring application dot run. And this run method is basically going to run your application, and you just provide the same class name which you just wrote here. So you just say dot class. And if you're supplying any command line arguments, it can interpret that command line arguments as well if you want. So you'd always need an entry point in an application, and this is the entry point which Spring Boot supports. And this is, if you see this code, this is just normal code. To make Spring be aware about this class being treated as an entry point, you need to add @Spring Boot application annotation on top of the class. This is one of the annotation which is coming directly from the Spring Boot library. You can see this import. So once you add this, then only Spring will be able to treat this class as an entry point. Otherwise, Spring doesn't know where to start from. So when you run Spring, it will try to find a class with an annotation Spring Boot application. And then inside the class, it will try to find a public static void main method. And once it has found both of them, then it will just run the application. So it's very simple, nothing fancy here. And what we are dealing with here is a student object. So we will try to insert a student object, and we will try to retrieve the student object. So if you ignore these annotations which I've added, it's just a pure POJO. It's just a plain old Java object. You create a student class. Let's ignore this field as well for now. I'll just come back to this annotation in this field. But this is just a student class. It has 3 fields as name, age, and address, an empty constructor and a parameterized constructor, and some getters. Intentionally, I have removed the setters because generally, whenever you are building any enterprise grade application, you would like to keep your objects immutable. Means once they have been created, you would not like somebody to allow to change the values of the object. This just makes programming much more easy if you treat all the objects in your application as immutable. That's why I have not added setters here. It's just considered a good practice. So apart from the standard things which we have already seen, there are 2 things here which I want to talk about. Let's first talk about this one. So @entity is the annotation which is coming from JavaX persistence entity. And this makes Spring Boot save this particular object into the database. This is the annotation which you need to put on your class so that Spring Boot knows that this class represents a table in the database. So you need to add this to make sure that this represents a table. Second thing, a table will have a ID. It will have sort of a primary key. So I've created a new column called ID, which is basically representing the student's roll number or something, or maybe a registration number. And here I'm using a couple of more annotations. If you see, these annotations are also coming from Java.x persistence library. And these annotations will basically allow a new ID to be created every time you create a student object. So you don't have to specify the value of this ID variable. Spring Boot will automatically generate a new ID value every time you create a new student object. And how does it generate? You can provide the generation type as well. So currently I've just set it as automatic, but you can set it as identity, sequence, or controlled by table. You can also see the explanation of each of these here, but I've just kept it as auto, which basically let the persistence provider pick any appropriate strategy for the particular database. In our case, the database is H2. So that's about the entity class. Let's call this as entity class. Now let's move to the repository. So you need a repository class. Like I explained in that 3-tier architecture, you always need a DAO layer or a repository layer to store your student object into the database. So we have enabled the student object to be saved, but we need a handler which can save this particular file, this particular object into the database. And the repository classes are the classes which will allow you to do that. So you create a very simple interface. You name whatever you want to name your interface as, and then you say extends JPA repository, the type of the object, and the unique identifier of the object. So the type of the object is student here, and the unique identifier of the student object is the ID, which is of type long. So you need to just supply the types: type of the object, type of the primary key, or the type of the unique identifier. And this annotation is coming from Spring Boot. You can see specifically Spring Boot data library, which we added. So you just need to create an interface, extend it from JPA repository, and make sure that you add this annotation as well. Spring heavily uses the concept of annotations, and this will help Spring understand that this is a repository layer class, and it will apply some more metadata to this class while this class is running in the JVM. So what happens here? You just created an interface. You did not provide any method to create or any method to delete or any method to get a student object, because all of that is automatically provided by Spring Boot via the JPA repository class. If we go inside this class, and if you scroll down, you'll see the find all method, find all by ID, save all, flush, save and flush, delete, etc. And if you go further up, this also extends the paging and sorting repository, which provides pagination and sorting facilities. But the interesting one is that paging and sorting repository again extends a CRUD repository. And if you go to the CRUD repository, you will find all the basic methods to save an entity, save multiple entities, find an entity by the ID. That's why it needed that long type to make sure that it can execute this method. You can check the existence of an object, find all the entries, find all by ID, count them, delete them. So all the basic CRUD functionality. So we call them as CRUD because the reason it is called CRUD, because create, read, update, delete. That's basically the generic acronym. So because this CRUD repository provides all the methods and their implementations automatically, we do not need to write any code at all. So that's why Spring Boot is so awesome, and that's why Spring Boot is very popular, because it's zero code in the repository and you still get all the CRUD functionality. So that's about repository. Now we have covered the entity class, we have covered the repository class, we have covered the entry point class. Now the only thing which is remaining is the endpoint, the HTTP endpoint, which I talked about. And that you can create by creating any class. Generally try to suffix it with the controller so that your core developers can easily find this class. And make sure that you put @REST controller annotation on top of it. This annotation will allow Spring to treat this particular class as an endpoint class. Then you can auto-wire the student repository. So if you remember, I talked about the whole dependency injection and inversion of control. So here dependency injection is in action. So here you're just telling student controller to auto-wire the student repository. And now what will happen that at runtime, student controller, or actually Spring, will automatically create an object of the student repository and supply that object of student repository to student controller. So you as developer do not have to create an object of student repository explicitly. That's the benefit, and that's how the dependency injection is working, because you inverted the dependencies now. The dependency is just injected into the class, and as a developer, you don't have to take control of creating the objects. It's the Spring which will automatically read the auto word annotation and will automatically supply an object whenever it is required. Then I have two methods here. Since we are talking about HTTP endpoints, so I have represented a post method here and a get method here. The way you will write a post method is via @post mapping annotation, and then you can provide the URL path on which somebody should call your endpoint to save something. So for example, somebody can call it HTTP localhost 8080/student/create. Whenever they hit that URL, the control or that request will directly hit this particular method. Why? Because you have provided the URL mapping here in the post mapping annotation. So since it's a post method, there would be request body. What is the actual request body which the client is sending? And you can represent that request body with the @request body annotation, and you can provide the type of the request body. And here I'm saying that, hey, if you want to access this particular URL, yes, all good, but you need to supply me with a text representation of the student object or a JSON representation of the student object. And then inside the method, I'm calling student repository dot save, which is going to save the student object which is coming in. So you see there's a lot going on here. I will show you how the student is represented in the request body as well, and then I will come back to how it got converted from JSON to Java. But this is how you can store this particular student object. You can hit this API as many times as you want and keep inserting a new student object every time. Then if you want to fetch a particular student, then you can do that by supplying the /student. And then in the curly braces, there's an ID written here. So basically you can supply the value of the ID of the student. So generally there would be another method here, which would be find all, to see all the students and with their ID, and then you can pick a particular student's ID, supply that student ID value here dynamically. That's why the curly braces supports dynamic value. So here it can insert 1, 2, 3, or whatever the student ID you want to fetch the value for. You provide that value in the student/ID, and all good. Then if somebody is hitting the URL with saying localhost 8080/student/1, then student with the ID 1 will be returned from the request. And you need to put @get mapping to make sure that this method is treated as an HTTP get method. And you can provide the type, you can say get student, and here this dynamic value is captured with the @path variable, because you need to know the ID, right? Whatever ID somebody has supplied it in the URL, you need to capture that IDE and then use that IDE for calling the repository. So you can do that by using the @path variable. So here I'm just saying whatever ID is coming in, I will store that value inside this IDE. Once I've done that, then I can again call student repository dot find by ID, which is again a built-in method provided to me by the CRUD repository. I can supply the ID, and this actually is going to return an optional object, which is an object which may or may not contain a value. So it's just a defensive programming style. So this will return an optional, and you can call a get method to return the actual student object. This will return an optional of student. So optional of student means that this optional object may have a student or may not have a student. Why did Spring do that? Because the ID somebody is supplying, that ID can be invalid also, right? So optional object takes care of that if there is no student found, then you will not get a null pointer exception. And if there's a student found, you can return that. So it's just a defensive programming style which Spring has adopted by returning an optional of the student object rather than directly the student object. But if you're confident that this particular optional of student object does contain a student object, then just call optional.get, which I've called here, which will return the actual student object sitting inside the optional object. You can read more about the optional object and its usage from the official Java docs, and there are tons of examples available on it on internet. So this is about the controller. We have covered all the classes. Now it's time to run the application. So you go to the command prompt, you go to the particular file folder location, and there you just say mvn spring-boot:run. So I just hit enter, and this is going to run the application. It's going to spit some logs here, and if everything is fine, you will not get an error, and you will just be getting a message saying that application got started. And it's running on Tomcat localhost 8080. with no context URL. So this is not a web application. This is a RESTful web service, right? This is a RESTful service. This is not a web application. So there is no web interface. So how do you access this? You just have an HTTP URL. So you can use any of the REST client available on the internet. There are probably hundreds of different REST clients available on the internet. You can choose any one of them. I am using advanced REST client, which you can also install as an extension from the Chrome browser itself. So if I just open the Chrome browser and I just say REST client, if you just write this and hit enter, you will get many different options. And the first option you get is from Google Play Store's App Store. So you can go to the App Store, basically the Chrome Web Store, not the Play Store, but the Chrome Web Store, and you can just install this. Since this is already installed, you can click on Launch App, and it will open this interface for you. So this is this is not a tutorial for advanced REST client, so I'll just be quick here. You can choose the method type which you want to hit. So let's say I want to do a post, and then you can provide the URL here. So remember the URL which we put here in the controller method, this has to exactly match. So HTTP localhost /student/create should be the URL. So let me just copy paste this one here. Okay, so the URL is good here. It's a post type of method which I want to do, and I want to hit this particular URL. Now I need to supply the content type and the body. So in the content type, you can choose application JSON because I'm going to supply a JSON object. And in the body, this is how the JSON object looks like. Advanced REST client also provides a nice visual interface to basically create this JSON. If you are thinking that JSON creation is very tough, it's not actually tough. It's just curly braces. And then you put key and value, comma, let me just put an enter here so that it's more readable. So you just put curly braces starting and end, and then you just put key value. You put a key, which is the variable name and the variable's value, variable name, variable value. And these keys have to exactly match the student's properties. So the student.java had this name, age, and address, right? So it has to exactly match. Otherwise, this request will fail. So this is all good. Now I can send this particular request. When you click send, it is going to hit my Spring Boot application, which is running on localhost 8080. It is going to call the student/create method. It is also going to convert this JSON into a Java object because here I'm supplying a Java object. So it will convert the JSON, which I'm sending from here, to Java object automatically, and it is going to automatically save it here because I've called the repository.save method. So let's hit send here. Once I hit send, I get a 200 OK. It means everything went fine. And in the response header, I get the object back because I have returned the object here. You see, this save method is going to return the same student object which you created. So everything is good here. My object has been stored here. And now it's time to fetch the object. So it has already been saved into the H2 in-memory database, and you can obviously go and connect to the in-memory H2 database and have a look at it. But for simplicity, I'm just going to do this here. And let's say the first object is generally added as the ID1 by default by the H2 database. So let's hit this particular URL. When I hit this URL, it is going to hit the student controller here. And in the student controller, it is going to hit the getStudent method, which is having a student/ID URL, and it is going to find the database with that ID. And if it finds a student object with that ID, it is going to return that. So let's confirm that now. So let's hit this particular send button, and it is going to hit a get request with this particular URL. Spring Boot is going to find if a student with the ID 1 exists in its database. So once I hit send, I get a 200 OK. And you see in the response headers, I get the same student object back, which I added. Let's try with 2 now. Let's see what happens. I see 2 and I get 500 internal server error because there is no object stored in the H2 database of the Spring application with the ID 2 yet, because we only inserted one object. That's why only one student object is there, and the first ID which H2 database created for it automatically was 1. So when you hit for get request with a student ID 1, you get the object. When you put any invalid value and you hit this, you get a 500 internal server error. You can also make it look nice by not sending the 500 internal server error and sending a nice exception from the backend. So from here, you can also send a nice exception that if this object is not found, you can say something like that, or else throw, which is again an optional object. And here you can supply a particular type of exception which you want to supply instead of just throwing 500 internal server error. But that's just additional thing, additional defensive programming you can do. You can add more and more validations and constraints into this project as you build this project in a more complex paradigm. So this is basically what I wanted to show you, that that we have created a Spring Boot application. We have connected it to a database. We have created also an HTTP endpoint with student controller. We ran that application. We used any random REST client. In my case, I used advanced REST client. And we first did a post request. We provided the exact URL. The URL has to exactly match with the controller URL. And then the body, the request body also has to exactly match with the student object's property, especially the case of the names have to exactly match. So if all this matches, then you will get a response back that the object has been created. If you want to fetch the value of the object, you're going to use the HTTP GET method, and you again provide a URL which has to exactly match to some method in some controller in the Spring Boot application, which is running on localhost. And if you provide the right ID, you are going to get a valid result. If you provide an invalid ID, you're going to get a 500 internal server error. And from here on, you can make this controller as robust and as mature as you want. You can add find all method. You can add a update student method. You can add a delete student method. You can have all different kinds of filters. Like, for example, return to me all the students starting with the name A, or return all the first students with the roll number 1 and 100, or between 1 and 100. So you can write as many endpoints as you want and build this application in with as much maturity and as much complexity as you want.
And with that, we have come to an end of this full course tutorial. I hope it was informative and interesting. If you have any question about the topics covered in this video, feel free to put them in the comments section. Our team will help you solve your queries. Thank you for watching, keep coding, and stay tuned to SimpliCode.